Create without limits with precision mobile workstations. Maximum power, speed, and performance when and wherever you need it. So you can perfect every pixel. Break ground in unexpected places. And make the most extraordinary ideas a reality. Discover your next big idea. Precision mobile workstations. Create without limits.
When's the last time something moved you? Was it a flash of beauty? A twist of phrase? A bit of brilliance that blew your mind? What if you could move people like that? And what if you could do it with shapes, sounds, design, and movement? When it comes to motion design, we believe everyone deserves the chance to move from novice to superstar. So we've created an online place for that to happen, so no matter where you are, we're there too. We are opening up worlds of possibilities for our students, and we're kind of obsessed with doing it well. Our teachers aren't just skilled working professionals, they're also the top motion design experts in the industry. Our critiques aren't vague and generic, they're valuable insights about your work. Our classes aren't easy, they are intense and effective. A tidal wave of knowledge. And our students aren't faceless usernames watching talking head instructors. We're a tight-knit community of highly driven learners, filled with global collaboration, inspiration, opportunities, and plenty of fun characters. At School of Motion, we take a full art education, strip it down to the essentials, and supercharge it with real-world grit. And we're equipping our students to do amazing things for some of the best brands and studios out there. In fact, this thing you're watching right now, and even this, was made by School of Motion alumni. Now it's your turn to create something truly moving. And we're ready to help you do it. Because the things that move you forward, move us too. School of Motion. We're not just a school, we're a movement.
Toolfarm makes waves with amazing deals and fast and knowledgeable customer service.
Swim on in for incredible deals on software and plugins at Toolfarm.
I decided to come to Camp Mograph because it seemed different than the bigger conventions.
Being able to talk to people face to face.
Do archery, canoe, kayak.
Outdoor basics, getting back to nature.
Back to basics.
The storytelling class was phenomenal.
Classes that feel really intimate.
Drawing with EJ, that's been my highlight of the whole day.
Sometimes we get caught up in the technical, like how to make this keyframe move, that we forget to take a step back and look at the bigger picture.
Being a motion designer rather than doing motion design.
It really brings out that inner child.
I have to go to this because it's kind of like going back to what I love.
A place where you get to be a kid again.
This is not crowded whatsoever.
There's not as many people. Just get out of your comfort zone. Camping isn't as bad as you think.
This is my new go-to event every year.
My bunkmate is Paul Bapp, and that's where else do you get that?
You're not worried so much about the render times, just having a good time. Cut it.
We're here with you today.
All right, everyone, welcome to day 3. We've got one more day to go after this, but this is another big day. Amazing lineup here, and kicking it off is one of our proud sponsors, Dell. So check it out.
Hi, everybody. Great to be with you, talking to you today. My name's Gary Radburn. I'm the Director of Virtual Reality, Augmented Reality, Virtualization and Remoting here at Dell Technologies. We're finding ourselves in a very strange time in the world at the moment where we're trying to do more with less. We're trying to enable a workforce to work from home that we haven't tried to do in huge numbers before. And we're now trying to look at new technologies about how can we actually enable our workers to be as efficient and productive as they were when they were in the office even now that they're working remotely in their own homes. So what we're going to go through today is a few of the techniques and some of the technologies that we can actually use to accomplish this. And as we go through, I'll try and explain some of the technology behind it, where it's come from, and why it's useful in terms of video production, high-level graphics, and workstation type scenarios. When we're trying to use standard virtualization for VDI, for instance, for office applications, there's not really that high a graphics component or some of the accuracy that's really needed for video editing. So these techniques and these solutions will actually enable you to do more with less, so having the equipment that you may already have, and how do you maximize the use of that in the situation that we find ourselves in, and also how do we remote in for high-powered graphics users and still maintain their productivity, try and minimize the latency, but still give them that near workstation experience, even though they're not co-located with the data. So let's move on. So the agenda, I'm going to go through how did we actually get here with the workstation evolution. How have CPUs progressed to a point now where we really have a lot of capacity which might be going wasted, not being utilized fully, and how can we actually use that inside of where we are now. So what are we trying to solve? There's going to be some key things inside of that. Working from home actually has a lot more inherent challenges than just how do I have a workstation in my home where there could be insurance implications, you've got family, pets, things like that running around, and then you've got high-powered, high-cost equipment inside of your home. So how can we mitigate some of those other risks that we have inside of home working? Then how do we actually accomplish this? How do we actually get people working from home? So that's the shifting pixel side. And then we'll move on into how can I now take that technology and allow multiple workstation users to be on a single workstation, for instance. So a single workstation back in the data center, but still having multiple users access it at any given time. And then moving from just a few users to how can I really maximize the number of users on that workstation and still keep them all productive. And then, of course, right at the very end, the big reveal about how do we actually accomplish this and what technology do we use to actually do this. So the first thing I'd like to say is we've had a huge advance in the number of cores that are available on a single CPU. Back in the old days, it was a single core, then it went to dual core, quad core, and now we're really racing ahead now, and there seems to be this insatiable desire to have more and more cores on a single CPU die. So inside the workstation space, especially things we have dual socket machines as well, you could actually have 56 cores and 112 with hyper-threading inside a single workstation box. Now, the challenge that we actually have in many applications across the board is that most applications become single-threaded. They've grown up over time, they've been monolithic, and we need to maximize the use of our machines inside of there, because if we've only got one application running and it's a single-threaded app, we've got a lot of cores that are sitting there that aren't being utilized and just going to waste. So we will see a technique of how we can actually use all of those cores inside of it. The other thing I would say as well is, like, when we're talking about media entertainment and video production, etc., there's a lot of rendering that goes on inside of the system as well. Rendering tends to be more multi-threaded. So is there a way perhaps that we could easily migrate from one system to another system at different times of the day? So if our workforce is working 9 to 5, let's say, if we wish, but 9 to 5, let's just take as a norm, then after that time, the workstation is now completely idle. What would happen if we could actually repurpose that workstation very easily overnight to form part of a render cluster? So we're now maximizing our resources for 24-hour operation inside of a system that's actually validated to work for 24 hours and maximizing our use of our resources, even though we're all in disparate locations. So we'll be seeing how to solve that one. What are the real challenges we're trying to solve? So we're trying to get people working remotely. That's on the left-hand side. Getting them working remotely, but getting them working securely and remotely. The last thing you want to do is have users taking all of your data home. Now, with Office applications, as I've said, it's very easy just to shift the pixels across the network and then have your email on the server somewhere that doesn't come down locally to the machine. If somebody's actually working on their next video production, very large files, do you want them actually copying it over the network, which is laborious, takes a long time because of the amount of data that's coming across? Do you want to ship them out a hard drive or a USB key that actually has all the information on it so that they can use that? And then you start to lose control of your data, because what happens if that gets lost in the post, gets lost in a car park or whatever else? You could have your IP actually compromised very, very easily. So if we can actually offer people the ability to be able to work from home, but to actually locate the actual compute resource and the data inside of the data center itself, which is the most secure location inside of your organization. If it's not the most secure location, then there's a different discussion we can have. But if you've got the data co-located with the workstation remotely inside of a data center, and now your local user's PC at home just becomes that window into that workstation world, we're now not transmitting any data anywhere. And obviously, if you're using extremely large data sets, as you would be with video files, then to co-locate the computing resource with those video files makes a lot more sense as well. So we're actually solving another problem. Even though the major one we're trying to do is the work from home and enabling workstation users, we're actually giving performance improvements for that working from home and securing the data all in the same type of solution. The other thing about centralization is it makes it easier for IT managers to manage individual resources. They're inside of the data center, they can remote into those, they can access those machines, they can update them, they can patch them. They don't have to go to each user's house to actually patch a PC or a workstation. If something goes wrong with the hardware, they don't have to go to somebody's house to go and fix that workstation with the social distancing that we're currently having to practice. So if everything is actually in a data center, it makes it a lot easier for an IT manager to manage all those assets, to fix those assets, and patch those assets. The other thing that we have is you can enable collaboration. So now everything is centralized. We can actually have users worldwide accessing those resources as if they were local. So we can have everybody accessing that data. Now we're having things like we're having the resources being worldwide, the gig economy, as it's called, where we could actually get the best people worldwide all working on the same assets that are in a central location. So now everybody doesn't have to be in the same building. Well, we're not really allowed to at this current moment in time, but you're not in the same building, but you can still collaborate effectively. And it now really gives you a worldwide platform for getting the best resources worldwide to work on a particular project in a secure fashion. So how does this actually work? So this is how we actually shift those pixels. We've got a very good partnership and have done for a number of years with a company called Teradici. They actually manufacture a hardware card which can go into the host system inside of the data center. And what it is actual hardware based, doesn't interfere with the host whatsoever. So all of your CPU cycles are being used for the programs you want to run, rather than being used for the compression of the data, the security of the data across the network. But what we can do here is you plug the hardware card into the GPU direct. So that direct connection now takes the output of the GPU, puts it into what we call the host card, it compresses it, sends it across the LAN or the WAN, and then we decompress it at the other end. So all we're doing is shipping pixels to the end user. All of your data is staying local in the data center. All of your compute resource is in the data center. You're just using what could be a zero client device, which is what we have as in the 5030. So that's a hardware decompression of that data going across. So again, very, very efficient. Or we can use a software client. So there's a software client that you can run on any PC to decode that data if you don't happen to have a zero client available. You can do multi-monitor on it. There are some limitations with the solutions, one of which is the fact that you've got a 2560 by 1600 resolution maximum, single monitor, or I can actually have a dual display. So I could have dual displays of 1920 by 1080 on that card. Or if I actually have the quad host card, which allows us to do 4 monitors or 2 2560 by 1600. So we can still be very, very efficient inside of our use of our resources, whether we have a dual host card or a quad host card, depending on what our end client requirements are. Now, we can look at that and say, okay, there's a limitation there on the resolution, the highest resolution, because a lot of customers now are working at 4K resolution. So how do we actually move on from there? But one of the best things about the host card is that should the PC or workstation lock up and it's remote, then you'd normally have to log a support call for somebody to actually go into the data center to actually reboot that PC physically, and then it would come back up and then you can log back into it again. If you have a software lockup, that's generally a bad thing if you're trying to remote in. The advantage of a host card solution is because it's hardware based and because all of our precision workstations actually have the remote power connector on it, you can remotely power on, power off and reboot your workstation even if the OS has hung. Right? So that gives you a distinct advantage of having a software based solution, but you are then perhaps constrained depending on your workflow inside of your video production, whether the resolution is high enough for what you actually need. So there's also a software solution which doesn't have that hardware component of the reboot that I just mentioned, but does now allow you to do 4K resolutions. Right? So you can now have multiple monitors running at 4K. The hardware-based solution, so the hardware zero clients, still have the same limitation of their resolution because it's all based inside of firmware. They can't deal with that 4K resolution, but you can interface it with a software host, which is the point of this slide. So you can still do hardware to hardware, hardware to software, software to hardware, software to software in terms of all those different connectivities. But a software solution is going to give you that 4K resolution. If you've got a client that supports that 4K and has AVX2 extensions inside of the CPU, that's one of the caveats, it can then decode that 4K stream and then connect to a 4K monitor to give you that near workstation experience working on a 4K workload at home. The great thing about PC over IP as well, which is the transport for it, is that it uses different codecs depending on what's on the screen, whether it's graphical or textual. So it makes the most efficient use possible of the bandwidth on your network. And it also has a build to lossless option. So over a couple of frames, if you need absolute accuracy rather than just visually lossless means I can't tell that there's any pixels that have changed. But if you're looking at color space and things like that, sometimes you can't detect that. So visually lossless is one side, but build to lossless will actually build to a completely lossless screen to mimic what you would have had if you had a local connection to it. And PC over IP allows you to do that level of lossless support. Now, let's kick it up a notch. When we start to go, okay, you mentioned all of those cores, Gary, at the start, where I've got a lot of cores inside my workstation. My applications might not be making most efficient use of it. How can I actually use those more effectively? Well, virtualization is another hat I wear inside of this. And now that GPUs have really become of age and have a lot of power, even on a single wide card, you could take something like our Rack 7920 2U workstation, rack mount that inside of the data center. You can put 4 GPUs inside of it. So let's say, for instance, RTX 4000s. So nice, powerful cards, single wide inside of that. And then I could create a virtual machine for each user inside of the rack workstation. I can dedicate a number of CPU cores to each user, and I can then pass through that GPU into that virtual machine. That means every user will have dedicated number of CPU cores and will also have a dedicated GPU that they have all to themselves. So this will enable a very good workflow for 4 different users on a single 2U workstation, each of which has dedicated resources with no slowdown, no perception of difference to a local machine inside of it, and you can get very, very effective use of your resource there. So by now virtualizing, having those 4 GPUs, I've now got 4 users running out of one workstation. So by utilizing the number of cores in my CPU and spreading those out, it becomes very, very good use of that resource that you may already have inside of your data center. To take it to the next level, then what happens if I want a lot of density? So I want to extend the reach of my workstations. There were users perhaps in the office who would borrow somebody else's workstation, somebody who's signing off on drawings or videos or particular dailies or whatever else inside of there. And they didn't need a workstation full time. However, they'd go and borrow Bob or Sarah's workstation just so that they can actually do sign off and then go away and do the rest of their work during the day. Being at home now, you don't have that luxury of resource sharing with other people. So perhaps you actually want to give somebody the power of a workstation on an occasional basis. Or you want to consolidate down when there's a team that's working and perhaps they're doing light level GPU work. And then you can split a single GPU over multiples of users. So with NVIDIA's RTX 6000 and RTX 8000 cards that have come out, the Quadro cards, you can now use virtualization of the GPU, so vGPU stack inside of there, and split that graphics card out to 24 or 48 users as a theoretical maximum. Normally, you probably only split it between 4 and 8, depending on the workload that you're actually doing. But you could put 3 grid cards or the RTX 6000, 8000 cards inside of the rack 7920. This is going to give you some great consolidation numbers, enabling people to use a workstation on an occasional basis or using it on a permanent basis and dedicate the entire card to them, or just put fewer users on that one card. So you've got a very powerful card. Not everybody is going to be thrashing the CPU at the same time. So it works in pretty much the same way that CPU virtualization has done over the years and is now doing it in the video format. So now we can get all of those same connections. We can use the software stack from Teradici, the client access software that they call it there. And you can load that onto each virtual machine, and you can then have the equivalent of all of these VMs going out to a lot of different users, all sharing the resources inside of that. Now, I mentioned earlier about reappropriating and converting it to a render farm or whatever else. Now, imagine we've got this scenario of these virtual machines during the day. What I could then do is simply through my virtual management platform, I could then change the virtual machine that boots up into that particular system overnight and make that into a node in a render farm. So if I then booted it up into even Linux, so people using Windows during the day perhaps, then you boot it up to a Linux image that has a Linux render farm for overnight use, and then in the morning reset it back so users can then log back in and do their daily work. So now I've got maximum flexibility of my resources inside of there as well to enable not only the users to be flexible, but the hardware to be flexible as well in terms of its use methodology. So just a quick look at the architecture. I'm not going to delve into this too much, but what you do is you run a virtualization layer on top of your hardware. So in this case at Dell Technologies, we use VMware. So that runs ESXi as the hypervisor on there. The vCenter management layer then runs on top of that. And then your VMs run on top of vCenter or are managed by vCenter. So that allows you to control all of that infrastructure. And then underneath inside of the hardware, because you're abstracting the hardware layer using the hypervisor, we've got our RTX GPUs inside of there, whether that be the pass-through ones or the vGPU RTX cards. We were sharing our memory in between our virtual machines, our network interface cards, the CPUs and the storage, and then we're sharing all of that out in a very, very efficient way with near bare metal performance, and inside of that to share it across multiple users. So this is a great solution. We haven't done this as an out of the box. You can't just go and buy one item. It's got all of this pre-installed. This is just ideas that I'm trying to give the community at large to do things more efficiently in the troubling times we're in. The Teradici cards are obviously, we partner with them very heavily, as I said, and they're available inside of our systems as standard. When we get to the virtualization layer, then that becomes more of a solution type focus where it can be built. And certainly if you want to have more conversations about it, then I'm more than happy to field questions or for you to drop me a line, and we can actually talk more in depth about it and try and work out what you really need inside of your solution to make your company more effective and to be able to be better positioned to have multiple users, managed users, still working on workstation graphics, workstation style performance, but working remotely at home. And if you're already using VMware, then you can actually leverage that infrastructure that you've already had and that management layer to bring to life what I've just gone through here. And so with that, I'll wrap up. Thank you very much for listening. It's been a pleasure to have this time with you. And please be safe. Take care.
All right, folks, welcome back to C4D Live. Thanks again, Gary, for that presentation. I know there's a lot of information working remotely, and we did have some questions pouring in. So thanks so much for being here and sponsoring the show.
Thanks for having me.
Yeah, so we can dive right in, and somebody was wondering what's the strongest PC. So in your lineup, power and performance, everybody's about that. What do you got?
Okay, so top of the range is going to be the Dell Precision 7920. It's the biggest workstation that we do in a tower format. It's also available in the rack format, as you saw through the presentation. Dual CPU inside of it, and goes up to terabytes of RAM inside of the system. Wow. Massive expandability. I mean, it's really the flagship product inside of there. Multiple GPU support if you want to use it for AI, deep learning, you want to use it for graphical rendering, it can do the whole kit and caboodle.
Awesome. And what's the model again?
The Dell Precision 7920 Tower.
7920 Tower. So that's what is the strongest you got in the lineup. All right. So another question, and this is kind of good because it's in the world of VR. So when will we see a new version of Dell mixed reality headset?
Yeah, that was an interesting one. That was always targeted at the consumer marketplace when it first came out, but it really lit the fire underneath the interest inside of virtual reality. Unfortunately, that headset is no more in the mixed reality space. We found out in the commercial side that customers were looking for more accuracy in the tracking of the controllers. So when you look at some of the solutions on the market that have lighthouses, then you have sub-millimeter accuracy. And we've now partnered with HTC with the Vive headsets across our entire range for promoting that inside of commercial organizations, basically because of usage, the end user license agreements, the amount of support that you need to get that. So if you need next business day or quicker, you can actually get that on those headsets rather than consumer level ones. So we still are heavily in the world of VR. It's still growing incredibly rapidly. And as I say, we're now partnering with who we believe are leaders in the field.
Awesome. Yeah, and I think during this time, it's really crazy because I'm sure a lot of people are moving more towards virtual spaces. So that's something that is definitely there. Someone said just virtualization is laggy. You want to talk on that a little bit?
Yep. It's as laggy or as speedy as you want to make it. If you just take it straight out of the box and you create a couple of virtual machines, get some GPUs passed through into there or use virtualized GPU technology, then if you're trying to do real-time things, then yeah, you're going to end up with some lagginess in there. You might end up with crackling audio. You might end up with stuttering of the graphics. Depending on the encoder and the bandwidth you're using, you might end up with some pixelation that then rebuilds to a proper screen. There are some areas in there which you can tweak, but just to give the audience one or two pointers. I don't want to go into a new session in how to tweak virtual machines. Right. But there's latency settings when you create a VM. If you're using VMware with ESX 6.7 and the vSphere management interface, you can actually set the VM to be dependent on high latency. And so if it's highly dependent or latency sensitive, you can set that setting to high. Then that will start to reserve CPU for that machine. It will actually reserve memory for that machine rather than using the pooling on demand effect, which is what causes some of the lagginess where it dynamically adjusts. You actually have that amount of power on tap for the machine at all times. And that really now starts to getting you up to 4K at 60 frames a second type graphics inside a virtual space.
Wow. Okay. Yeah. So virtualization is laggy if you don't have it set up right.
Pretty much, yeah. Yeah. So my car's pretty slow unless I put it into a higher gear than first.
Right. Yeah. Okay. That makes sense. Yeah. You gotta tweak it a little bit, folks.
Exactly.
There's some tweaking in there. I think just with everything, right? There's always a little bit of tweaking. So somebody was wondering, they have a 1080 Ti, but feel their PC isn't fully utilizing it. Is there something I have to do to fully utilize all the GPUs?
Yeah, I mean, that really now comes into application dependence and what you're actually doing to feed it. So if you're using an application that's single-threaded, as I mentioned in the presentation before, then depending on the clock speed of that thread and how fast you're actually feeding that graphics engine, you may actually find out that you're CPU limited, that you can't feed it data fast enough because the 1080i is a very powerful card. So if you haven't actually got the lanes feeding it or the amount of information coming in, it's going to be sitting there, twiddling its thumbs, waiting for more data to come in. So you can either feed it multiple threads, and that depends on the application, or you can feed it information faster and process it faster so that you're actually filling up its buffers so that it's eating all the time with the data.
Yeah, it's always, I always look at it like plumbing, right? It's you can only go through your smallest pipe, so depending on where it's at, that can be anywhere in your buffer.
And the great thing is bottlenecks move around inside the system, so you then fix the GPU one, then it might be storage, and then it's it's all good fun.
Yeah, it's all good fun. Awesome. Well, I think that actually is the majority of the questions that showed up here. Thank you so much for joining us on the show. And if people have more questions, where should they go? Where's the best resource for them?
Well, we've got several sites. We've got Dell.com, obviously, and then for the broader family with VMware inside of it as well, then we've got DellTechnologies.com as well. So if you've got any questions, have a look at those sites, and feel free to ask questions as we go through.
Okay, awesome. Thanks so much. And we will be back with our next presenter of the day, Wukash. So stay tuned. If you guys are into FUI design and future interface, you're definitely going to want to check this out. Thanks, Gary.
waves with amazing deals and fast and knowledgeable customer service.
Swim on in for incredible deals on software and plugins at Toolfarm.
When's the last time something moved you? Was it a flash of beauty? A twist of phrase? A bit of brilliance that blew your mind? What if you could move people like that? And what if you could do it with shapes, sounds, design, and movement? When it comes to motion design, we believe everyone deserves the chance to move from novice to superstar. So we've created an online place for that to happen, so no matter where you are, we're there too. We are opening up worlds of possibilities for our students, and we're kind of obsessed with doing it well. Our teachers aren't just skilled working professionals, they're also the top motion design experts in the industry. Our critiques aren't vague and generic, they're valuable insights about your work. Our classes aren't easy, they are intense and effective, a tidal wave of knowledge. And our students aren't faceless usernames watching talking head instructors. We're a tight-knit community of highly driven learners, filled with global collaboration, inspiration, opportunities, and plenty of fun characters. At School of Motion, we take a full art education, strip it down to the essentials, and supercharge it with real-world grit. And we're equipping our students to do amazing things for some of the best brands and studios out there. In fact, this thing you're watching right now, and even this, was made by School of Motion alumni. Now it's your turn to create something truly moving, and we're ready to help you do it. Because the things that move you forward, move us too. School of Motion. We're not just a school, we're a movement.
Create without limits with precision mobile workstations. Maximum power, speed, and performance when and wherever you need it. So you can perfect every pixel. Break ground in unexpected places. And make the most extraordinary ideas a reality. Discover your next big idea. Precision mobile workstations. Create without limits.
The best social ever is events. face-to-face interactions or online Slack channels and stuff like that. We have a select group of people that we would call if we needed help on something because we have met these people in person or on Slack or something, and we know how they're going to work. Think about it this way. If some rando hits you up on Instagram and it was like, hey, I got a job, you're immediately not going to be like, oh, sweet, a job's coming up. But when you're on an actual networking site such as a Slack channel or going out to meetups or going to events or going to Camp Mograph, get that FOMO. It's so much more one-on-one, and you build relationships with people. And that's what I think helps grow your brand. Ever since we started doing meetups and ever since we started doing that, the amount of work that comes out of it is like tenfold.
All right, everyone, welcome back to C4D Live. My name is Matthias Omatola here at Maxon. So we have amazing presentations throughout the day, throughout the last couple of days, and one more day to go. And I get a lot of questions of where do I find our artists and presenters, and really it's through word of mouth as well as just the interwebs, from all the different social media and networks. And this gentleman, I saw some amazing UI UX design, and I just had to say, you know what are you using? He was like, I use Cinema, and I was like, you know what, we definitely want you on board. So if you're into UI UX, future interface design or anything like that, this is the presentation for you. So check out Wukash, his presentation now.
Hey, what's up, guys? My name is Wukash. Everybody calls me Woo. A little bit easier. Just pretend like you're excited. Woo! So I do user interface design for AAA games. I do a little bit of creative direction on the side as well. I've done some music festivals like Drop Zone. I've done music videos. So I've done a little bit of graphic design for them. I've done like Nitrix and a few other ones. So I've been doing this for about 19 years. Yeah, so here is a little bit of what I've done. Let's play this guy.
How was your day? It's a great night for a drive. Where am I taking you?
So today we're going to be basically talking about FUI techniques, which kind of ties into a lot of the sci-fi loves that I have. So we're going to be looking at 3 different ways that you can kind of create this stuff. One really fast way, one intermediately fast way, which is involving a little bit of like node programming, which is called Espresso, which we'll go into what that is a little bit later. And then some more advanced stuff that might be a little bit harder, might have to do it a few times, but it's worth doing and learning, I think, in my opinion. So the way that I kind of approach a lot of this stuff is I approach it in like a graphic design way, and it's probably because a lot of my roots are in graphic design. So even when I'm working in 3D, I'm still kind of thinking about the space in 2D. I do kind of go into 3D once in a while, but for whatever reason, I really love my stuff like kind of staying in 2D, and then kind of, you know, creating space through doing that. So you guys will kind of see as we go through some of these what that kind of means. So we'll be creating animations like this. Let's take a little peek at it, what it looks like. So the cool thing about being able to render this stuff in 2D is you can still do really cool like flybys and render this out in After Effects or whatever else you guys use. So you can kind of mash up all this stuff and create really complex animations with really simple techniques. So what we will be creating is not this full design. This is kind of what you can create in the end. But what we'll kind of be making is these little 3 dudes here. So we'll be creating kind of like a constellation looking thing. Let me play this for you just so you guys know what it looks like. So we're making a little constellation thing, which is the guy right here. We'll be doing a little radar looking guy, which is this guy here, which is kind of some like dots and spheres being displaced in a really easy way. And then the far end, we're going to be doing this little node connection thing that's super flexible. You can kind of change the numbers in one place and it kind of changes them all over the place and reconnects the nodes and everything for you. So yeah, before we jump into the first example, let's take a peek at number 2, which is what we're going to be creating. So basically what we want to do is we want to create this sweeping motion around almost like a constellation looking thing. And then we want a nice little trailing behavior like all the way around too. So we get like the trailing, almost like wave kind of feel too. We want to create all those different things. So what we're going to be starting with first is just a simple disk. Let's go ahead and create a material so we have nice contrast as well. Go ahead and turn luminance on, and we can turn these other guys off. We don't really need those. So we can make this pure white. That's great. And then we're going to copy and paste. So Control C, Control V, or Command C, Command V if you're on Mac, and then go into here, make a black material. So super simple, not really much to it. We want to apply, or actually not yet. Don't want to apply these yet. We do want is a plane on the ground, and let's set that to about 3000 by 3000, and then apply the black material to that. And then we're going to go ahead and create a cloner, and then we're going to create a second disk. So the second disk, basically what it's going to be doing is cloning along the edges of this guy. So to be able to see that a little bit better, let's do this. Let's bring this guy up a little bit so we can see it. So what we're going to be doing is basically putting the tiny little disks along all the little intersecting edges of these polygons. So basically all the points of the polygons is what we want to do. So I kind of want to just give you guys a basic idea of what that means. So the more that we create of these polygons, the more clones that it's going to create as well. So that'll make a little bit more sense in a second. So let's go ahead and set this to 850. Zoom out a little bit because it's huge. And then we're going to go set this to 19. So make sure all the segments are at 19, and that's basically just how many go all the way around. And then set the rotational segments to 112. And that is, if you kind of bring these up and down, sorry, I think I said the other way around. These are the ones that actually go all the way around. These guys are the concentric circles in the center. So we can set that to, let's do a nice even number instead of 19, and then let's do 120 because why not? Cool. That is exactly what we want. And then the second disk, we want that a lot smaller. Let's set that to about 3 centimeters. And all these other settings are okay. We don't need to worry about that too much. We don't have to optimize it like crazy because this is not super it's not super processor intensive. So we don't have to really worry about that. So basically we go back to the cloner. We want to set this to object mode, which is going to allow us to drive basically this disk, this first one. Let's call this large disk. And then we'll call this one small disk so we don't get confused. So the small disks are going to be cloned along the edges or all the points of the large disk if we set this to object. But it doesn't really know what object to drive it off of. So what we have to do is just drag this guy in there, and voila. It's exactly what we want. So we can turn this guy, oh, not that guy. We can turn this guy off. And then we can apply the white material to the small disk object and turn our quick shading lines off, go back to this, and now we're going to see this a little bit better. So that'll kind of help us understand what's going on here. But there's one little small problem. We want this to be, I think, Z+. Yeah, so all the disks are now facing us. If you look a little bit closer, just so you guys can see what's happening, if basically you set this to, what was it at? I'm not sure, was it? Yeah, it's probably something like this. So if you look at this, it's basically standing up on its end. That's not what we wanted. So we wanted it to just face towards us, which just gives us a Z+. I think Z- is the same thing, it's just flipping it around. So either one of those will work. But yeah, so now it's looking the way that we want it to look. But if we go back to, oh, not that one. If we go back to our example, what we have here is we have a little bit of irregularity in all the little tiny disks, right? They're not in like a perfect line, and they're also a little bit smaller and a little bit bigger throughout the entire thing. So let's create that behavior right now. The way we're going to do that is select our cloner, so that in the effectors tab, we're going to create a new random effector. So go mograph effectors, and then we go to random. And as you can see in here, we added it automatically. If you didn't, let's say you didn't have the cloner selected and it's not applying to it, you're like, what the heck is going on? It's really, really easy solve. So all you do is click on the cloner itself, go to effectors tab, and then you just add this guy on here. So pretty easy, not much to it. Yeah, so let's make this a little less strong. So what we want to do is go over to, let's see here, the parameters. Yeah. Or actually, let's do fall off first. So we don't want it to go as far as it was. It was like, you know, kind of all over the place. It looked very star-like. But we want it to look a little bit more organic because it's a radar. So some of these might be actual points on like a grid or something. But honestly, you know, you could do it like this if you want. It's up to you and what your imagination, you know, wants, I guess. But what we're doing is basically a little bit more organic of a shape. So go ahead and bring this down to like, I don't know, 20 is probably a good number. Then we'll go over to the parameters. Don't have to worry about that one. Leave the position where it's at. How about set the scale though to uniform scale, which is basically going to take the X, Y, and Z out and just have it be a single number, which is what we want. Let's set that to 1.5. So that's going to create a little bit of variety inside of like these little disks. So we got some small ones, we got some big ones. That's what we want. Cool. All right. So next thing that we want to do is we want to create that really cool sweeping motion that we had. So I want to create that little radar that kind of goes all the way around. So how are we going to do that? We are going to use a plane effector. So let's go back to Cinema. Let's go ahead and go to mograph effectors and then plane effector. All right. You added it, but it's not really doing anything. Doesn't look like there's anything there, right? Because what we're going to do is we're going to go here. We're going to set the fall off to capsule. Ah, there we go. Now we can see it. It will actually affect stuff too if you set it up right, but we do want capsule. We don't want the other one. So let's go ahead and set the coordinates and then put it on its side. So now it's laying flat. And then let's go to panel and then see all the views, because we want to get a little bit better view of what's happening. So you guys will understand a little bit better as far as like what we're doing. So go ahead and zoom out in this guy, kind of just make sure that you can see all these. Cool. Might make this a little bigger. Don't really need that much space for these guys. Cool. All right, so now we got a nice little view of the top and the sides and see exactly what's happening. So let's double check that the plane effector was added, and it was, because you can see here in the list. So perfect. What we want to do is we want to set the fall off over here, set it to spline. You can do a bunch of different ones too. We can set it to linear and whatnot, but spline's the one that we're looking at right now. So go ahead and hold control, or I'm sorry, command, or if you're on PC, I think it's control, and then make a few points on here too. So basically what that's going to do is it's going to make a very specific shape, and we'll play with that in a little bit just so you can kind of see what's happening. So now what we want to do is kind of increase the size of this guy. So we want to go 750. It's going to look huge. Don't be alarmed. This is kind of what we want. So that is a good thing. So set these all to 750, and then let's set this one to probably around 600. Okay, so now we can zoom out just to kind of see. And you can see that this thing is huge. Doesn't look like it's a thing that you would want, but you would be wrong, because that is exactly what we want. So we want to go to the strength, and it's at 100 right now. We want it to actually be stronger than that. You would expect that from this. 100 is the highest that you can go, but you can actually overshoot it. So let's set it to like 360 on the strength. All right, cool. All right, so set that up. We set the, oh, we did not set the parameters up. So let's go ahead and set this. So we'll set this to 10, set this to 5, and then we don't want it really going up and down, so we'll leave that where it is. And then we want to affect the scale. And again, on the scale one, we don't want all these individuals. So let's go ahead and just select uniform scale, and then we will set this to -1.5. And hey, it's starting to look like the other one. Now we just have to kind of reposition the plane effector to kind of, whoops, that's not the one we want. We want it to kind of look closer to what we had earlier. So go ahead and just kind of move this guy around, get it to the position that you want it to be in, because it's pretty close to what we wanted now. And then just kind of pull it up a little bit. All right, that's pretty cool. So let's zoom into this really quickly so I can kind of show you what the fall off is doing. So if we want, you can see here that this is like a pretty harsh fall off. So you're gonna have a pretty harsh fall off here. So you can kind of see it almost linearly here, kind of in the same way. So if I pull this out, it's gonna give a little bit of a softer fall off. So depending on what you're looking for, what you're going for, you know, you might want to change that around. So let's keep that. I actually like it a little bit better than what we were having earlier. So let's go ahead and leave that as is. Maybe just pull this up a little bit, make it just a tad smaller, and then make this a little bit harsher. Yeah, there we go. Cool. And then pull this up just a little bit. All right, cool. So another thing we want to do is we want to create this null, and then we want to put the plane effector inside of the null just so we can easily rotate it. It'll just kind of keep that center at the center. So now if you see under here, and we just rotate this guy, you can kind of just see it rotates around the center. It just makes it a little bit easier, and it's fast. You can do it in other ways, but I'm just going to do it this way just because it's nice and easy and quick. So the last thing that we're going to be doing, if you look really closely, we go back to the sample, you can see that there's like a little bit of a trail, almost like a wave behind it. And the way that we're going to do that is through the delay node. So let's go ahead and select the cloner, because other times we haven't had this selected, or if you don't have it selected, it might not show up in the effectors. So we're going to go to, actually, you know what? Let's not select it, and then we'll go through that one more time, just so we kind of understand how to add that effector. So go to effector, then we'll go to delay effector, and it is not on the cloner, and we can double check that because we don't see it in this list. So just take it here, drag it into here, voila, cool. Now we have a delay effector. So in the delay effector, what we want to set this to is, let's see here, set strength to Where did you go? There we go. Strength in effectors to 100. And then we don't want it in blend. We want it to spring, which makes sense. And then we want to animate this guy. So as it kind of goes around in a circle, it just essentially kind of creates that wave look or that animated look. So one way you can tell that you have whoops, is that the one we want? That is the one we want. Okay. So one way that you can kind of get this effect is by just setting keyframes. So we'll set a keyframe, and you know you got a keyframe because if you go here, you can kind of see this little thing at the bottom of the timeline, and it'll kind of create a new keyframe. So go all the way to the end, select the null again, set this to 360 because we want it to rotate all the way around, and then click this because we want it to set a new node, and it will rotate all the way around. Okay, cool. So we're going to pull this guy down. Okay, so one thing that we want to make sure too is that the order of these effectors are in the correct order, because you will not get the effect that you're looking for if these are not in the correct order. So it's already kind of doing some funky stuff here. So let's go ahead and reset this. Bring back to the beginning, and then play. So now it's kind of doing more of the behavior that we want with like the nice little bounce and stuff too. So you can go ahead and render this out, and it'll kind of create all the effects that you want with a little subtle wave behind it, and it'll also do the basic plane effector on it as well. So if you are trying to render stuff out, one good thing to kind of look at when you are rendering this out is make sure that you have your alpha channel selected too. So you'll have to pull out this back plane to be able to render it out, and then you set it to not PSD but PNG, and then you can kind of import it as a PNG sequence inside of After Effects. So pretty easy to do that. Not going to go into that too in depth, but that's kind of what you would do if you wanted to use that almost like graphic design style, kind of what I've been looking at. So that's basically that. And let's see here, go back to this original one. So this is kind of what it's going to look like in the end too. And you can add all sorts of different effects on top of it. You can add the little like glows and whatnot too, to kind of give it more of a radar effect look too. Actually, let's jump back into Cinema4D really quick before we move on, because I just realized I did a very dumb thing. I knew that the delay effector did not look the way that we wanted it to look earlier, so we've got to just make sure that these are in the right order, that the delay is at the end, because they do execute, I believe, in the order that they're in here. So then we want to go to delay. We don't want it on infinite, we want it on linear, and we need to set this to Y+. And then let's go ahead and just crank this fall off to 100, bring it back to the beginning, and now we should see this doing more of what we want. Okay, so now we're getting that wave motion a little bit better than earlier. So that's kind of what we're looking for. That's probably why it looked not correct earlier. So just make sure that you have those set up, that your effectors are in the right order, and that your delay fall off is set correctly. Cool. Okay, now we can move on.
Let's maybe take a look at these examples again. So basically what we're going to be creating is number 1, which is right here. We want to create this like constellation like pattern. We want to be able to connect random nodes. We want it to just kind of create a lot of visual interest. So the way that we're going to do this is using something called Espresso. So don't let that kind of, don't let it scare you, because it's really, it is visual programming, but it's, once you get the hang of it, it doesn't feel like programming. So it's not too crazy. Most of the time you don't even have to do a lot of math to be able to get this to work. We're going to be doing one quick little Python script in there. And Python is basically a way of being able to just kind of script anything that you can't do in Espresso. It's a little bit more powerful. You can kind of do complex math and stuff. We won't be doing super crazy complex. We're just going to be going through a basic modulo. We'll explain what that is a little bit later. But the reason why you would use this is to make it super expandable. So if you can see, up here, there's, I don't know, what is it, like 10 by 10 squares on there. So creating all those by hand and then going through and connecting that line every single time would take an extremely long amount of time. So being able to front load this stuff with a little bit of visual programming kind of helps you out, because you don't have to go in there and like recreate this thing every time somebody's like, oh, we need, you know, less complexity here or more complexity here. It just makes it a little bit faster. So this doesn't always work for every project. You just have to feel it out to see if it makes sense to front load this. But when you are kind of creating from the get-go, you know something might be kind of possibly too complex or not complex enough. You don't really have your composition fully made. Being able to set something up like this is a really good idea, because it just it makes it a little bit more flexible, and you'll be able to create this in a more, I guess, dynamic way. So let's jump into Cinema4D. So we have to create a few basic things first. So we want to create a disk. We want this disk to be, let's see, probably about 5 centimeters. So we can go ahead and zoom in a little bit. Position it. All right, cool. Let's create a material really quick, just so we can kind of be able to see this and see what we're making. So go ahead and just turn luminance on, turn color and reflectance off. Go ahead and apply it to the disk. Let's make it platonic. Let's make this guy about let's say 9. Create add the material onto it. Cool. All right, and then after this, we want to create a mograph, and then go to cloner, and then drop both of these bad boys into the cloner. Cool. So already got some cool stuff happening. So kind of as you guys saw earlier in the other example, we want to move this guy to a grid array this time. We don't want any depth to it, so let's take that out. Let's keep it simple at 3 by 3, just so we can kind of get the hang of this thing first, and then we can kind of make it more complex as we go. All right, cool. So let's go ahead and create what we're going to be using in a little bit. So we're not going to use this right away. You guys will kind of see why we're kind of creating this and what the purpose is in a little bit. So go ahead and just create this first, and then we can kind of dive into it. So we want to name this speed. And this is where we're going to hold most of our Espresso math too. So we'll have a little controller on here. Let's go ahead and go to user data, and then add user data. So this looks really intimidating at first. It's not too bad though when you kind of get the hang of it. So really all it is up here is just the name of whatever you're going to be creating. We want to create this as a slider because we want really easy control, right? So you can kind of see it's going to look basically like this down here too. So oops, let's reopen that. Did not mean to close that. Yeah, so we have basically what we're going to create is like a slider down here. You'll see in a second. Then we want this to be a real number, and then we want the minimum to be 1, and then the maximum is going to be let's say 30. So this is really just going to be something that allows us to control the speed, and you can obviously turn this up if you really want. You can make the maximum a little bit higher. I feel like 30 is like the best number, just because it's basically going to be controlling how many times it's going to be changing. So is it going to be changing every frame, or is it going to be changing every 30 frames? So I don't think we're going to be needing anything quite like this high, because it's going to be probably too slow. So I kind of max it out at 30. So now we want to add the Espresso. So we need to right click the null, go to Cinema4D tags, all the way at the bottom, go to Espresso, and that is going to allow us to start making some Espresso scripts. So let's go ahead, make this a little bit bigger, and then we need to quickly draw, let's just do like 4 points. And it doesn't really matter how you draw those, because these are going to get dynamically linked the first time you run it. So just basically click 4 times on your screen. It'll kind of make more sense later on. So we need to kind of tell Espresso to say, hey, collect all these points. So how do you do that? Over here, we have a little way of being able to find all these nodes. So we can either go to the X pool, or we can right click Depends on what your preference is. I like the expool just because it's a little bit faster. When you're first starting out, it's probably not a bad idea to go through this just because it'll kind of show you all your stuff listed out, and you'll kind of understand all the different things that you can do. But for now, let's go ahead and just do it this way. So go ahead and type point. Nope, not point. Point. There we go. All right, so we're going to add a point node here. And then what we want to do is we want to input a random number into this point. So we want to select 1 through, or basically 0 through 3 or 1 through 4, depending on how you look at it. If you look at the backend math, I think it does do 0 through 3, but we're going to be looking at 1 through 4. So let's go ahead and basically pick a random point from this. So we will need random integer. And this is basically just going to pick a random point. So we want to take this integer and then input it into the index. And what you guys will see right away is this is going to turn yellow. Usually what that means is it's not getting the data that it needs to do the thing that it needs to do. So it doesn't necessarily always mean that it's broken. You guys will see a little bit later. It might turn yellow, but it's not necessarily broken. It's just not getting the data that it needs. So let's get it the data that it needs. So what we'll need to do is we'll need to drag the spline in, and that's going to create a new node here. We don't really have any nodes on here, so how do you create some is you just basically click on this guy. It's going to give you all your properties, and we just want the object for now. So let's go ahead and bring this down here, plug this object in, and right away you'll see this kind of change color. So now it means it's getting what it needs, so that's great. So one thing I do like to do is also add result nodes, and this kind of helps you debug things, because sometimes things don't behave the way that you want it to, or maybe you're using the wrong node and you don't realize it. So this kind of just helps you organize those. So you can see that this point count is 4, which is what we created. So that's good. So basically this random integer is going to be picking a random point index, which is going to be 1 through 4. And then it's going to connect one of those random ones to one of the random numbers in the cloner. So that's just kind of easy way of being able to see like what's going on and stuff too. So let's go ahead and go a little bit further with this. We want to basically, let's see here. Okay, let's go ahead and add the cloner in here. And the cloner itself is not going to really give us much information, so we need to get some data out of that. So let's go ahead and add a data node. And all this does is help us extract a little bit more information out of just this cloner. And right now you can see again, this cloner really doesn't have anything outputting. So what we want to do is we want to pick the object, and then we can go to object. And so now we have all this cool stuff that we can output from there, like these guys. So you can output the IVs, the visibility, the weight, all that stuff. So all we need is to output the position. So we don't have that, so we can add it by right-clicking, or not right-clicking, by left-clicking on this guy, and you'll get all the options here. So now we have the position. We want to take that point position. And oh, look at that, we don't have it on here either. So what we want to do is also add point position here. And let's make this a little bit bigger so we can read it. All right, move this guy down. So we're going to take the position from this cloner object and plug it into the position of this guy, and right away you can kind of see that it connected that first point. So stuff's kind of happening the way that we want it to, but not all the points are connecting. So we need to be able to randomly pick a point from this guy and then connect it to a random point in our cloner object. So how are we going to do that? Let's go ahead and add a random integer just like we did down here. So do random, or if you guys want, you can command drag this guy too, and it's going to also kind of create a clone of that as well. So that might be a faster way than typing over here. So we are going to input a random integer into the index of this cloner. So you got to remember, these guys are basically one thing. This is just a little bit more complicated way of showing the same thing. You're just kind of extracting data out of this guy. So it's kind of confusing at first, but it's not too bad. Okay, so we want a random integer to go into the index. And let's see here. So we know that here we have, basically it's 4 random points. So we go from 0 to 3. So that's basically what we want. And then here we have a random point of 9, because there's 9 of these guys. So we want to go from 0 to 8. Or normally, like the way that we count would be, you know, like 1 through 9, but with computers it always starts at index 0. So we do start at 0 and then we kind of go up to 8, I believe. So let's see if this works the way that we want it to. So another thing that we need to add on top of this is the speed node. So we want to basically be able to set up the speed. And how are we going to do that? So we need to take this guy, drag that null into here, and make this a little bit bigger. And then we don't really get any outputs, right? We want to get the thing that we created earlier, which is our user data, and then be able to output that data. So whatever we drag here, we want it to output that number. So let's go ahead and add user data and then speed, and then let's do result, just so we can kind of understand what's happening here. So take this, plug it into here. So now if we go to the speed and we change that number, you should see it change over here. So pretty simple. It's not really that complicated. It looks kind of crazy, but not too bad. So that's pretty cool. So now we are going to create a little bit of Python script. So what we're going to have to do with this Python script is basically use a modulo. And what a modulo does is it basically says if I divide this number by this number, how many times does it go in? What's the remainder of dividing those two things, I guess. So if you do like 3 mod 2, that would be 1, because 3 divides by 2 only 1 time, and then you have 1 remaining. If you do 11 mod, let's see, let's maybe type these out. So we have 11 mod 4, that would equal 3, because 11 divides by 4 twice, and then you have 3 remaining. But what we want is for it to always equal 0. So we want whatever these numbers are inputted to equal 0, because we want basically to match this number to the frames, and then being able to essentially turn a thing on or off. So we're gonna basically say this guy is either on or off based on what this modulo is doing. So it'll make a little bit more sense in a second. So let's go ahead and just type this out. So we're gonna do output 1, which is this guy. And it's kind of already defined here for us as soon as we create it. So we get global output 1's defined. And then what do we want to come out of this thing? So now you can see output 1 here. And now we can actually tell it to do a thing. So from here, we would do output 1 equals, let's see here, let's do input 1 modulo input 2. So this just means modulo, this %sign. And then we're going to have that make sure it always equals 0. So we want to make sure that that frame, so if we set it for every 1 frame, we want it to basically trigger every single time too. So that'll make a little bit more sense in a second. So let's go ahead and take this, input it into the input 2, and then we take a time node, which is essentially just getting our timeline here, and then it's outputting a number. So you can either do the actual time, you can do frames, which is what we want. So we don't need the time itself, because the time itself is, let's see here, create another result node just so we can kind of see what's happening. And then also this. So let's go ahead and just connect these just so we can kind of see what's happening with these. So you can see that the time itself is actually outputting like a time. And then the frame itself is creating a nice even number based on the number of frames that we're on. So 30 equals 30 makes sense. So let's go ahead and get rid of those, keep it nice and clean, and then we want to input it into here. So now basically whatever we set for speed is doing the modulo of whatever frame that we're currently on. So if we're on frame 2 and we have a 1, that's always going to equal 0, because 1 divided by 1 always equals 0, right? So yeah, that's pretty simple. And then another thing that we can do just to kind of test this out, so we can go here, we can set this guy to bool, which is essentially true or false, and then we can output it, and if our speed is set to 1, this should be true basically every single frame. So let's check that. Hey, look at that, exactly what we wanted. So every frame it's true. But let's say we want it to be every other frame to be true. So let's go here, go all the way to the beginning. So now, as you can see, every other frame is true, and then it turns off false. So basically what we're doing is we're turning off this random integer every other frame. So that kind of makes a little bit more sense for what we were doing over here. So if we want it to be every 30 frames, crank it all the way up to 30. And if you want it even more than that, you can go back to manager, you can go into speed, and then you can set that maximum a little bit higher. All right, cool. So let's maybe just keep that because it's going to help us understand a little bit of what we're doing later down the road. And then what we also want to do is we want to kind of feed this random integer a seed, just so it's a little bit more random. If we ran this every single time, it would be like the same pattern, but we want it to be a random pattern every single time that we run it. So that's what we're doing with this, is we're essentially just going to create a random seed to be able to have that be different every single time we run it. So let's go ahead and add a random. We'll connect this here, and then we want the output to be an integer, and then we just feed that into the random seed over here. So now every time this runs, it's going to be a little bit more random, and then we want to, let's see, enable, there you are. Okay, so now we want this to say every time this is true to run this random integer. All right, so let's see here, we should be getting kind of what we already want. So let's go down to 1. So you can see as soon as I set this was now getting the data that it needed. So it didn't turn, it turned off from yellow, but if I turn it up to 2, it's gonna basically not get the data that it needs because it's on false over here. So every other frame, it'll basically turn on and off. So it's kind of doing what we want it to already. So if we kind of jump into here and we look at this guy, you can kind of see that it's essentially every single frame, it's already doing like a random cool pattern. So that's pretty cool. One thing that's great about this setup is that we can go in here, we can change this to 5, change this to 5, and then with some simple edits, let's go ahead and go down to here, random integer, set this up to, let's see, 4, so it selects all the points. So now we're basically selecting all the points, and oh, actually we forgot one spot. Let's go ahead and see here. Got 1, 2, 3, 4. Set this down to 5 and 5. Okay, so we got 25 of these guys. So now this random integer, since it's picking from random points in our cloner object, which is down here, we want this to go all the way up to 25 so that it selects every single one of these points in here. So it's doing what we want. So that's pretty cool. So this is the power of being able to use Espresso. It allows you to basically just go in and create really flexible animations. I mean, you saw what it took maybe like 10 seconds to kind of edit those out. And if you want to get really fancy, you can actually connect a lot of these to themselves. So like every single time you change this, it would update these random integers. We're not going to get into the super complex part. We're just kind of keeping it super simple right now just to kind of get your guys' feet wet. So Let's maybe go back to these samples. You guys can kind of see here, you know, it's just kind of randomly changing, just kind of how we were looking at it earlier. And then if you look at the final, so you can see kind of in the corners and on the top and bottom over the little triangle thingies, you kind of have these random little nodes getting all connected and stuff too. So yeah, so that's the basic setup for simple Espresso. I think we kind of covered most of the stuff that we want to in that. So let's maybe jump into a little bit more of a complex example of Espresso. Oops, and actually before we do that, let's go back to here. I kind of want to just show you how this speed slider works. So if we go to, oops, speed, not spline. If we go to here, we can basically set it and say, how many times do we want it to change? So what this is going to say is basically every 7 frames, change it. Because we did the little math modulo over here, you guys remember, and basically if it equals 7 or is divisible by 7, it's going to set this to true, so it's going to connect a new point on that line. So now that it's on 7, every 7 frames it's going to be changing. And then if we want, say every, I don't know, 15 frames, it'd be even slower. So that's kind of the power of being able to set up all this stuff, because you can just imagine all the different nodes that you can kind of create, and the different, I guess, user datas that you can kind of go in here and create like all these fun little sliders to be able to like create, you know, maybe adjust how many points you have on here, you know, how big it is, how much spacing you have between the points. So it's pretty much endless, the different things that you can do on here. So you can do a bunch of different stuff. And then let's see here. Oh, actually, one thing I did realize is this should be 24, because we do start at 0. So 0, if we want 25 points, then we want this up to 24, just because this starts at 0. So if it did start at 1, this would be 25, but if we want to pick all 25 of these, we want to go to 24 only. Okay, cool. So now we can actually go to our new project. So what we're going to be doing is we're going to be making number 3 on the far right over there. So essentially what this is just like almost like a data visualization. It's a way of being able to kind of connect things in a very dynamic way. We don't do any manual work for actually connecting those lines, and it's all kind of done in the back end with all the nodes and stuff too. So it's pretty cool. It's very flexible. With a little bit of front end work, I guess, or front loading it, you are able to create very complex animations, and you can reposition this and everything kind of connects to, whereas like normally you'd have to like select all the things, you know, move everything up and then reanimate everything. So it's just like it would take a crazy amount of time to actually do something like this by hand. So what we want to do is just have it dynamically created for us. And how we're going to do that is using Espresso. And always the goal with Espresso is to basically be able to create this stuff a little bit faster and more flexibly. Okay, there we go. So Command N or Control N and just create a new document, actually create a fresh document because we had some materials down there. We want to get rid of those, so we start from a fresh, clean document. So this whole technique kind of comes from an idea that came from Hello Lux. So I kind of figure I would give credit where credit's due. Kind of created this base concept, and we're going to kind of expand on it, make it a little bit more animated, kind of create a lot of these nodes moving around and stuff like that too. So yeah, so let's dive into it. So we're going to create a cube first, then we're going to make it about 200. Sure, let's do 20. And then by, let's say 650. All right, cool. Let's zoom out a little bit, rotate around, center back up. Cool. Then really quickly create a new material by double clicking in here, or do create new material. Go ahead and set the luminance on, turn the colors off and the reflectance off, just because we want a nice clean color. Set that here so we can see a little bit better. From here, we want to create a new cloner and then stick the cube inside of the cloner. And here we want to change again from linear, not to object this time, but we want to go to grid array. We want this at 1, this one also at 1, and then we want to spread these apart a little bit further. So they're kind of doing the little node connection thingy that we were seeing earlier.
From here, we want to just create a new spline. So go ahead and do that. One way that I like doing it is I kind of create both the sides and then I go back into it and I just command or control click on here just so they're nice and even. That otherwise, like, they're going to be kind of offset. You might have one like up here, one down here. So we want a nice evenly in a line. So I just kind of create it that way. From here, we also want to copy this cloner, paste it, delete that out of it, bring the spline inside of here. Let's rename this to chords. Let's rename this guy to left node, just so we know what this is. And then we want to copy paste again. Let's go ahead and delete this, and then let's set ourselves up for success in the future. Create an instance, which is essentially going to be linked to this guy. We didn't have it selected, so similar to some of the effectors, if you don't have it selected, or if you don't have the cloner selected, it won't automatically apply. So in case that happens, you can select it, then inside this little reference object, inside the object tag, you can just take this cube and bring it down here. And what that does is creates basically like a carbon copy of the other one. So if we go here, we make this bigger, it's gonna make the other one bigger too. So it just kind of saves us time in the future, just in case we kind of change these. So let's recenter that. So that is the instance node. Let's see here, let's take this, let's kind of center it down here, just so they're a little bit lined up. All right. Cool. So I think that is all we need for that. Let's go ahead and start diving into some of the Espresso. So let's create a new null, like always. Always want a nice little clean spot to have these. So I always create a null just so I know exactly where it is. Let's rename this as the controller and then create the actual Espresso tag itself. Add that in there. Let's go down here, add the so that popped out. You guys couldn't see it, but this was kind of undocked for me. Oops, that's not what I wanted. It was undocked like this, and all I did was I just dragged it into here, just so I kind of have it nice and organized. Okay, cool. So let's go ahead and start adding some of the nodes that we need. So the first thing we want to do is we want to be able to select these points and connect them to these points. So what we're going to do is we're going to add a left node, and we're going to add our right node. Oop, this is not named correctly. Let's do left node. I'm sorry, left node, and this is the right node. I'm dyslexic. There we go. Okay, now we got it right. Okay, so let's delete this just to be safe. Bring this back in. So we're going to add the right node, going to add the left node, then we're going to add the chords themselves. All right, cool. So now we want to connect these points. So first thing we're going to need is go to xpool. In case you can't see that, go ahead and just go to custom and then xpool. Pool, and that'll kind of pop this guy up. You have Xmanager and Xpool, but we're going to be mostly using Xpool right now. So go ahead and do a search for point. Going to add that in. So that's going to be our first point. So we'll name this point 01, and then parameter. Cool. So that's going to be point 01. Cool. Copy and paste that. Bring that down here. And now we want to grab the fourth point on the node, which is going to be the number 3 since it starts at 0. So counting up 0, 1, 2, 3, that's going to be number 4. Cool. So we want to get some data out of these. So for our cloners, we need to get data that we don't have just out of this node itself. So we want to connect the point position to the point position of the points themselves. So how do we do that? We need an object tag here, so we can connect that into the object of here, and then be able to get the position out of this and bring it into the position of one of these nodes. Cool. All right, so from here, we want to create same thing up here. So just command drag this thing or just add data from the left hand side again. We also need to add the object here, connect object to object, and then position to, whoop, you know what? We did this wrong. We actually want point position. This kind of messes me up sometimes. We don't want the point index, we want point position. There we go. Okay, so now that that's connected, that should be a little bit better. And then position to also point position here. Great, okay, so that's what we wanted. All right. So from here, to get the position of the chords, it's a little bit more complicated because we have multiple points in here, and the spline works a little bit differently. So let's go ahead and we're going to have to add a Python node here. And all we're really doing in this Python node is we're just grabbing the cache from the actual chord itself. So go ahead and add the object here. And then we want to basically grab the cache. So all we have to do is delete this plus input 2 and then get the cache of these objects, because in the back end, Cinema4D is basically storing these. We just need to get that using a method, and that's what this thing is called. It's just a method on this input. And so we want to connect here to here, and oh, that's kind of weird, doesn't let us. So this happens once in a while. So go ahead and just delete these ports and then just add a new link, and voila, you should be able to connect these guys. So that's good. And then from here, we will create a, we need to, let's see, Python hierarchy. Oop, if I could spell. All right, we bring in the hierarchy here, and then we want the object input. So we, oh, same problem here, right? Can't really connect. First thing we want to go to is just delete that, create a new link, and then output that. Great, that's working now. And so from here, now that we have the hierarchy of objects, because almost works similar to over here where we need to actually grab the hierarchy first, and then we need to grab the index. So we do object index, and that's going to give us the number of point. And then we connect the object to the instance, and now we have the index, and we can take that index, zoom out a little bit, create a little bit more room for these guys so we can read it, and then move these guys over, consolidate some of our space. Cool. All right, so from this object index, we want this instance to go into the object here. And hey, look at that, we're already making some connections. That's pretty cool. Okay, so and then from here, from this instance, we also want to connect it to the object. Now we're connecting some more, even better, awesome. And I think we have these backwards, so let's set this one to 0, and then this one to 3, and now connect them the correct way, because all we're really doing is grabbing the first point. So these kind of point nodes are grabbing the actual points in the spline. So this will actually be point 4. So let's name it accordingly. And then it basically just connects them. So you can kind of see it's already doing some pretty cool stuff. So if we go here and we move this guy around, oops, not the chords, we want to do the nodes. Yeah, so we can move these nodes around. And they basically stay connected. So that's already pretty cool that we can do something like that. But we don't want to do that exactly. We want these to connect to each individual one. So how are we going to do that? We're going to take this instance and we're going to connect it to the index. This index, and connect it to the index of the nodes. So basically now that's all that's saying is like connect 1 to 1, 2 to 2, 3 to 3. So that's pretty simple. You were just basically explicitly telling it to do that. We don't want to do that on the other side because we want this to kind of animate up and down. So we're going to go back to some high school math. So you guys thought you weren't going to use high school math in Cinema4D, but little did you know, I'm going to have to go back to trig. So it's not too bad though. So first thing we want to do is we need something to drive the sine wave, which we'll create in a second. So we're going to use time to drive that. And then we're going to add a trig function. And then let's go ahead and just name this sine because that is what we're going to be using. And we can see it's already set to sine. And then once we're looking at this later, we kind of have a better understanding of what that trigonometric function is doing. So connect the time to drive that sine. A sine wave is just like it's like a up and down wave, and it has a peak and a trough. So, and then also a period and all that other stuff. But we're not going to worry about the specifics of it. Basically, all you need to know is that you're going between two ranges forever, right? Whereas time would just be a linear expression. You'd go from you just continuously go up, 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 and up, and you would never go back down. So we want to go from 0 or 1 to 3 or 0 to 2 if you're looking at it from the computer side. But we want to go from that first point to the second point to the third point to the second point to the first point. So we just want to go back and forth between those. So sine wave over here, that is what we're going to use to be able to do that. And if you look at the results, we can kind of get an idea of what's happening. So with time, it's continuously going up. Set this to, yep, that actually should be good. And then set this to also let's do integer on this one. So basically, if you look at the time continuously goes up, but with the trig function, oops, let's see, real number, yeah, that's what we wanted. Okay, so with this guy, because it's between 0 and 1, once it hits 1, it's going to start going back down, kind of like how we saw in the sine wave, and as expected, it kind of does start going down. So that is good. That is kind of the functionality we want, but we need it between 1 and 3 because we want to grab one of these, right? We don't want it between 0 and 1, so we have to map that to a new value. So how we're going to do that is just use a range mapper, which is very appropriately named. So in a range mapper, what you have is you have basically what your input is. Our input is going to be between 0 and 1. So we saw that over here. So we can set that between input upper and lower. Okay, so that's already set. So it's kind of assuming that it's already going to be between 0 and 1. So that's good. But the output, basically what we want to do is we want to map those values between 0 and however many numbers of these things there are. So we could set this manually to the number that we want, so 2, or the number of items there are 3. So we just got to remember that we start at 0 and we count up. So we don't want to do this manually, right? We want this automatically set. So a way we can do that is left click this guy and then do upper. Let's do the upper or output upper. So we can now connect this guy here, and then what we could do as well is set the, let's see here, yeah, so on this left node we can go to object properties count, and we want to do the count in X, and we can set that count in X to the upper limit of this range mapper, and that will automatically set based on however many we have on the left hand side, how many times it's going to go up or it's going to go down. So that's going to dynamically set that up for us. So that's already good. And then from here, this range mapper, we can kind of see what that's going to output. So let's go ahead and see, just so we kind of have an idea. So now we should be going between 0 and 3 every single time. So if you guys go back here, you can kind of see it's going to hit 3 and then go back down. So that is, as expected, exactly what we want. But we don't want this float in here, so we don't want a decimal point. So we're going to just do a quick absolute value on that. And I think sometimes it just ignores these numbers. I just like to do this just to be safe. So go ahead and grab this, and then we're going to take this absolute value and plug it into the index. So basically all it's doing is it's saying that this index of this guy, so the very first point is going to connect to random points on this other scale. So let's make sure everything is connected as it should be, and I think we are. Cool. Just so you guys kind of get an understanding what's happening here, let's just plug in the absolute, and oh, I'm sorry. We actually, you know what? We really didn't need that absolute value because I don't think that this outputs a negative number. Let's just double check. No, it does not. So we don't actually need this absolute. So let's go ahead and just delete that. And then from this range mapper, we can just go into the index. So that should still work. So now if we hit play, we basically go between these different points. So that's exactly what we wanted. But here's the cool part. We can actually do, let's see here. Let's do one more thing where we'll go here and then we'll do the count in X, because we want to grab the X count here. And then we want to automatically drive the number of, let's see here, write nodes based on the number of nodes here. So if we change the number of chords, we want that to also change the number of connections too. So you can see here already, that's pretty cool, because we did basically no having to do manual work, and it just automatically created all the things that we needed. So I think that's pretty cool. So if you try to change this number on the actual write nodes, it won't work. But if you go to here, set that number up, it's going to automatically create however many nodes you need. And then if you play it, it's still going to kind of do the right connection for you. All right, guys. Well, thank you for tuning in. I really appreciate your time. Hopefully that adds some value to your process. You guys learned something new. If you guys want, go ahead and hit me up on social media, which I kind of mentioned earlier. So I'm on Twitter, I'm on Instagram, and then if you go to my website too, if you go to www.lucas.io, which you can kind of see how it's spelled over here, pretty much the same as my Instagram handle. You can see all my other social stuff, so I'm not going to spam you with everything. But yeah, I really appreciate you guys for tuning in. Again, if you would like to connect or see more of my work, check out my website. And yeah, going to be passing the torch. I think we're going to jump into some questions here.
Hey, Wukash, thanks so much for that presentation. That was fantastic. I am just mesmerized by Fui work and think it's so awesome to see how it's executed in Cinema4D. It's often so simple and yet can look so complex. And you brought a next level to it with some of that Espresso and Python stuff. So thank you very much.
Yeah, no problem. It was really fun.
So we have a couple questions here for you from the audience. First one is just sort of in general, how did you get into the Fui industry? How does one get into creating fictional or fantasy user interfaces?
Okay, so this is one of those questions that there's no single answer for because everybody's journey is a little bit differently. I can tell you how I got into it, and I'm going to give you the short version of it. But I've been doing design for a really, really long time. Started super young. I tried a bunch of different things. Found that Fui was like one of my favorite things. So I kind of just dove into that like head first. I kind of just started like looking at other people's tutorials, started like figuring out how they did stuff. I started after that, once I had like a good hang of it, I kind of started creating my own stuff too on top of that. But to specifically get into the industry itself, I think that if you don't have like a really strong portfolio, just make like passion pieces. I mean, you look at people like Ash Thorpe and Machi Kuchara, like all those guys, they're like doing a lot of like passion pieces, and they would just like, they got known through doing a lot of that stuff too, right? And so it's like, you kind of just have to put work out into the world and people are going to respond to it. So another thing I did too is I put out like a free asset kit where people could just go down and download it. And a lot of my friends in gaming, they kind of like reshared this. And so it kind of, it took off a lot more than I expected it to. So that brought in a lot of work too. People kind of just like saw that, I was giving away this thing for free. And actually, I learned that from a few other guys. And oh my gosh, I'm trying to remember his name right now. But he gave out a bunch of like free assets, and I was like, oh, that's brilliant. Like I already do this stuff anyway. I might as well give it out to people. So the biggest thing is to just be able to, I think, create work that the world's going to respond to, and just kind of put it out there, and people are going to see your work and either contact you or you can just start going to the studios and just start applying at like pretty much every single studio. Look at the movies, like look at all the work that you like the most, and try to figure out which studio does that work, and just try to like follow those guys on Twitter, on YouTube, like basically everywhere. And
yeah, that's great advice. Do you, when you're developing your ideas, do you kind of draw them out on paper first, or do you like devise the Espresso on paper, or do you just kind of go with it?
Yeah, so being like an artist first, I tend to like kind of work in my brain. Like, so I'd almost do like thought experiments where I just kind of like close my eyes and I'll like think of an idea, or I might just like stare off into space and I think of like what I might want to create. But I have like a full process. So my full process kind of involves me going into just like words first. So I'll just outline it in some sort of creative brief, had some basic goals on top of that. And, everybody kind of does creative briefs a little bit differently. So I kind of describe what I'm trying to do first. And then after that, I kind of jump into like collecting assets and stuff. And so I either use Miro, which is like a really cool app, or Pinterest. And Pinterest is really good because you can just kind of like, you have like shortcuts and Chrome and stuff that you can really quickly pin stuff. And I'm all about speed. So being able to put stuff together really quickly is, I think, like a really, really good strategy. Because sometimes, you might be on your phone and you find something cool and you can pin it there too. So I'll collect all these assets, kind of bring them all together, kind of look at all these different things. And I don't always do like FUI. I might not even look at specifically that kind of work. I might look at, like the wing of a dragonfly and like the way that light hits it at like a certain angle. And I'm like, oh, there's like really cool colors in that, right? So if somebody did some macro photography of that and I'm trying to like mimic that kind of look or feel in like a piece, I might kind of just like extract from something that's not FUI. And from there, I'd like sketch a lot of stuff. So I use Procreate on my iPad lately, but sometimes I'll just draw it out on paper too. And then after that, I do a bunch of roughs of that thing from the sketches. So I'll do anywhere from like 5 to 100 different roughs of the same interface. And I just do them like super rough. There's no polish. There's no like, it's kind of hard to show that kind of work because sometimes people don't really understand the spirit of that. So you have to set it up in a way that says like, hey, this is, temporary work. It's meant to be like a lot of iterations on like a single thing. So once they see that, you can kind of point to different things and just say like, hey, I like this a little bit better. I like this a little bit better. And then you kind of narrow it down to a few, and then you kind of polish it from there. So that's kind of the short version of my process.
Yeah, and how about the back end of the process? Like, how deep do you usually take it in Cinema4D, and like how much comp work do you end up leaving for the end in a compositor?
Yeah, so I basically do I do a lot of experimenting in Cinema4D. So I kind of try like a bunch of different versions of this thing, try to figure out what works best. I'll save I'll kind of group them all up and kind of turn them on and off and kind of go back and forth between them. So I do like to create a lot in Cinema4D too, right? So you guys saw in there where you can kind of create these nodes. So sometimes in your head you see something as it looks good, but then when you see it kind of rendered out, you're like, "Ooh, that didn't really turn out as well as I thought it would." Like the dot density was too high or too low, which the Espresso helps a lot with. So you kind of create like multiple versions of these and kind of render them out. And then in After Effects, when I'm kind of compositing all this stuff together, I'll kind of turn all these on and off and see like what kind of gels together well.
Cool. I see that Jace Hansen's here in the chat complimenting your work. He's someone I look up to in the FUI world. Who do you look up to?
Honestly, Jason is one of them. He's amazing. I'm on his email list. If you guys aren't on his email list, definitely check it out. It's really cool. So he kind of just goes into a lot of his process and stuff, which I think is amazing. I also love Ashthorpe. He does really great work. Man, I'm going to blank out. Robin Hardo, I think I saw her in chat. I don't know if I'm saying her last name. She does amazing work.
Oh, yeah. Robin's great. Yeah, she presents for us a lot.
Yeah. Definitely watch some of her presentations. She's really good at what she does. All the guys at Perception, at Territory, those guys are amazing. I feel like I'm forgetting a bunch of people. But, yeah, there's a lot of people that I follow in that space.
Yeah, and it's a great and vibrant space in Cinema4D. I think the mograph tool set really plays into it. As a matter of fact, we wanted to dig into one of your earliest examples, that radar, and talk about a different way that it can be achieved in the newer releases of Cinema4D using fields. So I've got here basically the similar to the setup that you had created here with a disk and a cloner. And what we can do is create a new plane field. And we're going to jump into the fall off tab here. Actually, let's first change our parameter. We'll go ahead and set this to, I'm just going to overemphasize this and set this to 3. And here in the fall off, we can add a radial field. And this is a new field type that was added in with the field system in release 20, I believe. And here we have the option to directly adjust those angles. So we can set up a specific angle that we want for that radar sweep. And we can have a transition too, so that we can smooth in and out of that angle. So this makes it really easy to sort of adjust, that sweep distance more or less. And then you can adjust the offset to actually animate that around. And you can even add iterations here. So we can set this to something like 2, and now you can have 2 sweeps really easily. But one of the really cool things about this is that the radial field has what we call subfields. And you can see here that you can actually control the offset with another field. So we can go ahead and add in a time field. And we'll go ahead and feed that into the radial field offset. And now you can see that it'll automatically animate over 30 frames, that offset. And we can do things like set up a sine wave, and now it'll actually bounce back and forth. So some really cool possibilities there. And of course, you can stack more fields on top of this. So if we wanted to invert the effect, we can just add an invert field. And then if we wanted to do a curve on top of that, we could add a curve. And we could actually adjust the hard to do these things live. There we go. We can do something like that to get sort of that ridged appearance that you got. So some really cool possibilities there with fields. We definitely have to get you upgraded, Łukasz.
Yeah. Yeah, got to upgrade my math too, because 1 divided by 1 is definitely not 0. I meant to say 1 modulo 1 equals 0, but yeah.
Yeah, and modulos and all of that are super cool. One of the other questions that came in here was, you use some Python nodes in your setup. Is that something that's strictly necessary, or could you have gotten away without them?
Yeah, so some of them, I think specifically with the modulo one, you could have done it with, I think the formula node will also do something very similar. And I want to say, I thought I saw something that you could do specifically modulo without even the formula too. I would have to kind of dig into that to look a little bit deeper. But you can create those effects that way. The way that I like to set my stuff up is to make it very expandable, so that, like, let's say in the future, we wanted to do something even fancier than just modulo. It's like, if we want to do something on top of that modulo, you can also expand that out a little bit more too. So not necessarily.
Totally, yeah. I'm the same way. I jump to Python Python nodes quite a bit, just because sometimes it's easier to write out the logic in the Python code than to have 5 fields for what you can represent in one node.
Yeah. And it can kind of turn into noodles too. You see just noodles everywhere. So like being able to simplify that down in a Python node kind of helps a little bit sometimes too.
Totally. Well, thanks a lot, Łukasz. And everyone, please check out him on socials. I assume you shared those at the end of the presentation. I was dealing with some technical difficulties and didn't see them. But thanks a lot for joining us and presenting at Virtual NAB.
Yeah, thank you guys.
Yeah,
you guys are amazing. Thanks so much for having me.
Well, thanks for coming. So up next, we have Penny Niederlander, who's going to show some really great details on how she worked on the, and I forget the name, Birds of Prey, the latest Harley, I can't even say it. Sorry, guys. the latest Harley Quinn film. I'm a comic book failure. So here's Penny.
Hello, everyone. My name is Penelope Niederlander. I am a motion designer, and I also do, VFX and illustration and stuff like that. And Maxon has been awesome enough to have me here to do this demo of a project I recently worked on. So this is for the main on ends, or the animated end credits, for Birds of Prey and the Fantabulous Emancipation of One Harley Quinn. I don't know if you've seen this movie yet. There might be some spoilers for it in this demo, but not so much. You should still enjoy the film after you see this demo. So anyways, let me start by showing you my reel so you can kind of get an idea of the kind of animator and artist I am. And without further ado, let's play that.
I got my own style and I got my own grace. I work my own angle, what you trying to say? I got my own cut means I set my own green. And green not monsters be first on the scene. Your foxes, eyes in the sky. Gonna slip quick like, can I get a ride? Can you get a ride? Me, can I get a spot? I see you throwing shade out the corner of my eye. I'm from the ghost, so I keep moving on. From the freaks out night to the early morning. Blue motherfuckers done got me gone, and we ain't leaving till I get some. I got my records, I got my own tapes. Shoes, Louboutin, power suit, super cape. If you get to your bitch, say it to my face. They're 331 5988. Holla. Don't step to me, get fresh with me. Don't step to me, get fresh with me. Step to me, get fresh with me. Get fresh with me. Got my own rhythm and I got my own bass. I got my own kickers and my Mercedes. Got 5 on the ride, baby, I got traits. Like Shania and I gotta keep it grace. Wax on shiny, Gucci gutters whining. Chillin' at the Super Wars, checking up behind him. I got my eye on them and I grind on them. Even pop that booty when I'm right, man. That's right, I'ma learn you how. I moved up and I got my own piece of pie. Not pizza pie, but I got a good record like Domino's line outside for 5. So you wanna kick it to a damn ass John with my man coat chillin' and my glasses on. Don't step to me, get fresh with me. Don't step to me, get fresh with me. Step to me, get fresh with me. Get fresh.
There we go. That is my reel. Let me go back to this card. I've been doing motion design and all this for almost 18 years now. I started in 2002, and from my reel, you can see I do a lot of different types of work. I do live action, animated, 3D, 2D, hand-drawn stuff, whatever. And I've also, as you can see, done a lot of title work for movies and shows, main titles, end cards, all that stuff. And a vast majority of that title work is for a company called Shine. And so I want to take a moment to talk about them a little bit because this project was done, Shine did this project. I worked on it in LA for 7 weeks with Michael Riley, who is the creative director and co-principal, and Bob Swenson, who is the executive producer and co-principal. Shine is a really cool, smaller shop. And here, let's kind of take a look at some of the spots that they've done. The Birds of Prey, Dickinson, Raisin Dion, The Tick. I've worked on a few of these. My reel is probably half work that I've done at Shine. Let's click through to Birds of Prey. So when Michael and I were chatting the other day, last year, we like to both draw. He was just showing me some of the illustrations he'd been doing in Procreate on his new iPad Pro, and I was like, "Oh, I draw too." And we kind of shared back and forth some drawings. And he said, "Oh my gosh, I have a project that I think you'd be great to work on. Would you be interested in working on this Harley Quinn movie that's coming out?" And of course, I've never worked on a superhero titles before, so I'm like, yeah, of course. And it kind of just began with sharing some Instagram posts of each other's. And he let me bring in 2 animators I've worked with before, Amanda Gutera, and we'll link to her information later, and Mike Chapman, also his information is at the end. I was the lead animator. Michael drew the boards and was the creative director. Amanda was an animator working in After Effects and also doing drawing. And Mike Chapman was a cell animator working in Toon Boom. And, so all around, this project was sort of multidiscipline. We had, After Effects, Cinema4D, Toon Boom, Procreate, Photoshop, and, and a pretty small team. It was just the 3 of us animating. And me, Amanda, and Mike. And we put this together in around 2 months or so, maybe a little bit longer. So without further ado, let's take a look at the actual Birds of Prey main titles, the main on ends. So here we are.
Shiro, bitch, don't try me, ho. Bad like a villain, I pop it and then I reload. All the best things in life come for free, but don't you think that applies to me? I like baguettes, flawless, princess cuts. I'm expensive, reckless, and dangerous. Hey, look at me, boy, you can see I don't need you. I give my respect when I come through with my crew. Broke up with my ex, dumped them in the text. Would wish you the best, but I already left. Date night with my bitches, getting real twisted. Be a fuck boy, give my ass a bunch of kisses.
I love me this much, my pear shape on dripped up on blowing on my back. Diamonds got girls best friend. Diamonds got girls best friend. All my bitches ratchet and afraid to catch a case. VBS is on me, bitch, I flooded out the face. Diamonds got girls best friend. Diamonds got girls best friend. I don't need you, I got flooded up against. On your face, I put on my cigarette.
I know how to work a gun, I don't need a range, and I can take a hit, I ain't scared of the pain, and I don't really bang, but I came with the gang, and if you get too close, I might snatch off your chain. Oh, you want me to be a little more ladylike? Come through with my girls and beat your ass on ladies' night. Ay, you don't wanna go toe to toe with my pedicure, everyone you know, be like, bro, how you handle her? Diamonds on my new boyfriend, so that mean I will never ever fuck with you again, and I ain't never need him, so it's so easy to leave him, and I be doing me, I ain't never trying to please him.
I love me this much, my pear shape on dripped up.
And there we go. That is the main on ends. Ooh, I forgot to move to the next card here. All right, you can see that our client was DC Warner. So first things first, we are going to kind of just jump into some of the boards that we were Sorry for that email sound that just came through. All right, so let's pull up Penny, NAB. I think it'd be fun to, now that you've seen the main titles, that you would get a chance to take a look at what some of these boards looked like initially that we worked on. Oh, this did not make it into the cut, but here we go. This is about where it starts for us. Michael drew all of these frames in Procreate on his iPad, and you can see that it's a very sketchy look. It's kind of flat looking. I don't know why this little thing pops up. That's annoying. Oh. It's sketchy. It's bright colors. It's not very many colors per frame, so that each frame has sort of a little bit of a manic look. It's I like to think of this as Harley Quinn's sketchbook. This is her sketchbook that she drew during the movie, or looking at her hangout. See, all of these elements are drawings of pieces of her lair, the booby trap. It's this abandoned fairground where she kind of has her little home base. And so all of these ladies with the legs for hair, and these are all cut out large pictures that are in her in the booby trap. There's a lot of elements that are structural. The red swoopy pieces are structural. A lot of these odd shaped kind of few polygon pieces are big reflective mirror monoliths. So a lot of the inspiration that Michael came up with was from the actual set. And we received a bunch of photos of the pre-production of the set, so we had an idea of the layout and all of the elements. And so what we're going to do during the course of this presentation is we're going to kind of go through the four main production stages for all of these shots, and focus on the Cinema4D elements in particular. So first thing is modeling. Everything in here was modeled very simple. It's simple shapes and projection modeling. It's all hand-drawn looking, so it really doesn't matter for these things to have a lot of polygonal detail or textures that are realistic, and it's just that's not what we're doing here. So I'll show you how we used simple shapes like cubes and spheres and extrusions to create the shapes, and then we will move on to texturing. The texturing, because the majority of these shots are done in After Effects, it's mostly a 2.5D project. So we took some of Michael's boards and redrew the elements and split them up into different layers so that we could have, let's actually shoot over to the actual main title. So you can see that there are elements like this character right here, for instance.
Give me, boy, you can see.
This is all drawn in Photoshop, multiple layers split up. This hair was animated by Mike and Toon Boom. These elements were, simple drawn shapes placed in space.
Give me, boy, you can.
Let's see. Let me turn down the volume on this. Everything feels flat by design. We want it to look like we're bringing to life the sketchbook. These 2D elements. So the Cinema4D portion of the project is really just trying to extend and give us a little more leeway to represent shapes and concepts and feelings that we just kind of couldn't pull off in After Effects because it's not a true 3D program. Next, cameras and keyframes. That is basically just how we animated the camera and some of the elements very simply to extend that storytelling aspect of the project. And lastly, we brought everything into After Effects and used elements that were both created in After Effects and drawn in Photoshop or Procreate or Toon Boom, to bring it all together and then treat it with color and glows and texture and warps and stuff to make it feel unified. So without further ado, we are going to jump right into Cinema, and we're going to talk about modeling. So for modeling, let's start with the actual booby trap set. I'm going to show you what it looks like. This is the set. Let me turn off the camera. This shot is great because it actually has all of the elements of the set in it. Some of the other shots that include the set were just partial elements, but this one brings it all together. So as you can see, it's very simple, a lot of real simple shapes. And I'm going to go over how we modeled these from the previs concept art. I can't show you the concept art because it's not ours. It was done, contracted for DC Warner. But I did the next best thing, which is, oh, that is the wrong window. Let's go into here, NAB, and fake concept set. So what I did was I took a picture of my desktop, my actual desktop, with a couple shapes on here and a couple objects, just to have something to work with that's simple. So what we're going to do is we're creating a new cinema project, and we're going to use this element. Where are we? Here. Let's copy this path. Copy. And we're going to, first of all, create a new material. It's going to be a standard material, very simple. All we're going to use is the color channel. So let's link to this picture. Concept set. Do you want this? No, that doesn't matter. All right, that's all that's going to take. So we are going to try to replicate what this looks like. Now, right now, it's just projected. Well, not even projected. It's just a texture using the UVs placed directly on top. But now to emulate what the camera is that shot this photo, I'm going to create a camera. I'm going to make it active, and I'm going to make this texture camera mapping. Now let's see what our settings are. We're set to 1280 by 720. That's great. That's fine. That's just an HD resolution. But we're going to have to change this to HDTV to be 16:9 and use this camera. There we go. Now, because this will then show this full screen, it makes it a little more difficult. So I'm going to change the U and V to 50 and 50, and then I'm going to offset these 25 and 25, so that if we zoom in, we can see that we're just dealing with the centerpiece. So as you'll notice, as I move the camera around, the image is locked to the camera because the camera that we are viewing through is also the camera being used to project. So what I'm going to do is let's go with shaded line. And now we're going to really quickly try to line this up to match roughly what the desktop is. Now, I'm not 100% positive, but let's see. Let's go to a 4 view. Let's change this to shading like this. We're gonna try to make it so that it looks like we're looking down at the picture in this view. So in this case, you'll notice that these elements are square, these coasters. So that's something we're gonna wanna line up. Now granted, if you know the information on the focal length of your camera, that's gonna make this a lot easier. I don't know what it is because I took this with my iPhone and I just don't know. I think it might be something in this range. I think I found 26 somewhere written. Hey, that looks okay. That looks fine. That looks great. So we're just gonna zoom out a little bit so that it's mostly looking at there. Okay, good. So first thing, let's just match one of these simple shapes like the coaster. So I'm gonna create a cube and, oh, first of all, let us make a new camera, because with a new camera, we can now move around the scene and that texture is locked on. So let's take this camera and go down to rigging. and just give it a protection tag. That way we can't move that camera around. So now our ground plane, solid, great. All right, so this cube looks like if we move this kind of over to where we can get an idea of length. All right, cool. So 75, about 75 to 75, let's call it. And now we can just sort of line up our, our cube to line up with that coaster. That looks pretty good. Let's do another one. Let's take this one. Let's move it along the ground plane by grabbing the green. There we go. And then let's rotate that into place. And you can kind of see it over here. An easy way to make this a little easier for you is to take the same texture and apply it. So now you can see that I apparently did not get the the focal length correct. So we can go back and we can, let's remove this protection tag. Let's say it's not 26. That is so much smaller in the background. Let's just see what happens if we do this. And line it up. All right, okay. We're getting there. Cool. So if we move this roughly into space, you know what? Honestly, for what we're doing, this is fine. Good enough. Next thing we're going to do, well, let's put our protection tag back on here, is we're going to show how you can build something up from that ground plane. So what we're going to do is we're going to take a circle, and now in our overhead view, we can take this circle, move it over here. First of all, it needs to be XZ. Let's scale it down so it's at the base of the coffee cup, approximately. One thing we can do is just drop this down, -0.1, and turn off those. So now we can see our circle a little bit better. So this is the circle from directly overhead. And then let's take an extrude. The extrude is automatically going to go in the Z direction. So let's instead build it up from here. And now if we look over in this view, we can build our element up. So let's put that on there. I mean, I know this isn't lining up quite correctly, but if it's good enough for laying out what the floor would look like. If we come back here and we use our spline pen, I've got it set to Bezier. I'm kind of a fan of cubic, and we're going to try to build this floor element. So I'm just going to really quickly just grab a couple points here, try to match this shape. I mean, luckily with the Birds of Prey stuff, it's sketchy enough that it didn't have to be perfect. But there we go. That's pretty good. One thing you can do, though, is see how this is a little bit on the grainy side? It's a little hard to tell where these points go. If you open up your material, you can go to Editor, and this default is pretty low. So let's turn this up. What's 512 look like? 512 looks better. Let's go, there we go, 1024. Now we can see that we didn't quite hit all of the points we wanted to hit. So we're just gonna scooch these around, finesse it. We want it to be roughly where we want it to be. You know, it's an approximation. And, you know, if it was important, we could go more nuts with it. So there we go. And give this another extrude. There we go. We have the beginning of our set. Granted, like I said, it would look better if you matched this up to be the exact same angle that the camera was taken from. But for us, let's remove those, and we get a pretty good start to what this set would look like. Fantastic. The next step is using a very similar method. We're going to work on the crossbow. So let's open up the crossbow project. I made one special for this demo. You can see this is the crossbow. Let's actually look at the shot. That should be right about here. That is Mary Elizabeth Winstead, who was awesome in the movie, by the way. You may know her as Ramona Flowers from Scott Pilgrim. So here we are. These are actually right next to each other, are the two most 3D shots that you probably would notice in the piece, because they have a little more dimension to the actual elements that make them up. But the crossbow is probably the most complex bit of 3D in the entire piece. But I'm going to show you just how simple it was to build. Take a look at the boards for this shot real quick. So this is the Winstead board. Let's open that up. So this is what Michael drew. This was our board. And I was like, okay, yeah, we could draw this crossbow as sort of like a 2D object, and maybe give it a little bit of dimension somehow with some layers and After Effects. But I really, felt that she deserved a complex 3D element because she's awesome and that crossbow is really cool looking. So what we did was used another form of projection mapping. It's actually very similar to how I recreated the concept of the set. So what we did was, I just sort of gave it away right there by turning on that layer. I found the angle that, there we go. I think that I figured out that this angle right here approximated the camera that shot this crossbow. And so I did the same thing, that I lined up to the lines and the dimensions of the crossbow and then projected it onto this plane that you can see right here. And, camera mapping, yep, ref text. So it's this one right here. So the next thing is, I really just, it's a fairly simple set of shapes, ultimately, that makes up this crossbow. So I think that I can do this with cubes, right? Look at this. It's basically just a long, elongated cube here, a little bit of a wider cube here. Let's just move this out of the way. A lot of these pieces, I don't need this detail. I'm going to draw the textures and the detail. So by just creating this plane and running it along the center YZ axis, there we go. Now we can kind of move around. And if I sort of take this cube and line it up along with the center, because it's being bisected, it's obviously wider, it's going out on the other side, but this is the center. So I'm going to line this up to where I think the center would be. I'm going to go about, all right, that's about how wide it is. If I move it to here and kind of extend it, I can find roughly where it's going to live. Like, that looks pretty good. Okay, I'm going to make another cube. I'm going to take this cube, I'm going to make it a little wider, and I'm going to scoot this one to the front. Now, let's take these textures that are projected and add them to the cubes we're working with right now. So this will give us a little bit of a better idea of if we're hitting those marks. So this is looking a little, all right, there we go. That's looking better. It looks like it's a little wider. Cool. And, it's got this sort of beveled edge on the side, this sort of filleted edge. So let's give it a filleted edge. Why not, right? Look at that. That looks like it kind of nails it. And so we're super simply building out this crossbow. So we used cubes for places like that. But then, more complex parts of the model, we would do things like, let's just say, let's take a rectangle. Let's make it YZ. And we're going to build out this handle right here, how I built it. Oh, that's not YZ. XY? Nope. XZ, that's the one. All right. So now what I did for this was I roughly found where it sat, and I can use the side view, which is right here, to line it up approximately, like, it's taken from a 3/4 view, so it'll have this rounded edge where the bottom is. But if I kind of imagine where the profile points are, I can rough it pretty simply. So another thing I did was let's round it out a little bit. That might be a little too round, I don't know. Also, it's probably a little wider, but that's not bad. All right. What I'm going to do is I'm going to use the loft tool, And I love modeling like this because it's so easy. I'm just gonna move this up a little bit more, move it over here. That's great. And I'm just really roughly building out this shape and adjusting the size as I go. And I can work in the multiple views. I can look from the side, which can make it really a little bit easier to, oops, that's the wrong one, to find the contours. I can take this bottom one and add another bottom one. And you know what? It might be a little rounded. So why don't we just make this a little smaller? There we go. That's it. That's how I made the handle. It's super duper simple. And another method is to use actual extrudes of splines. So for this section right here with the trigger, oh, actually, you know what? Let's just finish this because I did do this. Let's make this a little bigger. Okay, let's remove the rounding a little bit more, just subtle. Move this up to here. And a little shorter. Just like that. And then this one is going to be longer right up here. Okay, so there we have a very simply modeled gun. Let's turn off the plane and kind of get a look at what our model is starting to look like. I can also use our texture to project it on. It's going to be rough, but it'll start to give us an idea of what this shape is in 3D. Super simple. So let's go back, turn that plane back on, and do this little trigger area. So I'm going to select my pen tool, and using the side view, even though it's, you know, looks a little funky and you sort of have to guess, I'm just gonna super duper duper simple create that shape. Okay, so if we look at over here, you can see it's not rounded. So let's change this to cubic. And didn't do it. Actually, we need hard edges, so let's just turn these to soft interpolation. Okay, so now we're getting an idea. Let's turn off our that. All right, so now we can come into here and just sort of finesse it a little bit, find a little bit of a nicer shape, kind of smooth out. Where is it? Sometimes you have to, I have multiple shapes selected. That always screws me up. My bad. All right, now we are solid. So here we go. Let's turn back on our plane. See where we're at. Dope. Okay. So now, with this, I'm going to create another extrude, throw my spline in the extrude. In this case, I'm going to take our spline and pull it out just a bit. That seems about right. And then we're going to extrude inward. And if we look overhead, we can see about how, okay, that's probably a little wide. There we go, that looks pretty good. Let's take a look at our model. All right, solid, fantastic. And then let's turn that off for now. I'm going to create a cube. And we're going to cut it out. So here's this cube. Let's make it a little taller to about the height that it needs to be. About the distance it needs to be. Let's make it wider because we'll need it to be wide once we do the fillet. And then we turn the fillet on. Let's crank all the way up there. And so now you can see that we have both, turn the extrude back on, the shape of the outside and the inside. And we can use a Boolean operator to knock it out. The extrude will have to be on top. And there we go. If we move this cube up a little bit, there's, you know, a little bit of creative license in this. But we can also adjust the points to make this feel a little more accurate. There we go. Okay, so let's check out our gun. That is coming together pretty good. Well, it's not a gun, it's a crossbow, but you get the idea. So there we used, you know, a projection onto a plane to match the camera and have a base for what this should look like from the one angle, so that we can work as if the gun is lined up with the gun in the photo. Crossbow, not gun. And, you know, from the super simple creating a plain cube and lining it up to the right spot, to creating a loft of just a bunch of simple rectangles to give it the rough shape, to using a Boolean to knock out an extrude. This really comes together very fast. So we're going to sort of jump around here a little bit. We are going over, let's see, modeling and then texturing, but it makes more sense for us to stay within this model for now. So we're going to talk about texturing of this gun and then go over to some other objects. So for modeling, let's turn off the elements that we created just now. Or sorry, not for modeling, for texturing. And let's go crossbow all static plane. So this is the model without any textures on it that we came up with for the actual shot. You can see a lot of really simple stuff. These are just cubes. This is like how many, what is this, like 12 polygons for this site. This is some more Boolean cutouts. We have a simple sphere for the back. But I want to show you how simple it was to texture elements of this. So one thing that I did was taking this crossbow element, and if I select the bow section and go into my hierarchy and find the bow and turn this off, so we now just have the bowless piece of the crossbow. And if I come into my side view, I can see what this looks like just perfectly from the side. And this is going to be a super lo-fi way to do this. So I am using my snipping tool. This is literally what I did. I'm going to just take a picture of this. I'm going to copy it, go into Photoshop, create new. It will already have my dimensions of my copied snip. And I'm going to paste my crossbow in. And here, now I have a projection-ready backdrop for my piece. In the case of this project, I did scale this up so that I had a nicer resolution to create higher resolution textures. But in the case of this demo, I'm going to keep it just at the resolution it is. I'm going to create a new layer. And this layer is going to be what we paint on. Now, forgive me, I am painting with my mouse, not my Cintiq at the moment, so it's going to be a little rough. But this is going to be an introduction into how we created the textures. So I'm going to backtrack really quickly and just talk a minute about how we sort of developed this sort of hand-drawn flickery look. All of the elements that were in the entire piece, there are 3 individually drawn frames of each image. So if there is a lady with legs for hair, she was drawn 3 times over top of each other so that we had 3 frames to flip between, like a flip book. And we did this on 2s. So image A would play twice for 2 frames. At 24 frames a second, it would be AA, BB, CC, AA, BB, CC. And this would give us a little bit of a living hold for our drawing. So now let's just color in a little simple cube section here. So I took Let's see, this blue color looks great. Okay, so I've got a brush. Let's make the brush a little smaller. Let's make sure it's firm. You know, we do a little bit of a scribble situation here. I would often do the edges. Oh, it's going over. It's fine for what we're doing. It's no big deal. And then I really am awful with a mouse. Oh my God. Okay, that's good. Let's just take our eraser tool and let's just really quickly erase away around those edges. And then there we go. Okay, let's also erase that. And just there we go. Perfect. Okay, now we are going to make a new layer and another new layer. I'm going to lower the opacity on this one so that I can see what I'm drawing. Okay, so we're gonna really quickly do that, roughly like there. In reality, we spent days and days and days coloring these in. Okay, great. Now let's do our last layer. And super good, voila. Finished coloring it in. I don't actually care that that went over. That is totally fine. All right, so B, oops, C. Great. Now what we're gonna do is let's bring the opacity back up on this layer. Let's turn those other ones off. And I'm going to go, actually black is totally fine, it doesn't matter. Save as. And in this case, I'm just gonna save it as a PNG. All right, we're gonna go back into our Cinema and we're going to create a new texture. So File, Materials, New Standard Texture. I'm going to take this little element right here. Let's see, I can take this and just drop it directly on there. And then in our material, what we did for this is we worked in the luminance channel. We didn't need shading, we didn't need shadows or ambient occlusion or anything. So we worked in luminance, and I'm going to grab, let's see, into our C4Ds and our text directory. I'm gonna find our NAB temp directory and CB01. Okay, so open. I'm going to go into animation and calculate. It knows that there are 1 through 3 total. And I'm gonna set this to 12 frames a second. And so right now, this is projecting pretty much the bounds of the shape. So what I can do is go back out to my side view. And if we find the cube, if I set this to flat and then rotate this, I'll be able to move this around. There we go. That's better. It's just the wrong size a little bit, but there we go. And now if I hit play, oh, my bad. Back in here, this is sort of the crux of how we did this, is because it's animating, you do still have to go into your editor and do animate preview. That button is super important. So once you have that, oh, and also super important, animation simple, you want this set to loop. So now if I hit play, you can see that my squiggle vision is working here. Let's go into this one. And the 3 texture frames that we saw are now playing back. And you can see they are doing it on 2s. So if I step through frame 0, 1, 2, 3, 4, 5, and then back to 0. And that makes it very cool for seeing what this is going to look like in real time. And I'm going to show you what that looks like textured as we textured it with the real textures. Now I play this back, I can really see the shape. And let me turn on the black sphere in the background. That's pretty much the look. Like, this is this is very similar to how it looks when you render it. So let's take it and just render this frame. Boop, pretty good. And then lastly, we gave it animation. Here's the actual camera. And so that's how the crossbow is made. We have covered modeling and texturing. The next thing we want to talk about is cameras and keyframes. So I think a really great shot to talk about cameras and keyframes is this Rosie Perez shot. I love this shot. It's so simple, but I think it's a very cool shot. So if we head over to the player, you can see here what it looks like in real time. And let me pull up the board. So Rosie Perez, oh, well, I screwed that up. Rosie Perez. The board was this badge, flat and tilted, canted, put in the background. And then we had a Rosie Perez's silhouette and some elements that were from the set. So these are supposed to represent simple color swashes of the sort of, I don't know what they are, curved girder shapes that are in the booby trap. Now, I could have used this all as like flats and done this in a very flat way in After Effects, and it would have looked cool. But there was something about the storytelling of this shot that was important to me. Rosie Perez is this cop. She really believes in, not necessarily the police, but she believes in the law. She believes in doing the right thing. And so, the badge is like a symbol for her. She really is struggling with being a cop in Gotham at this time. And I felt like we could do something really neat with this badge that felt like, that made it feel huge and made her feel like she was, silhouetting this big element that represents her. And then the camera move tells the story of distorting that view. So if we go back into Cinema, I'm going to sort of recreate how we did this. This is a sort of classic Vertigo camera move where you change the focal length, you animate the focal length and move the camera at the same time. Sort of counter to each other so that the character stays about the same size, but the world changes around. And on frame 0, the very first frame, I wanted it to look like the board. I wanted it to feel like, oh, this is flat. This is a flat moment, flat set. So I'm going to make a new comp here, a new project. Nope. And really, I'm just going to recreate this, what do you call it? Psych in the back of her that I projected the texture onto. And this is an extremely simple thing. So we can see what it looks like in terms of the geometry. This is just a plane. It's 10 by 10. We don't need these vertical ones, but we're just gonna like really quickly. There we go. Perfect. So we have a plane, and it's got a lot of resolution to be able to bend it. All I did was throw a bend deformer on here. Going to curve it, turn it to the angle that we want to see it at. I'm going to make it shorter. And there we go. That gives us what we want. So now if I, wrong one. If I bend this up, let's change keep axis length to 90. I have a very, very simple little psych. I could go in and make the geo a little cleaner so these are, one big poly or whatever, but it really doesn't matter for our test, and this is not a lot of polygons to begin with, so this is fine. That's perfect. In fact, let's take this and just move it a little bit farther back. Good. For the sake of understanding how this is built and how this works, I'm going to use a very simple texture. I make a new material. I'm going to use a surface checkerboard. There we go. That looks great. I'm going to take my camera. Now this is going to be my starting position camera. So what I want to do, I'll try to remember to do this correctly. Let's see. Let's start at 50. Let's see, right about there. That's good. I'm going to, with this checkerboard, do this again as a camera mapping. HD, I'm going to assign my camera to it. So if this is our starting point, this looks right. These boxes look like right angles squared to frame. They're a little wide because the texture probably, there we go. Let's just make it a little bit more that they're squares. Perfect. Okay, so now with this in place, and pretend this is the badge, but this will give us some really good feedback. And also, you know what? Let's do this. Let's take a, let's just say a cylinder is going to represent Rosie Perez. Rosie, you are a cylinder. Great, okay. Let's make this a little skinnier. There we go. So this, oh, that's not, there we go. Okay. So if we move this around, let's find a good angle so we're kind of low to the ground. Perfect. Okay. So now I'm going to use this camera as projection camera, so I know not to touch it. I'm going to make a new camera. It'll make a new camera with the exact same features. So it's still going to be 50. But now, this is so simple. I'm going to take my camera. At frame 0, I am going to, using position and rotation, I'm going to make a keyframe. I'm going to go to frame 60, or whatever. Let's go to frame 90 all the way to the end. That's great. And I am going to push in. Cool. But at the same time, I'm going to animate the focal length. So at frame 0, we're at 50. So we are looking straight on as if this texture back here is flat. But at frame 90, I'm going to open it up, make it a lot wider. Let's bring it down to 24. And then zoom in even farther and keyframe. And so now we're getting that vertigo effect. It's stretching out the world and making it feel a little weird and odd. I also like to give the camera a little bit of rotation. I think that's fun. And because when you're shooting in film, or really anything, it's very rare that you shoot for the exact time you're shooting. And these eases in and out will not feel very natural. So if we play it, it'll look like, oh, it looks like we're easing out and we're easing in. I don't find that very interesting for this shot, so I'm going to set it to linear. So it feels like once we cut into this shot, we're already moving. All right. Fantastic. So another shot that we did something similar in is Hall of Mirrors. Is, you know, we like to motivate what the feeling of these shots are. So in this case, we are creating a sort of world where you don't know what's going on. The intent of a Hall of Mirrors is that there are mirrors and they're reflecting everything and you don't know which way is up and which way is down and which way is in and out. You don't know what's a real wall or a reflection of something else. So in this shot, I felt like the camera really needed to feel off kilter, to make you feel like you weren't sure which direction is up. Plus we were moving from another shot where there was a camera move. So if we bring up our cut, you can see that, there we go. We sort of matched movement a little bit. Not perfectly, it's not an exact one-to-one continuation, but it feels like the world is falling away and now we're rising up and kind of drifting through this other mirrory world. So there we are. I think that pretty much covers cameras and keyframes for now. That is the last element, if I can find it, the last step in the process. And so for that, we're going to really quickly jump into After Effects. I'm going to focus on this shot because this is another 3D shot, but it's also married to a 2D shot. This is Bloody Eye Girl. So the first of the two shots that marry together is in After Effects, and it transitions into 3D in Cinema 4D. A little about this shot. This was animated by Amanda Gutera, and the blood dripping was cell animation by Mike Chapman. Very cool. It's a little bloody eye loop. And she animated the woman with the puppet tool in After Effects. In moving into this 3D shot, it was really important to try to marry these two together. Now, the camera move, the cut is a little not fluid, but that's by design. Like, we really wanted it to feel jarring, like a sudden pop out of that shot into this other world. Like, we have a little bit of a camera shake that motivates it. You can see that there's a little bit of distortion when we move really fast. So the world kind of goes woo, a little bubbly for a second. And all of this is to flatten out the 3D shot and to give a little bit more of a continuous feel between these two shots. So if we head back into After Effects, we can see what this looks like. I'm going to play just the cinema part of the shot. So this is again using several pieces of the set. We see a little bit of the House of Mirrors on the left. We see a couple flats of characters. This animation of the blue hair girl with the bloody eyeball, that is just the After Effects project character rendered out and thrown onto a plane. So, you know, it's very much this and, if that makes sense. Okay, here we go. So this is the shot, just playing right out of Cinema4D. You can see that we don't have any of the distortion. We don't have that sort of blobby lens thing happening. But I want to talk about all the different elements that we do put on these shots. For moves like this, I will animate a CC lens to give it that sort of warp push feel. You can see how it distorts if I turn this on and off and then go a little bit more into the actual move. It really distorts it. And it's just a fake lens feel. It kind of spherifies the lens a bit. It's CC lens. It comes with After Effects. It's a great little plugin. And then also we have this element of turbulent displace. Something that we were doing in this entire project was we needed to streamline the process as much as possible. So when we have a character or a set, these elements, like, they already are squiggly. They're squiggly drawn. They're just 3 frames looping no matter what element it is. But if you were to sit on that frame with it doing that, you would see the pattern of the 3 frames going 2 frames, 2 frames, 2 frames, 2 frames, 2 frames, 2 frames. And so we added this animated turbulent displace where the evolution is being animated by an expression. It's just time times 300. So I'm going to turn on a shape layer here so you can kind of see. I have another shape layer on top, and this is just going to kind of run through how we treated everything from 2D to 3D. This with the turbulent displace only. Do you see how it's kind of just wobbling it a little bit? It's giving a little bit of variation throughout, so that when we do have something that's sketchy up, even though that is sketchy, it's changing it a little bit. And then if we add the CC lens, you can see that it, in the best of times, will give a little bit of a curvature to it, no matter if it's a 2D or 3D. And then we also have a turbulent noise. We have a black layer underneath everything so that it doesn't affect the black, it's just affecting color. It is multiplied on. What that looks like is to give a little bit of a feeling of watercoloriness or just grunge. It's just really a grunge effect. And it animates just slightly. It's not very much, but with the camera moving around, you don't really see the 2D screen nature of it. And then lastly, we have this glow. It's a very simple little glow. I can back out of these shapes for now and show you what it looks like on the actual footage. It's just a bit, it pops it. It makes it feel like it's backlit a little bit so that the colors are glowing through the blackness. And the very last element that ties everything together is we added some particles to it, and these are all hand drawn. Everything in this is hand drawn. Nothing is, there's no perfect spheres anywhere for any of the particles, for instance. And so to show you kind of what that looks like, let's see. We have particles in the background. We have foreground particles, and those sit in front and back of the 3D elements and 2D elements. And we can go into the animated dust so you can kind of get an idea of what a hand-drawn particle looks like. It's this little thing. It bursts into being. It living holds, and then it disappears. And this is the one particle we used over and over to drive the particular. So particular is looking at that element. It feels as if we drew every particle in a way. Let's see, and I think we maybe have a couple other little elements that we threw in on occasion. So you can see these are the extra little pieces, just to make it feel a little bit more chaotic and hand-drawn to unify the 2D and 3D. And there you go, you can see the stars right here. We have 2D After Effects elements drawn in Photoshop and Procreate. We've got a Toon Boom dripping blood. We've got Photoshop cell animation in the form of particles and this star and these little whizzing around particles. And then we have all marrying together the 3D environment of this shot. That's really the secret sauce that created this unified world of 2D and 3D and After Effects and Cinema4D and all these software. I think that really touches on everything. So I'm going to go to my last frame, and here we go. We're going to talk to Matthias, or I'm going to talk to Matthias in a second. But in the meantime, I really would like to thank Shine and Michael and Bob of Shine and Young, Amanda and Mike for animating this with me. They're amazing. AmandaGatera.com, MikeChapman.com. You can check me out at pennyz.com and at Baffled by Foxes. Go see Shine's work at shinestudio.com. And I hope you enjoyed this presentation, and I can't wait to see what you all think of it. All right.
All right, ladies and gentlemen, welcome back to C4D Live. I'm Matthias Omatola here at Maxon U.S. headquarters in Los Angeles, and I'm accompanied by Penelope Niederlander. Thank you so much for that presentation, Pen.
Oh, yeah, it was a lot of fun. Thank you for having me.
Yeah, so I think we're going to dive in to a question of great importance, which is your favorite comic book person.
Oh, am I allowed to have three?
I'll allow it.
Okay.
Survey says.
All right, because it's kind of a three-way tie.
Okay, yeah, we'll see. And then we'll put them in a death match. All right,
okay,
death battle. All right, who do you got?
Hellcat. I've got a Hellcat tattoo.
Okay.
Patsy Walker. I'm a big fan of Captain Marvel. I got my necklace on. And then Gwenpool is probably top of the charts favorite.
Gwenpool. Wow,
yeah.
You got you have a very. I don't know Hellcat much.
Hellcat's great. It's part of all new, all different Marvel. The latest ones, and they're just wholesome and fun, and she has friendships and kicks some ass.
Personal life, an actual personal.
They're all three are a little messed up and are coping with being a little bit of.
Yeah, Captain Marvel. I never really followed much. Classic Carol Danvers in the black suit. I'm more familiar with. But then the new one, I've kind of caught up a little bit on the new Civil War, and that was exciting with her and Tony. But anyway, no spoilers. Check it out. But yeah, all quite interesting. I got to look up Hellcat. All right, so we'll dive into tech stuff. Fine, internet. I'll ask questions that are important. All right, do you build your own toon shaders, or do you do them in Photoshop? What's your process on your shaders with the toon stuff?
I've done a lot of sketch and toon stuff, and I've used cell renderer and other methods of doing toon shading. For this project though, it wasn't really about edges, and we wanted to have specific looks to match the drawn 2D After Effects 2.5D look. So all of the textures for this were drawn in either Photoshop or Procreate. Okay. And yeah, because, we wanted to have like a very specific 3-frame, frame A, B, B, C, C loop to give it like a living hold feel. And so that was just easier to do that. I drew on my Cintiq in Photoshop with the animation toolbar.
Very cool. Let's see here. What else we got? Were entire models textured or just the front-facing polys? So just the stuff facing the camera, or did you texture the entire thing?
I mean, it depends what it was. There were the different 3D shots have sort of different demands. The hammer was textured completely all around. There were some tricks involved, like mostly the top of the hammer, for instance, and most of the handle was just flat on. I drew those textures and put them on essentially cylinders. And then I did some Espresso stuff to make the part of the handle look like it was always glinting in the same direction. So it always looked at camera, but rotated around. The crossbow, I only did the one, like anything, only what you'd see from 3/4 view. But a lot of the textures were projected through anyways, so it probably looked correct on the other side. I'm not sure.
Good enough.
And, yeah. And, but like, and then the booby trap, a lot of things were on flats. So, those were pretty straightforward.
Yeah, let's see here. That answers that. How do you manage to, well, I'll jump to that one next. I like this one. This one is a timeline for the breakdown of the project. So how much time were you given for this whole scene?
I want to say that I was in Los Angeles for 7 weeks. I did 1 or 2 shots at home the week before, and I kept working on it a little bit after. But for the most part, we were knocking out, Amanda and I, a shot each every between 1 day and 3 days. So the crossbow and the hammer probably took more like 2-3 days each. But then like the Rosie Perez shot, that was a day. Honestly, the most time spent was drawing the textures because they were so, like, they had to be different but about the same. So even though it was really sketchy, you had to make sure that if it was a little less dense of sketchy lines in an area, you had to maintain that in the other 2 frames. So it would take a whole day.
And it's all by eye, so you don't have just it's not procedural. It's
you can't really do that procedurally. Yeah.
So let's see here. This was the person one that seemed fun. How do you manage to keep up with your skills across all your mediums? Your body of work and the amount of variety within it is fantastic. So it looks like you have, that's true, you have a wide range. So how do you keep up with your skill set across all of it?
Well, first of all, thank you. Very nice compliment. I mean, one part of it is just I've been doing this for, almost 18 years. And even before I was doing this professionally, I was in art school. And so, and in high school, I played around with this stuff. So, I mean, I've probably been doing computer graphics for closer to, 25 to 30 years, I guess, all told, in some form. And I really like being a generalist because the projects can range in from like a few days to, a couple months, few months. And so over the years, you just do a ton of different projects. And something I really like about that method is I learn a lot better and a lot faster by doing than by deciding that I want to learn a thing. Like if I want to learn a new piece of software or a new technique, I will have to spend some time to like research. But I think it sticks a lot better when you are doing a project, be it for a client or for yourself. Just doing the thing that you have in mind.
I feel you.
Really helps ingrain it and learn new things.
No, it's the same thing. It's like I'll learn it real quick, but it's working on a project and it makes all the difference to make it stick.
Yeah, right there. It's driving me crazy.
Let's see here. Let's see. What was the timeline? We covered that. Are the titles made independent of the music score, or do you have to sync them with the BPM or anything? So yeah, how does that work? Do you get music or?
We the thing with titles it's very specifically like the length of how long titles are up for is so bound in legal terms. Like you can have two different stars with a different frame count on titles in a lot of stuff. So, like the readable words are up the exact same number of frames in every shot. I think most of my shots are 72 frames long. And, we didn't have a final score. We had a temp score of the song by a different artist.
Got it.
And then, you kind of just hope things match up. And when we got the final score, then it would be like, oh, okay, you know what? I can actually make that hit. Or we can like make a couple little interstitial pieces, moves in and out so that we hit these times. And so like that kind of happened more in editorial, kicked back to us, made changes.
Okay, so they would give you kind of some tweaks if they would ask for a tweak, but that was more on the editor, less on you when it comes to timing.
Yeah, exactly.
Okay, very cool. Let's see. How do you handle working with multiple artists workflow-wise?
Yeah, this was an interesting one because I came up working in LA for 10 years. And so I would mostly work at studios, but I would work at home as well. And I would have a server at my house. And I was just used to working off of servers. But since I have been living in Austin for almost 8 years, maybe, I've been working a lot more remote this last year via Dropbox. And because I brought my PC to Shine and they're a Mac office, I couldn't actually get on their network. So we worked off Dropbox, even though we were all in the same room. Mike was in Austin, but Amanda and I and Michael and the rest of Shine were at Shine office. Amanda and I worked at a studio before together for like 2 years, Rooster Teeth. And so we kind of had a shorthand. And I find that familiarity, and that's another thing. I've been working for Shine for like 14 years. So this familiarity you have with people can really make it easy to sort of flow despite, not being in the same city as Mike or starting or ending the project in Austin when Shine is still working in Los Angeles. So I don't know. I think that if you communicate enough, and I will err on over communicating. I would rather spend the extra time to annoy someone to get the right answer and figure out how to do it from get, than assume that I know what the person is talking about or assume that they understand me.
Mm-hmm.
So, as long as like you have like a shared directory, like Dropbox or a server or whatever, and you're communicating, I think that you can do anything.
Yeah, that's awesome. Well, I think, one of your artists down there, Barton Damer, he actually said it great during the 3D motion tour. He's like, when you work with people for a long period of time, like he uses the basketball analogy that, when you're driving in, you can kick it out to someone because you've created that muscle memory. They're always there. It's someone you can trust, that you can, just know that they'll cover you in certain areas. So that's kind of a big deal. So this is going to dive into the personal. Somebody wants to know the dog's name. Who's the cutie in the background?
Oh, that's Murphy. And I've got another one down here that has to sleep next to me all day or pitches a fit. It's a dog office.
So it's Murphy, and which one's that one?
This is Daisy.
Murphy and Daisy. I think that takes care of most of the questions. Yeah. So thank you so much for joining us. We always love having you out too. Sorry we couldn't be out in Vegas and the pinball party and all that other fun stuff, but next time. Yeah, but if there are more questions, where's best for people to reach out when you do have time to connect with the community?
I check in on the MDA Slack and Panimation Slack a lot. You can go to my website and email me through there at pennyz.com.
Awesome.
Yeah, I'm around. I'm cool.
Cool. All right, folks, we're going to take a quick break, and then we'll be back here with Noseman to answer more of your Cinema4D questions. And we've got a few, so this is going to be a fun little segment before Chris Schmidt. So stay tuned. Thanks, Penny.
Create without limits with precision mobile workstations. Maximum power, speed, and performance when and wherever you need it. So you can perfect every pixel. Break ground in unexpected places. And make the most extraordinary ideas a reality. Discover your next big idea. Precision mobile workstations. Create without limits.
When's the last time something moved you? Was it a flash of beauty? A twist of phrase? A bit of brilliance that blew your mind? What if you could move people like that? And what if you could do it with shapes, sounds, design, and movement? When it comes to motion design, we believe everyone deserves the chance to move from novice to superstar. So we've created an online place for that to happen, so no matter where you are, we're there too. We are opening up worlds of possibilities for our students, and we're kind of obsessed with doing it well. Our teachers aren't just skilled working professionals. They're also the top motion design experts in the industry. Our critiques aren't vague and generic. They're valuable insights about your work. Our classes aren't easy. They are intense and effective. A tidal wave of knowledge. And our students aren't faceless usernames watching talking head instructors. We're a tight-knit community of highly driven learners, filled with global collaboration, inspiration, opportunities, and plenty of fun characters. At School of Motion, we take a full art education, strip it down to the essentials, and supercharge it with real-world grit. And we're equipping our students to do amazing things for some of the best brands and studios out there. In fact, this thing you're watching right now, and even this, was made by School of Motion alumni. Now it's your turn to create something truly moving. And we're ready to help you do it. Because the things that move you forward move us too. School of Motion. We're not just a school, we're a movement.
Toolfarm makes waves with amazing deals and fast and knowledgeable customer service.
Swim on in for incredible deals on software and plugins at Toolfarm.
I decided to come to Camp Mograph because it seemed different than the bigger conventions.
Being able to talk to people face to face.
Do archery, canoe, kayak.
Outdoor basics, getting back to nature.
Back to basics.
The storytelling class was phenomenal. Classes that feel really intimate.
Drawing with EJ, that's been my highlight of the whole day.
Sometimes we get caught up in the technical, like how to make this keyframe move, that we forget to take a step back and look at the bigger picture.
Being a motion designer rather than doing motion design.
It really brings out that inner child.
I have to go to this because it's kind of like going back to what I love.
A place where you get to be a kid again.
This is not crowded whatsoever.
There's not as many people. Just get out of your comfort zone. Camping isn't as bad as you think.
This is my new go-to event every year.
My bunkmate is Paul Bapp, and that's where else do you get that?
You're not worried so much about the render times, just having a good time. Cut it.
Can't hold that, we're here with you today.
All right, ladies and gentlemen, welcome back to C4D Live. I'm your host, Matthias Omatola, aka Major VFX on all the social webs and things like that. A couple things I wanted to announce if you guys haven't noticed already. We're giving away over $15,000, I think it's over $18,000 of prizes. So go to c4dlive.com and check that out. Register. HP's giving away a notebook. Dell's giving away a notebook. NVIDIA's giving away video cards. If you're trying to upgrade any of your hardware, here's your chance to do it, for free if you win. But there's over $15,000 of prizes, so there's chances to win a bunch of stuff. Also, S22 was announced at the beginning of the show, not this day, but on Monday was announced. So check out those features at maxon.net. So that's there. And cineversity.com is where you can go for all of our different archives. Noseman has tons of tutorials on there. And speaking of the nose, I'm here with Athanasios Pozantes, the Noseman, because Noseman knows. We have a bunch of questions, so we're going to dive in before our next presentation. So you're starting off and you have something to show with the people, right? What do you got?
Yes, well, greetings to everyone. My name is Athanasios Pozantes, aka Noseman, NosemanGR on Twitter and on YouTube and all that stuff. So we have a few questions here. We're going to answer a few of them. Let's go one by one. Is there any way to control the path of the animation of handles? Before I do that, I want to share my screen and show you a new product Maxon has been working on for the last few years for the next release, which is the Flying Mammal Person Generator. And it's a new parametric spline creates a very specific logo.
I didn't know you could share this yet.
Well, a bit of a wild card, and I do that. Anyway, jokes aside, this is an interesting generator made in Python by a very good friend of mine, an excellent developer, which uses a math to draw a spline of that particular shape. If anyone wants it, follow me, ask for it on social media, make me look good. And I'm
they don't need to make you look good, brother. They don't need to make you look good. You're already looking good.
I know. That was my attempt at modesty. Okay, so let's go to the animation of tangents. So I have a very simple cube here that goes from here to here. If the question is how you made this, I think you need to go on Cineversity right now and watch some tutorials. So it's just a couple of keyframes, all right? Now, you can always go to these points here and select them and move them, okay? But if you want to go to the actual tangents, when you select one of the actual keys here, and for anyone that doesn't know, these black dots indicate the position of your object at each frame, so you can see the easing in and easing out. So if you select any of these, go to the Attributes Manager, there's a key preset down here. And click on that little arrow. Maxon hides the best things under small arrows to keep you entertained, and turn off auto tangents. And then you can use tangents to change the spline. That one won't work because it's an edge one, but this one will. And for each key, you have separate control. So you control the actual animation path this particular way, providing the constraints of everything else you have here are not clicked. So there you go, full control.
So just click on it and then change that box.
Go here, scroll this, go down, auto tangents, and remove overshooting and all that. These are convenience features, and this way you can actually that and use the tangents. So one down, a few to go. This is the next one that says how do I get clones in the object mode to take their color from the underlying surface? Now this is a bit of a loaded question because it doesn't say how we textured the particular surface in the first place. I'm going to show the straightforward solution, and that is using a shader effector. So let me get rid of the shader effector, and we have a sedan, which is a mesh from our content browser. I've just turned it into a mesh object. I've created a cloner. I've set the actual clones to be generated on the object itself, and I just want to remind everyone I'm on a over 10-year-old Mac Pro, still working fine, but this is slightly slow. So sedan, a Dosh design, and I'm cloning these cylinders on that. And what I want to do is propagate whatever is on the surface, and everything on the surface of this car, which you can see is animated, it's a noise. It's a very simple material I've created here, which is just in the color channel. Remember that, color channel. There's a colorizer. In the colorizer, I have a noise, and I've added some animation, and that's pretty much it. And it's applied using UVW mapping on the car, which, by the way, I created using the automatic UV unwrapper. It took me about 4 seconds to do, and I'm very tired. So let's continue. You will select your cloner, and you will go to the mograph menu and add a shader effector. And that shader effector, you need to change the parameter from scale. You can leave the scale if you want them to scale. Leave it to effector color, turn off the alpha strength. And in the shading, it's asking us to define some sort of shading. Now, besides the shaders we can find here, we can actually use a custom shader from which we choose one of the channels that have something in it. Remember, the material I have has a color channel. Drag it in here, and then you have that color propagating to the clones, as you can see. Okay, now in certain situations, just don't forget, you need to select your cloner, and you need to go to the transform, and there is a setting. It's not the transform, it's the object. Where is it? Oh no, sorry, my bad. Is it parameter? Oh, I'm lost. Cloner. It's not, because it's set in UVW. So that was my mistake. You don't have to really do anything. That's all you have to do. And by those means, you propagate the surface color to the actual colors of the cloners. And that will work in all sorts of different scenarios. Let me close this. I think I have one more file. There you go. This is the equivalent. And basically, I'm using exactly the same method to take that noise from a plane and apply it through the shader to these clones here. And of course, to finish this, you can change the scaling and make them do all sorts of funky things at the same time. And that's pretty much it. So question number 2 down. Next one, multiple selection sets, how to add texture to them. So the question is quite, as far as I understand it, is that you have a sphere. Don't look at this. I'm going to open a new file. You have a sphere. You make it editable. And basically, I think the question is that if you have a certain selection sets, selection, and then deselect this, do another selection set, and set selection, you would like an automatic way to create different materials and apply each material to each group. Unfortunately, I think I know why the user is asking this question, because when you export FBX with the groups, unless you have a material attached to the groups are not going to be exported for game assets and so forth. Now, Here's the bad news. The bad news is that there is no automatic way to do it. So if it's a few selection sets, you just select it, create a new material, drag it on here. Go to the other one, double click, make a new material, drag it on the other one. So it's a manual thing. It will take you at least 3 minutes to do a complex model, and I don't have 3 minutes to spare. But what I will offer the particular user is if they contact me on social media and ask this question, I may be able to do some very, very quick programming. For example, I'm going to copy paste the script I found online, this one, and I'm going to adapt it so that it sort of works with one click, and I can take all credit for that. Now, this particular one still needs some adjustments in order to work, but by the time I get contacted and I get an extra 1,000 viewers on YouTube or followers on Twitter, I can refactor this particular script to work in that particular fashion. And yeah, I'll take full credit for that. Thank you very much. So that's down. And this is just a result of the same thing. Then we go to what is the fastest way to make realistic water drops from a tap with dynamics or manual deformers. I would say if your livelihood relies on this kind of stuff, you should invest in a fluid simulation, either plug-in or something like that, because fastest on its own doesn't really cut it. It depends how realistic you want it, how much work you want to put in it, how much art direction. But I've created a setup here which is creates a sort of a cartoony splash. It is dynamic. I'm just going to sort of break down this whole concept here, and let me show you what I'm doing over here. So number one, in a drop null, I have a sphere and a spherical field. I'm going to use the spherical field later on to activate the dynamics of the little drops for the crown. I've put this as a child, and I'm going to use the closest thing I want to dynamics, which is to keyframe this, right? For a simple drop going down, just keyframe it. Don't bother with dynamics. And we have this initial motion, which is nothing more than just a keyframed sphere, and I changed the tangent so that it accelerates, right? Now, the next component of this is to create a cloner with a bunch of spheres in a circular configuration, right? There you go. And I've attached a dynamics tag to this, and I have the following settings. I've got it triggered at velocity peak. And anyone that watched my dynamics tutorial on Link Education or one of those outlets will know what dynamics do. Or if you've been on Cineversity and seen a number of tutorials, this will start the simulation when any effector moves the clones. And this is where the plane effector comes in. This plane effector, which is confined by the spherical field, this one here, will only be applied if it's on when this particular field touches the area of the clones. And I've set these clones to have an initial linear velocity, and I've randomized them a bit with a random effector so that they're not pointing in the same direction. So some of them are pointing, their y-axis is pointing in different directions, which means that when the initial triggering happens, they are going to start at an initial velocity of 350 centimeters per second and going to fly away. So this is what we get. Triggering through a plane effector, masking that trigger using a spherical field. The spherical field of a drop which is keyframed over here, and this is the result of that. Now, if I want to create little tails, droplet tails, I put my cloner in a tracer. So now I'm getting lines. So when they fly away, they have these lines. But as you can see, I've got everything here underneath a volume builder, which means that if I turn this on, I get a volume, and if I turn the mesher on, I get little droplets. Mind you, the tracer, I've set the amount from the limit to 5 frames so that this line gets truncated after 5 frames. And you can see that we get this little thing. I've added a little cylinder as my surface area, and what else? And then, for my own reasons, I added an instance of this whole null in subtract mode to create some sort of dent when this is sort of going through. Okay, this is a dent. I didn't have to do that, as I don't have to do these presentations, but I just do them to make things look cool. Smooth the form on top, rewind, press play, and we have a sort of cartoony drop. If you want something better, you can do other techniques like using more. And very quickly, if you want to make a crown, you'll make a disc, you will turn on your crocheting lines, you'll add some segments, you'll go into this, you'll make it editable, you will select a loop, you will extrude this loop, you will scale it out, and then extrude it again and scale it out again, put this under a subdivision surface object, and then start extruding individual polygons and sculpting this. And what you can do with this is you can create two states of this object and use some sort of pose morphing to morph from one to the other using fields and whatnot. So this is all I can show about this particular technique, but my suggestion is go and invest some money on a fluid simulator, whether it's X particles or jet fluids by Game Logic Design or Real Flow or I don't know, anything else that can make your work a bit better and provide you better quality of life. I would say worth its money. So
or just do what you said and just have it completely art directable. That works.
More 3 minutes on something. Again, if you want to charge your clients a certain amount of money so you can live comfortable lives, make sure you put some work into it. I don't.
So that's good advice. Yeah, do work when you actually get hired by clients. Do the work. Invest in the right things.
Yeah, it's a good idea.
So what we're going to do is we're going to take a quick break, and then we'll be back here to announce Chris Schmidt. So thanks again, Noseman. And yeah, if there are more questions in the C4D chat, just keep them rolling. I'll see if I'll be able to, if we generate enough of them, I'll try and bring them back on possibly tomorrow or another time. But just keep them going in the chat, and we'll keep aggregating them so we can actually tell him something interesting. Because if it's not interesting enough, he won't come back on. He's very particular. He's very particular. So awesome. We'll take a quick break, and we'll be right back.
Hey everybody, it's Paul Babb over at Maxon, giving Matthias a little break from the stream, from the chat, or giving him a chance to get in there and chat. Great people today. Love the activity on the chat. Thank you so much. Don't forget to enter the contest for the raffle, and keep sending those thoughts in. Hey, we've got a great presenter coming up. One of the kings of the community. He's been creating tutorials and plugins for years, broke off to start his own company last year, Rocket Lasso. We're really thrilled to have him again. He always brings incredible content, great tips and techniques, and just makes it look like a lot of fun. So without further ado, let me introduce Mr. Chris Schmidt.
Hi there, everybody. I'm Chris Schmidt from Rocket Lasso, and I want to start out with a big thank you to Matthias and to Maxon for putting this entire show on and inviting me to participate again on C4D Live. Our pseudo NAB should be really fun, and I'm looking forward to this presentation. I've been looking forward to this idea for a while. The idea actually originated as a question in one of my live streams. I do a live stream called Rocket Lasso Live every week on Twitch and on YouTube, where I just take questions live from the audience. We try and create things primarily in Cinema4D. And there was a ragdoll question that started there. Rocket Lasso as a company started about a year ago. Me and my brothers started it. We're hard at work on tools and plugins, primarily for Cinema4D, working on tutorials. And like I said, I do the live streams, and it's just a lot of fun. And I hope everybody comes and checks it out. I have a Patreon set up. If anybody sees anything that they like here, all of the scene files I'm creating are going to be available for anybody supporting at any level on Patreon. But without further ado, let's take a look at some of the things that we're going to be tackling. Obviously, we're going to be creating some ragdolls. And here you can see we're going to be implementing some nice realistic characters in here. And I think it's actually a pretty straightforward technique for getting them fully integrated. I'm actually kind of shocked at how simple that is. Some of the techniques just get really nuts, where I've been trying to push the technique a little bit further. You can kind of see here the raw dynamics, but you can take that, implement it, and start making the fancier versions of it. I don't know. It's just a really open technique, and I'm really excited to see where everybody goes with this. All right, here we are in Cinema4D R21. I've already got scene file prep just so we have a little bit of texture, a little bit of lighting. So we're not looking at a blank gray screen the entire time. Now, we're going to begin with a figure. It's great because, first of all, everybody has access to it. And second of all, the scale of this is going to match everything that comes in from Mixamo, probably because both are based off of the average height of a human. We get this figure. I want to see the polygons. I'm going to NB. We want to make this as low poly as possible. So I'm actually going to drag this all the way down. Let's drag that down. And okay, maybe that's a little too low poly. We want a little bit of detail. Enough to fill out the form. So I'm going to tick it up again. There we go. That's pretty good. So very low poly, but we're not really wasting any. And of course, the fewer objects, the fewer polygons, and the quicker everything's going to run, especially if we're going to be cloning a whole bunch of them. We will make this editable. It's going to explode out to a bunch of pieces. If I hold down Control or Command, as I hit plus, it'll actually expand everything out. And you can see all the different pieces involved in the character. And that's looking great. But there's a lot of pieces here. We don't need all of these. So we're going to use a function we don't use too often. I'm going to select the bottom one, hold down Shift, select the top one, and then we can right click. We're going to do a function that we don't use too often, and that is going to be ungroup objects. We click on that, and now everything's been pulled out of their group. It's going to make it easier to select all of the different elements. And now I can grab my rectangle selection and just drag and grab a whole rectangle. And now it's going to be grabbing the floor, so I'm going to temporarily hide that floor. And I'm going to select the entire hand like that. And you see we get two different pieces. And the way we're going to be building this, we don't need both of those to be separate objects. I'm just going to right click and say connect and delete. And we're going to do the same thing with every relevant pair of objects here. So grab those, right click, connect and delete. We'll do it with these. Right click, connect and delete. The upper leg, connect and delete. The knee and the shin, right click, connect and delete. And the foot, right click, connect and delete. And two more. We got the torso and the little waist. I'm going to make those as one object, connect and delete. And we got the head and the neck can also be treated as a single one, connect and delete. Now we're only going to work off of half of this model because hopefully we can save ourselves a little bit of time later, not needing that entire collection. In addition to that, we got a couple extra objects here that aren't doing anything. We got this effector. That's an empty object. Right foot effector, essentially anything named effector. That's not doing anything. It's empty geometry. Head effector, don't need that. And let's see, is that everything? Oh, figure, that's an empty one. It's an empty polygon object now, essentially a null. There we go. And now you can see we've actually knocked this down to very few objects. We don't have to worry about that many of them. So with that in mind, let's immediately make them dynamic. Select everything, right click, simulation, rigid body. I'm going to copy one of those rigid body tags over to the floor. And now it should be ready to hit play and everything falls apart. That's great. It's fun to play with dynamics in Cinema, but obviously this is just the very beginning. Now, I want to add as much clarity to this setup as we can. I want to get as much information as we can because it is a fairly technical setup. I think it's pretty straightforward. Hopefully this will be explained in a way that everybody can follow along, but we do have to be very specific, and anything we can do to add clarity to our testing and our building is a good thing. So I prepped just a generic checkerboard material here. So yeah, this is the checkerboard. And we're going to apply that to everything. In fact, I can just actually, why don't we create a null? I'll create a null and we'll name this ragdoll and make all of our geometry a child of that. And that way we don't have to apply a tag to every object. We can just apply it directly to the top and it'll filter down to all of them. So now we got that ragdoll. It's going to show us the rotation a little bit, but you know what, to tell you the truth, I would like to see it even more clear. So I'm going to select all of our geometry, grab our live selection tool, and I'm going to select all of the polygons that are front facing very quickly. Let's see, grab those. I guess we can grab that. Even on the hand, even on the leg. And this, believe me, this is going to be very useful to us later on. Spending this a little bit of extra time is totally worth it. And I missed one. We'll grab that. Excellent. So we've got all of those polygons. Now we can create a selection tag. So we'll say selection, set selection. And if I were to grab this just green luminous material, I'm going to drag that also onto the ragdoll. It's going to apply to everything, but we made all these tags and they all have the same name. So if I grab that material and drag the tag, it'll automatically override that. You can see that now we have a nice stripe down the front of it. So it's very easy to tell what the front of these are and if they're twisting in a way that we don't want them to. Excellent. All right. So all of these objects are dynamic. If we hit play, they're all going to fall apart and we can see them very clearly. This is actually a really good step to save the scene file. So let's do that. And let's go on and start getting some control over this. Now, if they're all just going to fall apart, it's going to be very difficult to see what's happening. So I actually want to take the pelvis, select its dynamics tag, and inside of there, I'm going to go to the dynamics tab, and I don't want it to be dynamic anymore. I'm going to say dynamic off. And that means it's still dynamic. It just isn't going to be affected by gravity. It's stuck in its same place and everything else is going to kind of bounce off of it. But that kind of gives us a foundation to connect everything to. And when it comes to things like character animation, it's like the movement originates in the hips. So that's why we're using that as our base. So with that in mind, we need to, why don't we order this up a little bit? We'll make it a little bit cleaner. So we're going to start with the pelvis, go up to the upper body. That will then go to the head. And then from there, we can take the upper arm, lower arm, left hand. We'll move those up. And then the leg and foot will be last, just a little bit more organized. So first thing we want to do is actually connect the upper body to the pelvis. We can do that in a pretty straightforward way using a simulate dynamics connector. If you've never played with connectors or only used them in the most basic way, they're actually incredibly powerful. And I've actually learned a lot about them in this last year, and especially in the time of putting this presentation together. And I highly recommend going deep on them. Now, we're going to begin by, actually what I'd like to do is adapt the position of the upper body. That's what we're going to be pivoting from. So I'm going to make it a child of that. And we can click the reset PSR button, which is up here in the interface now. You see that's going to reset and it's going to be perfectly lined up there. Nice. Now, I actually enjoy putting the connector in kind of the parent object. It's like the parent, this pelvis is going to drive the upper body. So I'm going to make it a child of that. You don't have to. It's just a way of me being organized. With that in mind, we want to grab the connector and I'm going to drag the pelvis in the top because that's the start. The top was kind of like I said, the parent, and the bottom is going to be what is getting connected. So those two should now, just by doing that, should be connected. And when I hit play, we should see that that tap part is now stuck to this other one, but it's passing right through and it's falling down with gravity. So not exactly what we want. In addition to that, this is a hinge connector. There's a lot of different types of connectors and they're really powerful. They each do their own unique thing. What we're aiming to do here is build the most robust but simplest kind of combination of settings and connections to make the best ragdoll that we can in this time. Our connector in this case is going to be a ragdoll, and we're going to be using a lot of those. So this ragdoll connection is going to enable it to move anywhere within this cone. I'm going to hit R for rotate and spin this up exactly 90 degrees. Holding down Shift is going to enable you to rotate it properly in that orientation. Now, here's something I did not know for a really long time and is incredibly important, is a lot of connector types, they should not be perfectly on the axis of the object. It doesn't know what to do if it's exactly on the axis. If you ever done like IK rigging and you've ever tried to build like an elbow or a knee and it suddenly is backwards, it's that same idea. It doesn't know which way is forward unless we give it an idea of which way is forward. What I'm actually going to do is take this connector and I'm going to scoot it down just a little bit. And the instant I scoot it down, in fact, I'm going to undo. When I scoot it down just a little bit, you're suddenly going to see the cylinder pop up. And that cylinder is kind of representing the direction of these two objects combined. And you see that that is existing inside of this cone. The cone is kind of like a thing you put on a dog when it had surgery. So it can only move within that cone. And the cylinder has to be upward to be able to move within this cone. And when this is perfectly lined up, it doesn't know if it's inside the cone or outside of it or what its orientation is. So now it's properly lined up. And I want to hammer this home. It's really important. It's messed me up a lot of times. That is now upward and we're trapped in this cone. So if I hit play, then now you see the torso falls over and it's being stuck inside of this cone. So that is excellent. We have a lot of control with that. And I want to push this as far as we can. I want to give the ragdoll a lot of freedom to bend in a lot of crazy ways. So inside of this connector, we're going to increase its radius all the way up to almost a full 90 degrees. It's as high as it can go. And now it can be anywhere essentially on that half of the plane. So we're going to want to be pretty organized here. So I'm going to rename this upper body, and that becomes our connector there. Now it's currently just falling down and we want it to have a little bit more control. In order to do that, we are going to use some springs. Now I did not respect springs enough in the beginning. I kind of ignored them. I didn't think I needed them, but they are awesome. I'm going to go ahead and actually, as a way of saving time and being a little bit more organized, I'm going to make a child of this upper body. That way I kind of know, okay, it is doing the same connection that upper body is. I can hit reset PSR and it's going to jump up there. That's actually not needed. But why don't we go ahead and drag in the same objects. So the pelvis and the upper body. And those are now connected. Now, currently, we are on a linear spring, but there's two different types of springs. There's also a angular spring. And the angular spring is, you can kind of see it's like if you twist something one way, it's going to want to spring back like a little watch kind of mechanism. So with that in mind, first I want to make sure that I do the reference axis, and you can see this is aiming up on Z. So I'm going to set that to Z. I'm not 100% on that, but it does seem to help. So just by applying that, we hit set rest length, we can see the rest length is going to be already at 0 because that isn't rotated at all. But if they were at different rotations, that would do something. And if I hit play, we should hopefully see that the torso is not spinning around backwards anymore. Our green line is trying to stay lined up. Now, we could push that further by doing things like increasing our stiffness. If I crank that up to 11, then... Well, that's a good demonstration of it. I tend not to like cranking up the stiffness because when you crank up the stiffness, it can get a little bit twitchy because it's trying really hard to get to a direction, but it's almost at a 90-degree rotation, so it doesn't know how it should orient itself. So there are limitations on how far you can push a spring alone, an angular spring especially. So that should be trying to get it to have the proper rotation, but it's not going to keep us vertical. So let's make a copy of it. Here's a second spring, and let's just call this just spring is actually fine. We'll just call it the spring. Actually, it'll be the spring position. So it's trying to keep this kind of straight. So I'm going to change that from angular back to linear, and you can see there's a connection from one section to the other. If I hit play, and really important, the rest length, we have to say set rest length. So currently there is a distance of about 29 units in between those two. If I hit play, it just falls down. It's not doing too much. But if we start increasing that stiffness, let's jump it up to 5, you can see now that it's attempting to keep these at a certain distance. Now, there's a lot of different ways of using these springs that I have found. And the way I would have done it in the past, and it is super valid, is to take the rest length and make it longer. So typically I would double it. So I'm going to say times 2, and it's going to double that. And now the spring essentially thinks it should be twice as long as we can visually see it, and that's what it's trying to get to. So even with the stiffness at 1, if I hit play, you can see it's trying really hard to keep it upright, and there's a nice springiness to it. So that is a super valid thing to do, is just increase your rest length. But there's a different technique that I've found is a little bit more controllable and art directable. And that is, we're going to change this from center of mass, which is currently just trying to find the middle of the dynamic body. We're going to change both of these to offset. So it is set looking for the offset, looking for the offset. Now, by default at 0, it just means it's gone to the axis point. It's snapping to the axis. But I'm going to grab the pelvis and I'm going to say, actually, I want you up here near the tip of the torso, right where that would be ending. And then I'm going to grab the offset of the body, and I'm going to also move that up to about that same point. I'm just going to eyeball it. You could be very precise if you want to, but if I hit set rest length, you're going to see that the rest length is incredibly small. So with everything at defaults, with the stiffness and damping, this spring, this torso, is being connected to a spring that is connected to the pelvis. And the pelvis is saying, like, hey, I've got a point up here in space, and that's where I'm trying to get you to. Wherever the pelvis rotates to, that's where its offset is going to live. So even if it rotated, it would be up there. And it's kind of putting this torso, the top of the torso, on a very short leash. So if I hit play, even at these default settings, you can see, and ignore that spinning, that is behaving correctly. But you can see that's actually staying very, very upright. It's very controlled. We have very precise control over, I want you to go there. And what's great about this is actually, instead of increasing the stiffness, which can introduce some sort of jitter, we can actually lower this. I can say like 0.2, and now you can see that it is free to wiggle around a little bit at an even lower number. So that's a very good start. And as we go, it's going to be changing the dynamics of the way it's set up. So I'm not going to worry too much about all the little specifics as we go step by step by step, but I just wanted to make it clear how that is connecting. Now that that's being sprung forward, you can more clearly see that this rotational, this angular spring, is keeping the correct rotation. It is facing pretty forward, but I know for a fact that later on, once we start dropping this and applying different forces, this angular spring is not going to be enough. So even if we're not going to see the effect very strongly right now, we are going to build in a slightly different system that should help us out here. And that is going to be creating a copy of our spring, our position spring here. So I'm going to rename that. And we're going to rename this one spring forward. And what this is going to do is the same idea. We're going to offset. Let's reset these actually. We're going to offset this. So let's say the pelvis is going up here, about the halfway point or a little bit up the torso. Keep in mind that this little middle section is also part of the upper part. And then let's see, okay, I got this. So I'm going to scoot this forward just by offsetting. I'm going to pull it pretty far forward, maybe like 2 or 3 times the width of the body that we're seeing. And then I'm going to grab the upper body and I'm going to scoot that one up a little bit and also offset it maybe about halfway the distance. This is just kind of my current workflow. This is not to say it's the best way of doing it, but I've gotten very reliable results from this. And I think the basic idea here would be that it's pivoting. You saw up here, we really locked it into position, but here we're giving it a little bit of room. There's a little bit of wiggle room on here. There's a little bit of length. So this could actually rotate and pivot a little bit and still have control. It will have control, but it can have a little more freedom to rotate. So just by doing that, we now have a spring that's saying, hey, there's a kind of a floating point in front of this body. And that floating point is always trying to stay connected to the spring at set rest length, this distance. So that is going to force this in a much stronger way to be forward. So it's going to almost make it impossible for it to twist around backwards. And that can happen very easily as other forces are applied. So we're going to be building that idea into every system as we move forward. So that was a lot of explanation just on one little section, but now it's going to go a little bit quicker as we begin to copy and paste this into other places. So let's do that again. And we're going to step by step do all of these because I think it's really important. I don't want to lose anybody. So I'm going to make a copy of this and it's for the upper body, but I'm going to copy it into the head as a way of getting its position. So I can say 0 on Y, and I'm not going to reset PSR because I don't want to lose my rotation. So I just 0 out on Y and you see, boom, it jumped up to the head. Now I can drag that onto the upper body. And here's something that is great. Connectors and springs share an identical parameter. These have the same parameter ID behind the scenes. So when you select all of them, you can see we have object A, object B, and they're all there. So I want to replace with what's doing the driving, and the driving is the upper body, and what is being driven, the head. So let's drag the head into the secondary object. And so all of those have jumped to that. Now let's go through them one at a time and make sure everything's correct. Now, remember what we were talking about before? We don't want to be lined up on the axis because it doesn't know what direction it should be. So if I just take this and scoot it down just a little bit, oops, I'm moving it in 3 dimensions. If I move it down just a little bit, it's going to shoot straight up, and now it knows what its orientation should be. So very important. Next up, let's just do the springs one at a time, and we just have to kind of tweak the variables. So this is our spring position, so it's kind of the upward one. So let's make sure we're up at the top of the head and up at the top of the head, and all we have to do is tweak those numbers, set the rest length. It's very close. Then we've got our forward one. Let's make sure that it is doing a very similar thing. Scoot this up to about the middle of the face, about the middle of the face, set the rest length. Excellent. So that should be facing forward. Boom. Did that. Now that is connected. It should be staying upright. It's all connected. Now you see, as soon as we added the head on here, it's so much heavier that the entire thing is flopped over. And that's what I meant when I said we're not going to worry too much about the specifics until we start connecting more of the body parts. But we can see that this is now connected. We can see that it's continuing to face forward, and the rotation seems to be correct. Excellent. So let's do it again. Copy this. Oh, and we're trying to stay organized. So I want to rename this one to head because it's connecting from the upper body to the head. And it's important to keep these organized and named properly because now this upper body is going to get this entire rig a second time. So I made a copy. I'm going to continue from the bottom. So I'll just delete that and rename this one. And we'll name this one left arm. So that is going to connect to our left arm. Now, actually, I'm going to move it down here into the left arm and zero out any positional information. So let's snap it essentially to its axis point. I'm going to hit R for rotate. We know that right now it's kind of the cone is facing upward. If we want to visualize, of course, I can grab that and shrink this a little bit. And what we want to do is grab this and spin the entire thing 90 degrees, holding on the shift. It's at -90. And excellent. Now we know it has a proper position. So I can drag this back into the upper body. Hit E for move, so I can scoot it back just that little bit. And as we scoot it back, hopefully we can see, well, actually, this is not, let me make sure I put this in the correct position. Looks like I put it in the head there. I think we want to be in the upper arm, and that is zeroed out. So I guess maybe I just have to scoot this back a little bit extra. So we want to make sure that that angle is the correct orientation. So I'm going to scoot this back. But actually, this is interesting. The axis, the axis of the upper arm. Oh no, it is there. Interesting. So, well, let's just figure out exactly what's going on here. Now, if I were to, as I scoot this around, it should be relative to that position and the way these are getting connected. So it's the center of mass and the X. Okay, apologies. I was just making a little mistake there. I forgot to relink all of this to the new connection. So that's why it's trying to line up with the head. I was like, what's going on? So, okay, ignore that. Everything we just did is valid. We just have to select the left arm and all of its children. And let's make sure that we are connecting the upper body, which we are, to the left upper arm. There we go. That's what we were missing. So let's go through them one at a time. Let's grab the left upper arm, just scoot this back a hair. And as soon as we do, let's zoom out. You can see that the cylinder is shooting out forward, so it has the correct orientation. You want to make sure you don't move it back too far, because the further back you move it, the more it's going to not accurately rotate that point. Once it's in ragdoll, you're not going to notice too much, but yeah, very important. Okay, now the position spring. Now this is completely different orientation, so I'm actually going to zero it out. You can just right-click on any number here, and it's going to reset it to default if you right-click on the little up arrow, down arrow thing. Let's grab the upper body, and its offset is going to move up and then probably here along Z. And I don't have to get this perfect, but I want to scoot this back to kind of where that pivot point is. So we'll also scoot that back in space a little bit. And now we can grab the upper arm and scoot that along here. So that lines up pretty well right there. And it probably should offset a little bit on Z as well. Those look pretty close. Hit set rest length. Again, a very nice small number. Excellent. So we've built the testing rig, so we can just keep on. Oh, let's do all of them actually. Let's grab the forward and the exact same idea. Let's zero out, 0, 0, 0, 0, and reposition these. Now, like I said, we're going to be very meticulous here. We're being very careful, even though we're going to repeat these ideas. it's the same idea kind of over and over again. I'm going to spend the time and do this properly here because I don't want to lose anybody. It's very specific. And once you have the ragdoll, you can reuse it again and again and again everywhere. So you can see that I took the thing that's doing the driving and I pulled it more forward. And then I'm going to grab the thing that's being driven and scoot it to about the same position and go meet it, but not quite all the way. It's just the current technique that I find is working very nicely. Set the rest length, and we grab the spring. The spring is actually doing the correct rotation. I don't know that we need it, and in fact, the spring is probably pretty redundant. We might turn those off later and see that they're not doing that much because we've built in this forward spring, but it's working well so far. Let's go ahead and copy this entire rig again into our lower arm. Now, it's for the upper arm, but I'm going to put in the lower arm so we can once again adapt its X, and we're going to zero out its position. So it zeroes out and snaps over there. And now we can move it into the upper arm. Now, immediately, let's grab all of its connections and connect the upper arm and drive the lower arm. And it looks crazy when they're all selected, but let's just go through one at a time. But when you're bending your elbow and when you're bending your knee, they cannot pivot in all directions like your head or your shoulder might. So we're actually going to change this connector type to a different type. We're going to change this to a hinge type. Now, our axis is getting a little bit crazy. It doesn't really matter, but just to be a little bit cleaner, I'm going to see what we can zero out. In fact, I'm going to zero them all out. And let's see what the orientation is. Okay, so it's rotated like that. We can just spin it up exactly 90 degrees. So negative 91. It's a little bit cleaner for rotation. So the elbow can only bend in that rotation, and that is very powerful. And when it comes to that kind of rotation, when it comes to the this one, I don't know if it's as important to offset, but let's take a look, and we might be able to see that more clearly. Because on this one, we are going to limit the angle. We absolutely do not want the elbow bending backwards. If the head twists a little bit more than it should, like I don't think it's going to stand out that much. But if an arm bends backwards, we'll see. So in this case, we will set an angular limit. And by default, I didn't used to know this. It used to drive me nuts. But I used to think that the solid part was where it was allowed to go. But it turns out that's like a blocker. That's blocking where it can go. You can see right now that it's, the thing being driven is showing this axis right here. So that can rotate in this big range. So by default, with this current rotation, we did get what we wanted. But something I would like to do is limit the rotation even a little bit more. I want to make it so this arm can never get all the way perfectly straight. You can see right now already that's a little bit bent. So I'm actually going to grab this upper number and I'm going to start shrinking it. You see up here, it's bending a little bit. And now it's not going a full 180 degrees, which means it could never quite straighten out. And the reason we're doing that is later when we're applying different forces, if it's stretched all the way perfectly straight, it doesn't want to bend over as much. It's kind of like, oh no, I'm a straight connection. You imagine like two cans stacked on top of each other. If they're perfectly lined up, they don't want to bend off of each other. But if they're forced to bend a little bit first, then it's going to allow for more of a rotation, more easily allow for a rotation. So that's excellent. We have a spring position for where we want it to end up. So let's, just to be clean, we'll zero everything out. Where do we want this to be attempting to get to? So we will offset the upper arm first. So I'm going to scoot this way over here towards the end and a little bit here on X. So we have, that's Z. So we have X, Y, Z. And then we can grab the lower arm and it should also be equivalently offset. And like I said, don't sweat these being identical. Just kind of close is more than enough. Set rest length. And there you go. It's very close again. And then we have our spring, which is going to try and keep it rotated to a particular angle. But you know what? In this case, I think that's significantly more redundant. So I'm going to just turn that one off. We'll keep it, but we'll turn it off. And then we've also got our spring forward saying, what is the forward direction of this? But I don't think we need that in this case either. I'm going to just turn it off, but maybe we do. So I'll leave it there. But I don't think we need it because the type of connector that we fed into this, which we should rename, this is, that's the left arm. And now this one should be the left lower. I'm just keeping the naming of what came out from the original figure. Based on that rotation, it cannot physically rotate in other orientations. So we don't have to worry about it being forward. So we get that one kind of for free. All right, so let's pick up the pace. We need to copy this also to the left hand. So I'm going to copy the hand. Now, you see, I actually did not copy the left arm one. I copied one of the ones from the upper arm because I wanted to go back to these settings more. I didn't want the hinge connector. I wanted the ragdoll connector. So once again, zero out the position. and move it up to the parent, the thing doing the driving, select it. It is driving the lower arm to the left hand, and that should do all those connections. I did do that with this, right? Yeah, upper arm, lower arm. And actually, it's on both now, but we should always make sure to check, kind of do a little check to make sure it's working each step of the way. So we can see now that that falls, and you can see that it is not twisting sideways, and you can see we do get a little bit of a bend in it, so that's excellent. All right, now we're back on this one. Let's rename it to left hand and check our spring position. So zero them all out, 0, 0, 0, 0, 0, and get our offsets proper. So we'll scoot that one to the tip of the hand and scoot this one to match it. That one was nice and easy. Set the rest length, very, very, very close. The forward one, this one is actually kind of important. We don't want the hand to be twisting around at all these crazy orientations. So 0 everything out, get it to the middle of the hand, scoot it. Nope, not that one. Let's scoot it forward on X. No, I'm sorry, Z. I keep doing those backwards. Give it a few more, and also offset the actual hands position. So we'll scoot that in and pull that one. Like I said, I've been kind of doing half the width of it and then matching it, because when they're smaller, they weigh less. So excellent. So that should be controlling that. And we also have the spring, which is perhaps redundant, but it's also adding some of that rotational energy in. So we hit play, and now we should hopefully see that the hand, actually, you see the hand got a little bit crazy there. It flapped around towards the back. Actually, nope, we forgot a step. We gotta be careful. We forgot to move this backward. Look, the cylinder is moving, it's aimed down. We have to take this and scoot the whole thing just back that little bit of hair, that tiny little bit. And now when I hit play, now the hand doesn't seem to be, it's not twisting around as backwards, but you know what? It's still flopping around more than I want it to. So just to show you, we can exaggerate these. If I push this further, and I push this one to go match it, and we set the rest length, and we'll grab the forward one and make sure that it is out even more. Let's go even a little more than that, and then a little bit more than that. Set the rest length on that. This is forcing its hand more to be in those orientations. It's kind of like an up vector, and there we go. Now you can see the hand is trying to be very far forward. It does get whipped around a little bit here when it seems to collide with something, but we might... Well, we'll deal with that as we get to it, but that seems okay. All right, excellent. So those are all set up. Let's work our way through the leg very quickly. Once again, this is pure iteration, but we're already doing all these forward ones, so we'll see how this goes. So all this is fine. I'm going to copy this directly to, actually, we're going back to, I'm going to hit escape because we're going back to the pelvis. So I'm going to grab let's collapse all the ones we don't need because those are done. Let's grab this pelvis one and duplicate it into the left thigh. 0, I'm just going to reset PSR. It's going to spin it in this crazy orientation. Let's shrink the cone so we can see it a little bit more clearly. You see it's aiming backwards. And hit R for rotate. Spin it straight down. Now, we could be a lot more picky about the orientations here and make it so it's only limited to particular angles. I'm keeping it very free form. We're just kind of saying like, hey, try and stay forward. Like here, it's going to aim down. It can't twist to a crazy angle, but it can bend in ways that legs probably couldn't. So you could definitely go through here and tweak these. So it's like, okay, the leg can't go beyond that point, but I'm giving it as much movement as possible. That goes in there. It's zeroed out. Let's select all of it. This is going to connect from the pelvis to the left thigh. As I said, I like these to live with the parent, so I'm moving it back up to the pelvis. And as always, let's move it up a little bit from here because that's the orientation. The cylinder shoots downward. That's working properly. And let's very quickly reset our spring positions. This one's going to be a little bit different because it's off. These are offset from each other. So we'll scoot this one down to about the knee. That seems lined up pretty well. And offset downward to go match it. Set rest length. And this one's the forward one. Reset, 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 reset. Scoot down about halfway. Scoot it over. And pull it negative on, I think, World Z. A little bit more forward. This one, the leg definitely ends up with a lot of kind of twist on it, so I give this one a little bit more distance. And we'll pull this one out about halfway as well. Maybe pull it down. There we go. Nice straight line from it. Set rest length. I'm being a little more precise than I have to be, but, it couldn't hurt. And this is going to, this is also going to influence the leg to try and stay more straight here. Excellent. So that's that one. Rename this one to, I guess we'll just grab the name. So this will be the left thigh. Rename it. And then let's do it smart. Let's copy this into the left shin and zero it out. 0, 0, 0 on position, not reset PSR. And of course, this one is a hinge because it's a knee. We don't want it rotating all crazy. Actually, I guess I could zero out R for rotate, spin it 90 degrees so the knee will bend properly. Link this to all the proper things, which is going to connect the parent, the driver, to the driven child. Left shin, for the left thigh to the left shin. Move it up again, make it a child of the parent. And let's once again limit. This one, the way it was rotated is not quite what I wanted. Now, we could fix this rotation. We also just hit R and then spin this 90 degrees like that. So, that either work. I like this nice clean 0 to 180. And in the same way we were before, our leg is free to spin back in this area. This is the blocker. So I want to limit how far this can rotate. In this case, it's going to be increasing the 0. And you can see right here, that is going to make it so it can't quite straight. It's never going to be able to go fully straight. But you can see already the leg's a little bit bent. Excellent. And then we've got our spring position. This is going to try and pull this leg down towards the ground. So we do want that one. We'll scoot this one down. And that's already matching pretty well. Let's get rid of that offset. There we go. Very close. Hit reset. There we go. And then we've got our forward. Once again, we don't need a forward and we don't need the spring for this particular instance. I don't think we do. And we got one last one to do here. Once again, I'm going to go select it from the top because I want these settings. We'll put that on the foot, a copy. I'm holding that control as I make a copy. And now we can zero out the position. Hit enter and then move it up to the shin, its parent, select it and all of the connections. Connect the shin to the left foot. Rename this left foot and scoot it up that little hair. Bink, very important. Cylinder aim down. And this one, the foot is the most important one to get the spring position correct. Now I'm actually going to hide the floor so we can see down below it just a little bit because we want to take the spring position, which I'm actually going to say, I'm going to rename it spring down. And this is what's going to keep the foot going down. So I'm going to pull this one down pretty far. And actually, I'm going to pull it back in space a little bit. So it's kind of lined up with the axis. And then this one, of course, should be about the halfway point. So you see that I went pretty far for the distance of the foot to say, like, no, aim down. Excellent. And now we've got the spring forward, which is also very important. Let's zoom these. And this is what, or reset these. It's very important because it is what's going to keep the foot facing forward. So incredibly important. If the feet twist the wrong direction, man, it looks wrong. So let's scoot these back. And this one's going to pull pretty far forward. And I'm going to make this one pivot from here. So it really wants to get pulled that direction. Set rest length. And there we go. We have now done all of the basic connections. We should have probably been checking the feet as we went, but let's turn our floor back on, the visibility, and hit play. And let's see. Okay, that seems to fall over. The leg seems pretty stable. So let's turn the pelvis off, or turn the pelvis, I suppose, back on. It's going to become dynamic again, so we can drop this and see if it's working. So let's turn on, and everything is now dynamic. Deselect everything, hit play. Boom, it all crumples down. It looks pretty good, except I guess, well, this upper leg seems to be twisting around quite a bit. But I also noticed that we were working from our springs were set down to 0.2. I'm going to put those back to 1, which is way stronger. So now we should see that that is trying really hard to stay forward. Now we're really it's crumpling in a very rough way right now. But let's keep going. You see the connections are there. It's trying to stay as far forward as possible, and then it does fall forward. So all of that seems to be working very well. So we need to mirror this. This is also a good place to give ourselves a save. There's something that I had not mentioned yet, and that should have been file B, but let's go ahead and make this C. Something I hadn't mentioned, which is it is incredibly important to make sure that this is all happening at the time of 0. Do not make changes to dynamics in general, but especially not to dynamics and connectors and springs, not at the time of 0, because it will lock your model into some new rotation and there is no way to fix it except for completely manually. It's a nightmare. Okay, so we've got to make a copy of this entire thing mirrored over. Now, the mirror tool was not designed for this type of mirroring, so we'll have to do a couple tweaks afterward, but it does work pretty well. We've got a ragdoll. I'm going to go to our character tool, click on the mirror tool, and the only thing I'm going to change is go to the naming. I'm going to say I want to replace the word left with the word right. That's the only change I'm going to make. And now let's make sure we're viewing this from the front or front-ish, like this, because by default, it's actually snapping to whichever view it's closest to. So we can click mirror here, and it's actually going to, boom, create a mirror of this. Now, this top one is the original. So I think that is the original. So I'm going to hide that. And now this one is the mirror. And you're going to see that all those objects that were in the middle, every piece of geometry that was at the halfway point has gotten deleted. Now that's okay because we actually copied the entire object, and those middle points, we don't need those. So we're going to completely ignore them and pretty much just extract all of the rest of this and move it into our main body. So everything here in the pelvis, let's delete the things we don't need. We don't need this upper body connector because that's going to be going away. We don't need the head at all. This upper body, we don't need the head connector. So, and then we're not going to need these bodies in the moment, but let's move. Now we've got the right thigh connector. Let's move that up into the pelvis. Let's make sure we grab it and its children and make sure that we link to this new, to the original pelvis, because otherwise when we delete the second one, that will be delinked. Make sure you get that one correct. And then we have the upper body, which is connecting to the arm. So I'm going to select that and move it up into our other upper body. And just to show you, we'll do the opposite. This I'm going to delete the pelvis, delete the upper body, which we don't need. And now when I go back up here into the right arm, you can see all of these have lost their object A. So we link to the proper upper body, and those have linked to that. So I believe actually that is pretty much all that we need to do. Let's go ahead. Well, it's all we need to do to move those things. I'm going to collapse everything in the hierarchy by holding down Control as I click. And let's move our new copied pieces into the appropriate spot. So I'm going to move them above the equivalent left one as a group. So there we go. So I'll keep the right leg together, the left leg together. So that's fine. So our ragdoll mirror did its job. We'll delete that and unhide this. So now we've got a mirror. But we should go through all of the direct connectors that move, actually almost everything. We have to go through almost everything and make sure that everything that we just made is connected properly, because certain things might not translate over to the other side very well. Specifically, the springs. You see, as soon as I click on the right leg, so this is connecting from the body to the right leg, what's happening is there's one value that can't get mirrored, and that is our X. The X value doesn't get mirrored. So it's actually pretty quick to fix. I'm just going to hit negative on that, and it should spin it there, and boom, you see it's lined up properly now. If I hit set rest length, it didn't even change because now it did match. So it's mostly this X value needs to get flipped to the opposite side. Now, I actually haven't tested it, but there's a chance that if we grab all of those pieces that we just were moving over, there's a chance we can grab all of them and just do the mathematical equation. To tell you the truth, it's so specific that I don't want to risk it. So anywhere we have a X value on the right arm, I want to invert those. So I'm going to say negative, negative, and boom, you see it jump to the proper spot. And then we have the spring forward on the right arm. So let's go negative on X, boom, that snapped correctly. And then I think it might be able to filter down the rest of it. Now this one, we turn them off, but let's click on this. And yes, you see it is on the opposite side. So let's go negative, negative. So these are all the things that got mirrored, and we're fixing those. The spring forward, we didn't even use that, so we'll leave that off for now. Position spring, that one's wrong. Negative, negative. There we go, on the tip of the hand now. And forward, negative and negative. There we go. We got the forward one. And I believe that was it. That was less painful than I thought it would be for mirroring everything over. So if this is working properly, which you never know if it is or not, we should hopefully be able to hit play. I'm going to save this first, and this will be letter 1D. And this will be the mirrored step, and deselect everything. I'm going to even collapse the hierarchy down, re-expand it, So I held down control as I collapsed it, and then don't hold it down. So now everything's collapsed and I can just see those levels. Let's hit play and see if it seems to be working. Yeah, actually that seemed to work pretty well. It's a pretty good, just like fall down kind of ragdoll. So excellent. That's an excellent start. In theory, we've got a ragdoll and we just start messing around with it, but let's start getting some controls. Let's get a little bit of something going on in here. So we don't want it just falling onto the ground. So the first thing we need to do is actually, let's turn off gravity. That's going to be the very first thing. In fact, let's do some universal settings here. I'm going to hit Controller Command D if you're on a Mac, and go to Dynamics. And I'm actually going to take our time scale, and I'm going to set it up to 150. I've always kind of felt like the dynamics in cinema feel a little sluggish, so we're going to speed it up so it's a little bit quicker. And then under the Expert tab, essentially we're making the time go faster. And if the time is going faster, then that means essentially more movement is happening in a shorter time. So we should give it some more steps per frame just to make it equivalent. So jumping this up to 7 or 8 in my mind makes it so that it's like the same amount of time for calculation for movement as we had before. So it's just a little bit faster. And I'm going to go back to general and take our gravity and set it to 0. So now there's no gravity. And if we hit play, this should just start gently floating up into the air. Excellent. Now, the reason we're doing that is because now we can make a simulate force wind. We could use gravity, but I like wind. I'm going to hit R and we're going to point this straight down. And the reason we're doing that is just so that we have a wind that we can easily turn on and off. So I'm going to rename this one gravity. And I did a lot of testing, and the number for gravity to match what Cinema has is 40. And I found out by having one wind counteracting it until it just until it perfectly floated, and it was exactly 40. Now that should be applying to everything. Now we turn gravity off, but we should be able to play. Everything runs a little bit quicker, and this still falls down the way we would expect. Boom. Excellent. Now let's make it so this continues standing. We want it to stand. Let's have this thing stand. It's just falling down with gravity. I don't want to see the gravity, so let's turn that off. And we could use another wind to do this, but let's start introducing some field forces. So under simulate forces, let's create a field force. This field force, I'm going to say, I need to give it a direction. So I'm going to say the direction. We can do that via solid. And yeah, just click solid. And now you can see it's 1, X, Y, Z, positive Y. That means it's pointing upward. So everything's pushing upward. Now I just know for a fact that the good value here is going to be about 155. Actually, it's more like 200. So I'm going to do 222 because it's quick to type. And now I hit play, you see, zoom, it shoots up in the air. So, okay, that's really powerful. And that's because it's applying to everything. So what I'm actually going to do is something a little bit unusual. We're going to select all of our dynamic objects. And under forces, I'm going to say, don't exclude things. Instead, I want you to include things. I'm going to say everything should include our wind gravity. So everything's being affected by gravity, but only the upper body, I guess like just that dynamic tag, is going to be affected by this field force. So let's rename this one upper body. And now we have a field force that's affecting just the upper body. So when I rewind and hit play now, you see it's going to go up in the air, but the arms and legs are falling down this time. Excellent. So now it's still flying up in the air, so it's too strong. So what we need to do is limit it somehow. So I'm going to, on this solid, create a mask. And I did that backwards. So, actually, I misclicked and made the folder. So let's create a mask. And in that mask, I'm going to create a linear field. The linear field will become a child of the mask. Make sure you turn this on so it's actually affecting the mask. Set that to normal. And currently it's on X plus, but in this case we want a Y minus. And now if I play, it should fall to the ground, except you see it's kind of up in the air just a little bit at the bottom. So if I were to grab this linear field and move it up, as I move it up, this torso is getting pulled in the air so much that it's wherever we pull this, the torso wants to go. And if we pull it up enough, we should be able to find some sort of equilibrium where the torso is floating, but the rest of it is standing. So, okay, that's working well. We don't have that much time. So let's go and just turn off our display here. We don't need to see that. In fact, we'll just make that invisible. And now we can see, now we can get a little more information from the body. Like clearly a bunch of things are happening. Like this torso is not trying to stay upright enough. The arms fall down pretty well. Like I like that they're kind of jiggly and loose, but I feel like the forward facing direction needs to be stronger on them. So let's go and the head definitely needs to be stronger. So now we can actually start playing a little bit with our simulation. So Let's go ahead to the pelvis, and we've got our upper body connector, and you can see now how powerful it is and important it is to have been naming these things. So I'm actually going to grab both of those, and let's just crank it up to 1, back to the original stiffness of 1. And now we can see that the torso is staying a lot straighter. Let's do the same thing on the upper body. Grab the head connector, let's grab both of those, and set their stiffness to 1. And now, boom, the head suddenly snaps up quite a bit, and I was trying to stay upright. You can see the entire body is staying upright. The arms are twisting a lot in the beginning. So let's twirl down. Actually, it's in the torso. So we got the arm. I'm going to grab all 4 of the positional based ones. We got position forward in the arms. And let's also set those to 1. And boom, you can see that these arms are trying to face forward. Oh, okay. I'm immediately seeing something that we forgot to do. Remember when we were fixing the mirroring problems? Well, there's one we forgot to fix. And that is on the arm, there is a connector. And this connector is, this didn't get mirrored properly. So the arm is being told that it can bend backwards versus what we want. So in order to fix that, I think all we have to do is spin this around 180 degrees. Nope, maybe it's here. Let's do positive 90. There we go. So that spins around in the positive orientation. And now the arm is back to bending, hopefully the correct way. And the same thing probably happened on our right, our left thigh. No, the right. Oh, I guess this would probably be, yeah, it would be the right thigh. So in the right thigh, we have the right thigh connector. There we go. And yeah, now we can see that this knee can only bend backwards, and that's going to trip us up a lot. So let's fix that. I'm not sure what rotation it is. So let's just, actually, I'll hit R for escape, hit R for rotate, and let's spin that. Oops, be very careful and grab the correct axis. And now there, it's that one. So if I set that to positive 90, then that should be flipped around. And now those should at least be the correct orientation. So let's just, without changing anything else, just all we do is flip those around to match our orientations, hit play. And there we go. Now you see the left and the right are behaving the same. So they should be able to bend correctly, and that the forward motion is being forced a lot more strongly there. And let's see, what else do we want to do? I think I might want to turn off that spring, the right arm spring, and that spring, the rotational one, the angular one, just so it can twist around a little bit. And you can see very much that they're trying to stay straight. So I think that this forward, or this positional one that's keeping them very far straight, I'm going to weaken that one. So let's set that to maybe 0.5. And we can even, that one, maybe go back to 0.2. It's being forced to go very forward, but now it's allowed to rotate and flop downward. Excellent. So you can see now how we're like kind of rigging this up. We're now able to art direct the way that this is moving. Now, having said all that, something we should have maybe done a little bit earlier is in the ragdoll, something I've been enjoying doing is changing some of the settings we feed directly into it. And along those lines, something I've been doing is changing the world density, and I've been doing a custom density of 0.2. So what this is doing is it's 1/5 of the density, and I have found that the springs, the density is very responsive to springs. So springs become more powerful if the density is lower. And as long as this whole body is relative to each other, I think it's completely fine. In addition to that, something, just a good default I've been finding is you can end up with a lot of jiggle in the character. So I've been doing an angular inside the dynamics on all of them under force. I've been setting an angular damping of 90%. And a drag of just 1%. And that's going to drain a lot of energy out of the way that they're wiggling, and it's going to calm itself down quite a bit. Now, because, well, okay, so that's all good. The next thing I would like to do is make this maybe calculate just a little bit quicker. And to show you that, let's go ahead and pause it, rewind, hit save. And let's go to the global settings again, Control D or Command D. And under Dynamics, I'm going to click on the Visualization tab. If you've never clicked on this, it shows you what the dynamics are currently doing. Now, it only does it if we're in a different frame, but you can see as soon as I hit play, this is all the calculations that it's having to do. It's like the directions and the speeds, but you can see that it's got this very complicated mesh that's trying to do on all these limbs. So what I'm going to do to make this calculate quicker, and actually we can simplify by, we can hide all that extra information. So now we just sort of see the limbs. What I'm going to do is rewind, and with all of our different dynamics selected, I'm going to change the shape from automatic, which is creating that mesh. I'm going to change these because it's a very simple character. I'm going to change this to be ellipsoid. That is changing these to be calculating like they're a sphere, and it can be a stretched sphere, but because of such simple geometry, this should make very clean, very precise calculations. But there is one exception. When I hit play, we're going to see that the feet are going to get really wobbly because they're being treated like they're spheres, which means it can rotate and pivot around in a really weird way. So we are going to grab the 2 feet, and I'm going to set those And let's make changes at time of 0. Let's change those to be boxes. And boxes are going to be very stable. And look at that. Just by changing that, look how stable the feet suddenly became. Now, because we just changed the form that these were all seeing, we changed kind of the density calculations a little bit. So you can see that this is the point where this is floating is a little bit different. So let's turn off this visualization. We don't need that anymore. And go back up to our gravity, our upper body torso thing. And actually, this is a little big. I'm going to pinch this in a little bit. And I want to move this up and down. And what this is doing is finding its natural equilibrium. So if I scoot this down right to the perfect spot, we should be able to, make him not stand upright, but his feet will be flat on the ground. So that's pretty good right there. Excellent. So that is working awesome. Now we are probably way over time. So we need to just do the last little fun things here and then maybe jump into the Mixamo bit. We can create a cloner, and everything we've done here is completely compatible with the cloner. So by dropping this into the cloner, I can drag this up in the air, put a little more space in between them. And I think we can go to maybe about 10 or 12 with my computer. It's a pretty good computer. But by doing that, I should be able to just hit play. And we've got all these independent ragdolls, each calculating uniquely to just themselves. Let's give ourselves a couple extra frames here to play with. And now we see all those falling down and they're all going to do their thing. It'd probably be a good idea to grab the cloner here and randomize the color. So I can hit randomize. I don't want the position, but I do want to turn on a custom color of white, use the alpha strength. I'm going to go under effector and zero this out and grab the cloner and make the initial value black. And that should give us a very clean, random black to white colorize. Actually, I didn't do that correctly because we don't want it to do it that way. We probably do want the colors. So inside of the random, we don't want that negative, but I'm going to turn off alpha and we'll just use the effector color. And that should randomize the colors. Now we're not going to see that while these materials on there. If I pull them off, we can see that, yes, they do each have a unique color. So now inside of something like the front material, we can go into the luminance channel and feed it the mograph color shader. And that should automatically work there. We can go into our checker pattern. And if we want to have this applied to a material as well that we've already got, I can feed this into something like a fusion. And in the fusion, I'm going to feed that also a mograph color shader, have it multiply on top of it. And that should darken all of those colors up. And if we reapply these materials onto our characters or onto the cloner, you can see that this has now been colorized and even their front stripe has adapted that color. And then we can see each individual character getting the different colors applied. And now we're at the point where you can just have fun with it. We can do a lot of different forces. We don't have a lot of, we don't have enough time to make it super crazy, but what we can do is we gotta do this one. I'm gonna create a simulate forces. Oh, nope, it's not force. It's under dynamics, but it is called force. So we're gonna create a force, and I want to once again apply this to all the dynamics. Now we have to actually select all of them, and then not the upper body because the upper body has a different thing in its list. So I'm gonna drag in the force to everything, and then also now just grab the upper body, and you see it's a different list. So we had to select it separately. Drag in the force there as well. Now I'm gonna turn it off. And actually, why don't we, instead of dropping these, let's make a radial array. We'll make 10 of them and spread them out. So we've got all of them. They're all happy. Hit play. We're still running in about real time. Like I said, we can get back to 10 or 12 of them, and they're hanging out. But now we can start messing with them. Now I'm going to crank this force up to 111 just because I know it's a good value. But now we can do things. Let's rearrange this a little bit. We can do things like, let's let them settle in a little bit. We can do things like turn off their upper body, so that suddenly all falls down. We can turn it back on again, and then they'll stand back up again. We need more time. Boom, raise that up. We can now turn off, I'm going to turn off the upper body and then turn off gravity, and now they're all going to float in the air. And then we can suddenly turn on gravity and they'll all fall to the ground, and then turn it off again and they'll begin floating again. But then one of the ones that's most fun is force. If I turn on force, then they're going to get attracted to each other. Blump, 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 blump. So force is kind of like a particle attractor or like particle on particle attractor. So these guys are definitely not doing their social distancing, but it's just a really fun parameter. I'm actually going to, we got to be careful about not breaking anything. But if we hit play right now, they're all going to get pulled into the center. It looks a little more visually interesting if we let them float for a little bit randomly And then you let them get pulled in. You get more of a ball. And then we can turn the gravity on and they can fall into the ground. And then we can turn off the force and they'll all collapse into a pile, turn the force back on, they back into a ball, float away. Turn on the torso floating, turn this off, and they'll all pop out and they'll all be trying to stand themselves back up again. So you can see we've made an incredibly robust rig here that we have just a lot of control over. Now there's probably tweaks we can do, little changes. And when it comes to me playing with this, making as many of these clones as you can and still run in real time is great because you'll see the mistakes quicker. Like if one of them's foot twists, you're like, oh, the foot might not be reacting quite right. And you make the changes quicker if you have this type of setup. So, that is excellent. Now, we're going to have to probably fast forward through this next part, but I do want to cover it as much as possible. So we will save this scene file here. And once again, if you follow on Patreon, all these scene files will be made available. So these are, I'll just call it ragdoll because these are now ragdolls. Let's turn off the cloner. And what I want to do is show you how to integrate a Mixamo character, or kind of really any character, but a Mixamo character is going to make it really simple to do. So if you're unfamiliar with Mixamo, if you have an Adobe subscription, then you can, if you have Mixamo, if you have Adobe, you can log into mixamo.com and you can get you see this big list of characters, and these are all textured, modeled, rigged, ready to go. And they don't have that many models and we don't have too much time. So what I'm going to do is click on the characters, and I'm going to go down to the SWAT guy. I just really like it. I'm going to say use this character. And if you're not familiar with Mixamo, you should totally play around with it because it's really neat. But you can click on animations and click on any one of these, and you're going to have your character start doing that motion. And it's just a lot of fun. If you're not familiar with it, I highly recommend this tutorial series from School of Motion. Specifically, EJ put this together, and it's all about bringing Mixamo characters into Cinema and making it linked up with the Cinema4D character tool. And so you can add your animations on top of it. It's really powerful and really nice. But in any case, we got this character. He's dancing around. He's doing his thing. Let's pause it. I'm going to hit download and leave it all default. Let that download. Okay, that downloaded. So I'm going to open it up in my folder and then drag that directly into Cinema. It's going to have all these import settings. Just leave them default and give that a second. It's going to pop in, open everything up. And there we go. It refreshes and I can hit play. And we've got a dancing character already textured, fully rigged, ready to go inside of Cinema. But of course, we don't want the animation, so we can get rid of it. The way we get rid of it is actually you have to go into the takes system because it was imported into a take layer. Select the Mixamo layer and then say File and say Current Take to New Document. So I was going to split it off into a separate file. And now we've got this. If we expand this, you see we've got all these different joints. Now what we can do is put him to his T-pose by selecting the geometry. And this particular character only has a single piece of geometry. So I can click on that and there's something called Reset Bind Pose. If you click that, he'll go to his T-pose. So without clicking undo or anything, let's go ahead and click the bottom joint and then all the way up to the topmost joint. And you see all of the keyframes, they're all here on the position and the rotation. So I'm actually just going to select R and then hold down Control and click P. And then you see I have all the R's and all the positions selected. And holding Control and Shift or Command and Shift, if you click on any of those keyframe dots, it'll actually erase all of them out and delete the tracks. So now there's no animation here whatsoever. So with that in mind, we're going to have to do the fast forwarded version of this, but selecting all of that, let's go into our scene file with the ragdoll, paste this. I'm going to save it really quick because I don't want to lose any good information that we have. So let's just change this to the Mixamo file. Okay, so now I'm going to talk through maybe more of the procedure than literally going through the entire thing. And if you do this in a kind of clean, meticulous way, it's not too bad. So what we are going to need to do is go to every single one of our models, every single one of our different meshes here, and snap the axis to the equivalent joint. Now, what I want to mention is look at how perfect this is matching our character. Like it is really, really close. And it's just a great workflow with Mixamo. But all I want to do right now is select the axis tool, and I've got the pelvis selected, and I want to snap the pelvis's axis to its equivalent joint. So I'm going to hit P for snap and turn on snap, hit P again, turn off vertex snap, P one last time, and turn on axis snap. And now I am going to move the model's axis to every one of the equivalent joints. And we're just going to whip through these, snap, and I'll probably fast forward here because this is just a little tedious. So we'll snap. Okay, so those are all snapped. Now what we need to do is move all of our equivalent controls, and you're going to see how useful it was for us to kind of build the hierarchy the way we did here. We need to essentially do the exact same thing, except we're going to turn off the axis tool. Make sure the axis tool is off, otherwise it won't move the children. So I'm going to move that to snap to there. And actually, we'll just go through all of these. And I'm just going to snap all of, every time we have a connector, it's going to snap to its equivalent spot. And let's fast forward again. And snap. Okay, now that those are snapped, let's turn off snapping. Letter P, turn off enable snap. And now I'm just going to go back down the hierarchy again. And we have to do the exact same thing that we had been doing, which is before, which is pulling that up, kind of offsetting it that little bit. So pull up and make sure your blue line goes the equivalent down. Grab this one, pull it up, make sure that that lines up. So let's fast forward one more time and make sure you're doing the opposite. Like that one goes up, so let's pull it down. So just give it that little bit until you can see your blue line going the correct orientation. And scoot the last one. There we go. They're all snapped. Of course, you do not have to do the hinge ones. And now everything is moved into their new positions. Now, the last part is you can be as meticulous and specific as you want to, or be very quick and sloppy. But the last one is actually just going to polygon mode and manipulating the polygons of any given one of these objects and matching the model as accurately as you want to. So I can scale these up. And it's okay if they pass through each other a little bit. You just want to match it as well as you visually can. And the more accurate it is, the more accurate your model will be. And even here, don't worry, we're not changing the axis. That's already in the correct position. So just make this match as well as you kind of visually can. And I'm not going to really, I'm going to do this quickly. And but you could go through and start moving individual polygons or even modeling a little bit and making them more accurate. And the more accurate you make it, the more it's going to match. But you don't have to go that far and it will look pretty good. So let's just go through and speed this up again a little bit. Okay, cutting back in for a moment. I just moved all the arms up at the same time because once again, we're just moving geometry. But I'm going to select all of these. And here's something cool if you didn't know. With all these selected, I can actually select any one of their axis and that will become my pivot point. So I actually move all three of them at the same time just on a single pivot. So once again, I'm just moving geometry, but I'm making it match as quickly as possible. And I'm shocked at how sloppy we can be with this, and it should work pretty well. So back to Speedy. Okay, and make sure you get the feet right. If the feet are not quite correct, these I'm going to scoot back. They're a little bit long, T for scale. Scoot them back, T for scale. So if those are a little bit more accurate. Now, once again, you can see how crazy sloppy I just was with all that geometry. I didn't really care how perfect they were. They're not lining up. They're not even perfectly symmetrical in any way. But before we break anything, let's save it. I'm going to save this number 1G, and this will be Mixamo matched. And before we do anything, let's hide the Mixamo character and make sure that this is still working. If you did everything the way I just did it with any luck, it might fall a little bit, but let's hit play. And look at that. It is still a ragdoll. It's still bouncing around and everything is still matching. And honestly, the proportions don't look that crazy. It's just kind of like a bigger character now, and everything's still facing forward. It's bouncing. It's maybe a little bit shorter, or the mass is a little bit different. So our upper body maybe wants to be a little bit lower. So we can grab this upper body. We can grab the linear field inside of it. Let's just scoot that down until he stops bouncing. Excellent. All right, all of that is working. Now it is the last step for making this character work. I'm going to collapse the entire thing down as I have been doing, re-expand, we can see it. And this is, it gets a little bit weird, but just follow along. I'm going to create a second object manager. And the second object manager, we're going to make it bigger, and we can expand our entire Mixamo joint structure. We can make it visible as well. And what I'm going to do is start dragging the equivalent joints directly into the character. Now, we could do fancier methods. We could start matching it. We could use constraints to make it fancy. We don't need to do any of that. Let's just do the very basic version. So I can grab everything and make it a child of the pelvis. I'm going to be jumping back and forth between the two. So don't be shy about doing that. So everything is inside of there. That makes sense. But everything that goes up to the torso, let's go to a front view here. Everything that goes up to the torso, let's figure out where that is. Not that one. That one. That's the one that's pivoting from the same spot. So that one gets moved over into the upper body. And then we have our neck. Nope, the neck is too low. So it's actually the head. The head joint is the one that we were snapping to. So the head joint gets dropped directly into the head. And then next up, we have a shoulder. Well, the shoulder is not where we pivot from. The arm is. So let's go to left arm. We'll drag left arm into left upper arm. And then we can grab the right arm and drag it into the right upper arm. And then we start jumping back here, whichever way makes it quicker. We can grab the forearm. So that's the right forearm. Drag it into the right lower arm is the equivalent. And then down here, let's grab our left forearm and drag it into the left lower arm, I do believe. Yep. And then we have, what do we got? We got our left hand. That is the equivalent. So we'll drag that into our left hand. And we have our right hand, obviously equivalent to our right hand. Now there's all these fingers and everything. We're not worried about those. So let's collapse those down. And then let's go back into the pelvis, because in here we have our upper leg. Excellent. Upper leg, which should go into our right upper leg, which is right here, the right thigh. And then we have the left lower leg, which will go into the right. Looks like I just I accidentally dragged the left leg into the right leg. So I didn't mess anything up yet. I just have to drag in the right spot. So let me make sure I drag the right thigh, the left leg into the left thigh. There we go. Geez, I was completely blind. Left thigh. And then the left lower leg goes into the left shin. And then the left foot goes into the left foot. You'll even see the joint start kind of visually breaking there. It doesn't matter. It still works. And now we just have the last one, which is the right upper leg, which will drop into the right thigh. Right leg, which goes into the right shin. And once again, you just click it, you see which one the equivalent is, and drag it into the appropriate spot, into the right foot. There we go. They've all been dragged into their proper places. Go back to our 3D view. We do not need to see the character anymore. Or no, we do want to see the character now. In the ragdoll, we actually don't need to see the ragdoll anymore. We just see our final character and hit NA, so we don't see polygons. And with any luck, we can hit play, and nothing happens. Why does nothing happen? That tripped me up a lot in the beginning, but let me show you. Let's collapse our entire hierarchy and expand the ragdoll. And what we need to do is select all the dynamics tags. And inside of R21, they changed the defaults in the collision, and it's by default applying the tag to the children, but it doesn't know the joints don't know what to do with that. So if we say none and set individual elements also to off, those are now not affecting anything inside of their own little hierarchy. And now if we hit play, we have a fully dynamic Mixamo character that all the same things we were doing to the other one, we can do here. We can collapse on the ground. We can turn off the gravity, and we can start making copies of them and have them be floating around and do whatever we want. Now, a couple last little details are really important. It really, like there's a whole character, there's a whole rig, there's all this mesh stuff. It can start slowing things down significantly. So what I've been typically doing is I pull the ragdoll out, and I'm going to hit Alt-G to put that into a null, and we'll rename this character. I'm going to grab the character and drag it also into there. And now we're hiding these different parts. So if we were to drop this into the cloner, I guess here's another important detail is this rigged character will not work in the cloner. You cannot work him in the cloner. What you can do, though, is make a couple of clones and then make it editable. Now, like I said, this is going to slow down a lot. So I'm going to drop this down to 3. So we have 3 of them, and I can make it editable. As soon as it's editable, it will completely work. If I hit play, we have 3 completely separate characters. We turn on force. They're going to be attracted, first of all, to themselves and then to each other. We can turn gravity back on, have them collapse. It's just hilarious and fun and weird to mess around with. But you see, there is a significant speed hit there, and you have to make that editable. So what I suggest is, first of all, only make changes at the time of 0. Make sure you save your scene file before you make it editable, because very often it's like, oh, I want to do it. I'm going to tweak the gravity. I'm going to tweak some settings. I'm going to change the ragdoll a little bit. And then you're like, oh, I didn't make my cloner not editable. And you have to go back and fix that. So make sure you have to undo the make editable before you put it back in. Now, having said that, a couple of quick little workflow things. First of all, you're free to, if this character isn't in the cloner, you can just copy and paste it and you can make as many of them as you want. That does just automatically work. And they're completely separate. They're individually dynamic. They completely work in this scenario. So that works. You can just make copies, and I'll delete that one. And also, if you want to run test simulations, you can always throw the entire character in. And then what I've been doing is I just pull out the geometry and then turn on the cloner. And now you have to unhide your character, obviously. But if I turn my characters back on again, I can crank this back up to pretty much the same number that we had before. It might be a little slow down with all the joints inside, but yeah, it's still pretty quick. And you can see I have all these characters, and I can run all the simulations and do my tests and be like, okay, cool, this looks cool with all these characters. We have all of our characters and we have control over them. And then when you're ready, then all you have to do is, I'm going to pause, rewind, and then all I have to do is drag the character, the geometry, back into my character null, make it editable. And then before you do that, make sure you hide the ragdoll again. Make it editable. And now, boom, it's going to be working with all of them. It should be the same simulation. So that is pretty much all the different details. And yeah, man, there's a lot to cover there. Maybe I'll do some follow-ups. There was some extra information that I definitely could have gotten to that we did not get to go to here. One of the things being that we could start using field forces and create extra controls where you can make like a whole dance party where these are all fully dynamic and they're dancing and they're bouncing off each other, and you make the hands jump independently and make the hands start feet do different movements. And then, if you start going even deeper with field forces, then you can do things, these weren't fancy renders, this is when I was doing testing, but I can even do something like use field forces and crash this ball through there and make it so that anything that was hit is going to turn off for a little while. So they'll actually collapse down and be dynamically stopped. So maybe I'll do some follow-up. So make sure you come and follow on YouTube to see some additional information on that. But that should wrap up the meat of this one. So hopefully that was as fun to watch as it was to play around with and make on my end. It's just a really fun technique, and I can't wait to see what everybody puts together with it. It really just ends up being another tool in the toolbox. It can be applied in so many different ways. Dynamics in Cinema4D has always been one of the most fun things to do, and applying it to characters is just like this exponential increase in like chaos and fun that you can have with it. As I said, this originated as a question on a live stream. And if you'd like to come hang out on those live streams, we answer Cinema4D questions live every Wednesday on Twitch and on YouTube for at least 2 hours. We've been going more like 4 hours during these crazy times. And it's just a lot of fun, and it's fun figuring things out together, and the chat helps me figure it out, and we just make some fun, crazy things. You can follow that on YouTube and on Twitch at Rocket Lasso. In fact, you can follow Rocket Lasso at all of the things: Instagram, Twitter, LinkedIn, all the different places, Facebook. And if you really like this kind of stuff, we're working on new plugins. We are working on tutorials, always got tutorials out, and like I said, the live streams. But we've also got a Patreon set up. If you appreciate this kind of stuff, you'd like to see more of it and help support the kind of stuff that I do over here and that my brothers are working on, then that would be really appreciated. If anything we've ever done was helpful to you in the past, it's deeply appreciated. All of the scene files that were created during this are going to be available on Patreon as well for anybody supporting at any level. In addition to that, there's bonus live streams and early access to things and all the scene files from all of the live streams. So it's appreciated, but the tutorials are always going to be out there and free, and the big open live streams. And eventually any fun technique just ends up out in the world for everybody. And that's really important to me. So thank you so much for any support, and thank you for watching very much. And I'm looking forward to seeing everybody again when everything goes back to normal. And thank you very much for watching.
5, 4. All right, everyone, welcome back to C4D Live. I'm Matthias here at Maxon US headquarters in Los Angeles, accompanied by the one and only Chris Schmidt of Rocket Lasso, all the way in Chicago. Hi, brother, how are you?
I'm excellent. Thank you so much for having me and having everybody. It's been an absolutely incredible lineup, and I've actually gotten to watch pretty much every presentation, which I never get to do.
Yeah, a little bit change of pace. I mean, I miss it, but yeah, I mean, I think everybody is getting a chance to see more. which is really nice. We have a bunch of questions, so we can go through those, and then probably more will roll in. You know how it goes. So let's get started here. Can't you do something similar with IK dynamics on the ragdoll stuff?
IK dynamics, you can quickly make something be sort of ragdoll, but it's not going to have very good intersections with other things, and I definitely don't think it would work once you throw it to a cloner and start applying field forces and everything on top of it. I think it would break down quickly. But if you're doing a very, very basic version, then yeah, I think you could do some of the basics that way.
Cool. All right, that takes care of that. Moving on. For this ragdoll, you're limited by a character. The question is, are you limited by the character being broken into different objects? Is that a limitation of this technique?
I think that's what you would want to do, is you're essentially building a low poly proxy of whatever is going to get driven. But you saw, and I think that question might come in earlier before the end, because eventually you can apply it to any character. So essentially a good way of thinking about it is every major joint that is used to build the character up, that gets represented by an equivalent low poly bit of geometry, and then that will drive that joint.
So it's just more joint to joint driven, not necessarily object.
Yeah. And a single object would just be, it would be like a giant soft body or something. So individual parts have to be dynamically driven at some point. So
very cool. I don't know if this is a question or a request. Chris, when are you going to do a tutorial with Andrew Kramer?
Well, I chat with Andrew. So I don't know, who knows? Maybe there's some good combination, especially with them doing a lot more 3D over there, and their presentation was absolutely killer. And man,
maybe SIGGRAPH. Maybe we set something up for SIGGRAPH. Do a dynamic duo. Let's see here. What kind of mic are you using? People want to know.
I've got a Shure. Is it Shure or Shure microphone?
Sure.
But yeah, I slowly upgraded my setup here where I plugged in my point and shoot camera. So I've got a Sony camera going through a video card, and then this goes into a box. Slowly upgrading my setup. But yeah, nice Shure microphone.
Looks good. Sounds good. Looking good. Let's see here. What kind of mic? We got that. Another question. Why didn't you start with the Mixamo model in the first place?
I'm not sure. Well, I mean, the point is that the ragdoll is just a tool that you can use to apply to a lot of things. So maybe you made your own character and you want to apply it to there. Mixamo is not going to help in that equation. Maybe you're ending with a ragdoll. Maybe I've actually done it where I made a very low poly like paper character, and instead of binding it to joints, I bound it directly to that geometry, which you can actually do. You can actually bind directly to anything, not just joints. And I was able to drive that paper character directly with the ragdoll. And of course, you can run the ragdoll very quickly and clone it very easily. Once you use the Mixamo character, everything slows down. So having it segmented out like that just gives you a lot more flexibility.
Flexibility and speed. Let's see here. I think that was a two-parter, which I think you explained both of those. All right. Why didn't you just parent constrain the skeleton rather than actually breaking up the skeleton? I think that was kind of the same thing, right?
No, it's a different question, and that is potentially valid, but I don't think that would work once you put it into a cloner. So I was trying to make the entire rig as compatible with a cloner as possible, because seeing a crowd works really well, and things like Espresso and certain things just don't translate once they're clones. But once you make it editable, it might suddenly reactivate again. But I was trying to make it as compatible as possible. It is highly likely that you could just drive this with parent constraints or PSR constraints, or if you built the rig, if you structure the skeleton or the ragdoll in the perfect hierarchy, you might even be able to directly use a pose morph and blend between those that way. There's a lot of possible combinations.
Very cool. All right, that would take care of that one. Hopefully that got you taken care of, Steve. That was actually one of our tech guys. I was wondering that. All right. Did you ever try a mesh deformer to attach a mesh to the ragdoll? Or is that method too heavy?
That's an interesting question. There's a lot of techniques that we could try and tackle here, and I already went over the allotted time I was supposed to, just to cover everything that I possibly could. And that's a really good idea. I'm not sure if we could put multiple objects in as a mesh deformer, and then you probably have problems with the blending because you can't paint the weights that way. But you could probably drive a low poly proxy of a Mixamo character or something, and then use that to drive it. That's potentially a valid technique.
So using a low poly proxy for the mesh. Let's see, deformer. Okay, interesting. All right, is there is it possible to use field forces to mimic simple IK along this ragdoll?
Mimic simple. Oh yeah. Well, okay. I understand. I think I understand. Is yes, it is. It's built as a ragdoll, but IK, IK would make it so that if it's driven from the hip, you could grab the foot and move the foot around, and the hip will still be staying in the exact same spot. So you totally can do that. All you have to do is, well, you could do two things probably. One would be crank up your follow position, follow rotation on, say, the foot, and then keyframe the foot when it's not dynamic, and then it would probably try and follow. But you saw in the very beginning, I kind of did this Indiana Jones animation, and he's running along, and it's intentionally kind of over the top and cartoony. But what I did is I keyframed a couple of springs. I attached the spring to the foot, and I keyframed the spring moving, and the spring is going to yank the ragdoll. So at that point, you have to think of them more like marionettes. So you can attach a string as a marionette. Of course, it's an invisible string, and the string could be, a length of 0, and you just tug that around wherever you want. You're always going to get that. You're either going to be fighting the overshoot, or you're going to be draining tons of energy out. So at certain points, like, well, I don't know. There's good hybrid methods, but if you're going to push it really far, then you should just be doing the keyframe animation and not dynamic. But you could do every step in between, definitely.
Got it. I think this is your robots. Someone's talking about your robots. Are you going to animate your robots using this technique?
I've thought about it. I've been working on a series of robots to be posting on Instagram, because I don't post on Instagram often enough. I spend all my time just doing fun technical demos, and I don't tend to bring too many things to completion. I'm trying to fix that and do more rendering and whatnot. So I've been trying to build a little bit of a backlog before I start posting. So I've been modeling and rendering and lighting and even rigging up a couple of robot characters. And this would apply to anything. You saw right when we applied it to this character that as long as it's kind of got a vaguely humanoid shape, we can just adopt this directly onto that in like 10 minutes onto pretty much any bipedal character. And then, of course, you could just spend a little more time to build a more complex rig if you're applying it to something like a dog or something. But I don't have a specific plan to, but if I had an idea for an animation that this would apply to, yeah, this would totally work.
Very cool. Let's see. Can you apply the jiggle deformer to the setup? Is that an EJ question?
Oh, yeah. There's iDesign asking, where was the jiggle? Well, I mean, if I do a team-up tutorial with EJ, then we could apply that after the fact. And and ultimately, the character, the Mixamo character that was imported is just being driven by the skin deformer. So I think a jiggle after that would just automatically work. So
yeah, because it's just affecting the mesh, and then the mesh is actually moving.
Of course, anything that's getting jiggled has the potential of passing through other objects. So you have to go really light on it.
Yeah, I don't know if EJ knows about really light jiggle.
200%.
We'll start at 200% and work our way up. All right. What technique of let's see. What is the technique of using baked Mixamo animation and the dynamic stuff at the same time, like a dancing character then floating in the air? So switching between the baked to the dynamic stuff.
Yeah, sure. So if you had like some motion capture. You have some motion capture animation and you want to transition between the two. Two ideas popped in my head. One would be the one we just talked about, which would be use springs and drive the spring directly on the same joint. I think it'd only take a few minutes to apply like the hands, the hip, the head, the feet to the equivalent of the dancing character. And you'd get kind of a ragdoll version of that movement, and that would be kind of fun. But I was hoping to actually do it in this presentation, but I didn't have anywhere near enough time. This presentation could have been like 4 hours, and I was already talking pretty fast. But I think that there might be a way of just fully transitioning between, like, essentially using pose morph, a hierarchy pose morph of like position, scale, and rotation, and fully transition from a dynamic character to a keyframed character and just smoothly blend between those. So as long as it kind of matched on a single frame, you could blend between them and seamlessly go from one to the other. I haven't tested it, but that's the idea.
Very cool.
Maybe I'll do a follow-up.
Baron's saying that I ignore his questions. I haven't even seen your questions, Baron. Are you adding me in the chat? At me. I wouldn't ignore you. Stop it. All right, let's see here.
Spanish.
Let's see what else we got. Baked Mixamo. What kind of webcam? People want to know about the webcam. Because you've been upgrading. You got
yes,
the Shure mic, and what do you got for the cam?
Yeah, it's actually not a webcam. Like 2 years ago, I was like, oh, I should try and do a little bit of photography, and I got a bunch of advice from friends, and I didn't want to go overboard. It's like, what's the best quality for something relatively cheap? So I bought an Sony A6000, and it's a great little camera, and it's, it doesn't break the bank, and I got a lens or two for it. It's really fun. But then I went nuts for like 2 months, and then I didn't really use it. I brought it on one vacation, and then it sat in a box for like a year. So when it came time to upgrade my setup, I was like, hey, I'm just going to take the camera. I did a little bit of research. I bought a little Magewell like video converter, and it plugs into the camera, and that goes straight into, I think, HDMI. And so my webcam is actually a full Sony A6000.
Yeah, looks great. I need to upgrade my webcam.
Yeah, it's worth it just for the depth of field. It's great.
Yeah. Oh, I'll just click blur my background. Wait, no, I'm joking. I'm not going to do that. All right, let's see. When are your plugins available? People want to buy things.
That's true. I would. Over here at Rocket Lasso, we're working on something. We're trying to make something big. It's kind of like a whole suite of tools, but that's not ready yet, and I don't like teasing. But we've got a smaller tool that it's kind of like an idea just popped in my head, and and we are working on it, prototyped it. One of my brothers coded it in a very short time. And I was like, whoa, this is actually way more powerful in a very simple way than I thought it would be. So we expanded the idea a little bit, and we're testing rapidly back and forth right now. And that will be something that will be coming out pretty quick. I'm actually in the testing phase, so I wouldn't be surprised if that one's not out in a month or two. It's the hope, and it's kind of like a good test for like getting things out there.
Just to get something.
But I
get a smaller one first.
If it was around the corner, I could have done a little demo of it, but we're not quite there yet. But don't worry, it'll be coming out soon. I think it's neat.
Awesome. Okay, Bernd. Okay, Bernd, you finally asked me my question. I was asking Chris to do a tutorial on how to generate a tree or create a tree generator in Cinema using thinking particles. Oh, geez.
So no. So Bernd is referring to, oh man, 10 years ago when I first met everybody over at Maxon, and I had made this super crazy thinking particle setup that you could generate a tree. And this is years and years ago. And I ended up showing it to somebody at Maxon. And it's actually one of my favorite stories. I had a friend who I knew online, and I showed her, and she worked for Maxon Germany. And then she's like, oh, you should show this to Kai. And I show it to Kai. And the Kai's like, you should show this to Rick. And I show it to Rick. And then he's like, you should show this to Paul. And I show it to Paul. And Paul's like, you should come to dinner with us. And I was like, and I ended up recording the making, or actually, maybe not even the making, just the using of it for Cineversity, like way back in the day.
Wow.
But yeah, really
right
fun.
Before I got here. So it was 10. I guess I'm going to my 11th year. Jeez. All right. We're getting up there.
Joel wants me to have you on Rocket Lasso Live. We should totally line that up. I've had Rick on as a guest a couple of times. That'd be cool.
No, let's do it. Let's do it. All right. I'll be on the show. All right. I guess I'm sure somebody else will have one more, and we're running a little bit over, but these were all good. Favorite color?
I actually kind of discovered a new favorite color, I think a week or two ago on live stream. Like while we're there, I dragged the slider. It's like, oh, that color is gorgeous. And I don't know the name of the color, but essentially it's if you make a really light blue, like a really saturated light blue, and then you grab the value slider and you pull it pretty close to black, and you get this like just gorgeous, rich, dark blue. I don't know. It's gorgeous.
So you're going to have to share it in the chat later.
Yeah, you'll be seeing it. Yeah, you'll be seeing it around in a lot of my stuff probably because it's my current favorite color.
It's current favorite. Favorite comic book character.
Comic book character. I guess that's the two-parter because it's like as a comic and then what they've become. Because in a meta way, I was like I got super into Tony Stark because he's like a super engineer, which is really cool. But I gotta say, as much as I always love the scientist character and the engineer type character, the MCU really, really made me like Captain America. Like I'm Captain America all the way. He's just so like wholesome and go get him. Like that's so good.
The finest parts of America.
Yeah.
Behind the shield.
In actual comics, I'm a big fan of Atomic Robo. He's really cool. It's a robot built by Nikola Tesla back in the day, and he just goes on science adventures. And it's really well drawn. And I like the stories. And I think it's mostly available online too.
Do you have a favorite podcast or YouTube channel that you like to watch for science inspiration or anything else you want to share with the folk?
So many. I have too many to list. I don't watch TV. I pretty much just use YouTube, and I've got so many channels. I follow so many different things. My favorite YouTube channel for entertainment is Red Letter Media. They do movie reviews, and they got a whole spectrum of things, but they kind of they do good movie reviews, but they also have a segment where they review bad movies, and it's kind of joking, and they have a panel. And to me, it's like the modern day Mystery Science Theater 3000.
Oh, okay.
It's kind of the vibe I get from that, and they have some ironic reviews and whatnot. I just love that for entertainment. For a serious one, I really love the Sam Harris podcast. It's always tackling like really deep issues that are like taboo topics that people aren't willing to touch, and it's just like, hey, let's figure these things out. So I really like that one a lot. I always recommend it whenever I can.
You should put there a list on your Instagram or something.
Yeah. Once I get the website up proper, get a folder. I'm constantly asking for advice from other people because I want more things. And YouTube channels, TV show, it's like, oh, the season ends and it's coming to an end. YouTube channels tend to just disappear. If you're following like 50 channels, it's like, wait a minute, I haven't seen a video from blah 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 in like 3 months, and they're just gone.
Yeah, they'll just ghost you.
You have to keep on replenishing.
Yeah. Well, I think that's all we have time for today. Let's see. I guess a really quick one. If we can make these quick. What's your 3D printer doing? That's a really random one.
Well, it's sitting right behind me, just off camera.
It's not printing.
It's not printing anything right now. I have to be careful because it is. You got to be careful with a 3D printer only printing at certain times if you're around to take care of it. And I don't know. I go through phases where it's like over the course of a year, there'll be 2 months where I'm like 3D printing, and then the rest of the year it just kind of sits there. I package it up and cover it and make sure it doesn't get too dusty. And then I get the laser cutter, so those kind of alternate when I.
Yeah, we need to talk laser cutter off camera. We'll talk on that. But
yeah,
Redshift, are you doing any tutorials? Somebody was wondering.
It's entirely possible because I've been. Especially with these robot renders I've been working on, I've been trying to go deep on Redshift. And recently I was trying to make something look as almost like a sketch and tune look in Redshift. And I was actually impressed at how far I was able to get with that. I tend not to make a tutorial unless I feel like I know the subject kind of inside and out to the point where I can explain. For me, it's always very important to explain why we're doing things and not just how to do them. So I need to
people
understand
like you. That's why people like you. you get that nuts and bolts of it.
Yeah.
But thank you so much, Chris, for being on. Always love having you for all the different years. I remember back when we first met, you were just off, not actually on stage. You're always stage adjacent, answering questions. So it's always great, and love that you've taken the stage and you've contributed so much to the community. So definitely thank you, and I'm sure everybody online, thank him if you get a chance. But stay tuned. We're going to go to a quick commercial break, and then we'll be back with our next and last presenter of the day. And I believe it is Seth Worley. Yeah, so stay tuned. If you guys haven't seen his short, darker colors, it's something to definitely check out. So we'll see you after the break, folks.
Create without limits with precision mobile workstations. Maximum power, speed, and performance when and wherever you need it. So you can perfect every pixel. Break ground in unexpected places. And make the most extraordinary ideas a reality. Discover your next big idea. Precision mobile workstations. Create without limits.
When's the last time something moved you? Was it a flash of beauty? A twist of phrase? A bit of brilliance that blew your mind? What if you could move people like that? And what if you could do it with shapes, sounds, design, and movement? When it comes to motion design, we believe everyone deserves the chance to move from novice to superstar. So we've created an online place for that to happen, so no matter where you are, we're there too. We're opening up worlds of possibilities for our students, and we're kind of obsessed with doing it well. Our teachers aren't just skilled working professionals. They're also the top motion design experts in the industry. Our critiques aren't vague and generic. They're valuable insights about your work. Our classes aren't easy. They are intense and effective, a tidal wave of knowledge. And our students aren't faceless usernames watching talking head instructors. We're a tight-knit community of highly driven learners, filled with global collaboration, inspiration, opportunities, and plenty of fun characters. At School of Motion, we take a full art education, strip it down to the essentials, and supercharge it with real-world grit. And we're equipping our students to do amazing things for some of the best brands and studios out there. In fact, this thing you're watching right now, and even this, was made by School of Motion alumni. Now it's your turn to create something truly moving. And we're ready to help you do it. Because the things that move you forward move us too. School of Motion. We're not just a school. We're a movement.
Toolfarm makes waves with amazing deals and fast and knowledgeable customer service.
Swim on in for incredible deals on software and plugins at Toolfarm.
Mograph.com, an online resource for motion graphic artists. Start your week with the Mograph podcast. Industry news, interviews with your favorite artists, and terrible humor. Watch live shows and interviews from Mograph events like NAB, SIGGRAPH, Half-Res, and local meetups.
This is exactly what I should be doing.
Our Mograph talks feature live demos and motivation from artists all around the world.
Sometimes you gotta make stuff that you're not gonna put on your reel, and I'm not here to judge.
What if Rick and Morty show up for the countdown at midnight? That's where I peaked in life, in my career.
We gotta stop this thing, Rick! It's gonna kill us all!
Hear from the people that create your software, design your render engines, and artists that are changing the face of modern motion graphics.
You get that render done. Yeah, you better frame what?
Mograph tutorials and online classes will teach you about Cinema4D, After Effects, as well as other popular software and render engines.
Throw in HDR Studio, take the render settings, pick the HDR, put in a reflection, and gorgeous.
Join the conversation in our live sessions.
Ah, that's so funny. All right. I'm going to live forever.
Subscribe today and get the latest updates on our YouTube and other social media channels.
Take all your dreams and just do it!
Subscribe to mograph.com.
Hello, everyone, and welcome back to C4D Live. My name is Matthias, your host here in LA headquarters of Maxon US. Wanted to actually remind everyone, we're giving away over $18,000 of prizes from some of our sponsors such as HP, Dell, NVIDIA. So definitely check that out. There's tons more out there as well. Kitbash 3D is giving away a nice kit that's free. Pixel Labs in there. Red Giant Complete. There's so many different prizes you can win. So if you haven't registered, make sure to do that. Also, if you're trying to get in on subscription and join the Maxon family or convert any of your old licenses or anything like that, definitely check out the special that we have going on. Getting into subscription before the end of the month can get you 50% off Red Giant Complete for the first year. So definitely check that out on maxon.net. And now from our very own Red Giant, we have up next a longtime, amazing, creative Seth Worley.
Hello, I'm Seth Worley. I'm a writer and director of branded films and commercials for clients like Bad Robot, Sandwich Video, and most notably Red Giant, where for the past 7 years I've served as a senior content creator, making short films and branded content to show off Red Giant's tools for visual effects and motion design. Why don't I just show you my reel, just to give you a visual for who I am and what I do.
Now I know you're probably thinking,
who is this genius?
Watch.
My dog pooped.
Hey, let me finish. That was pretty much it.
Money, please. So you can see my work tends to skew fairly comedic while leaning heavily into genre. I grew up inspired by filmmakers like Robert Zemeckis and Steven Spielberg. I've always had a taste for VFX-heavy, high-concept stories. I started making short films for Red Giant back in 2011 with a short called Plot Device, which was created to showcase the power of Magic Bullet Suite's super awesome color correction tools. That was back when you could make a viral internet short and wind up directing a Thor movie 3 months later. I did not get the Thor movie, though I do know that Marvel folks are fans.
That's really gross.
But that short kicked off a series of shorts we continue to make here at Red Giant. The most recent being this one, called Darker Colors. Here's the teaser for it.
Monsters? You couldn't be into like ponies or rainbows or something? You'd rather fight a pony?
So there's a scene in Darker Colors where the character Jack creates this makeshift flamethrower out of aerosol, spray can, and a lighter to keep this monster away from him. The monster's made of crayon, so if the monster gets anywhere near him, it will melt. For obvious reasons, we didn't want to hand an aerosol flamethrower to a child and ask him to wield it in a basement filled with wood. We opted to create the flame in post and After Effects. A really helpful part of this was this practical light that we used on set to create interactive flame light on Jack's face. So anyway, here, let's dive in. So here's my plate, and I've gone ahead and pre-tracked 3 nulls to this scene. These 3 nulls are going to provide all the information that I need to be able to put the flame into the scene. I don't need a 3D camera track or anything. I just need the motion data from these 3 points. I've got the scene null, which I tracked on the doorknob back here in the background. That is going to basically allow me to match the camera shake. Then I have this lighter null that is, as you would expect, attached to the end of the lighter. And then I have the spray null, which is tracked to the spray can. Now, first thing I'm going to do is I'm going to create a 4th null that I'm going to call the fire null. And then I'm just going to parent it to the scene null. So now it will stay paired to the scene null no matter where I move it. And I'm going to come back to that. I'll explain in a second why I created that. So let's create a fire. I have this fire flamethrower asset that I'm pretty sure Andrew Kramer gave me a year ago when I started working on this short. If it wasn't you, Andrew, and you know who gave this to me, I don't know why you would know, but if you're out there and this is your flamethrower, great work. And please reach out and tell me so I can give you credit in things. So I'm going to drag it into my comp, and I'm going to center it up here in the frame so it is fully contained in the frame and pretty well centered. I lose some of that fire right there, so I'm going to see if I can get all that in there. Okay. Now, I am going to go to Layer, Pre-Compose. I'm going to pre-compose this fire, making sure I select Move All Attributes into the new composition, and I'm going to call it Fire. Now I'm going to go to the puppet pin tool, and I'm gonna apply 2 puppet points. One on this end of the fire, and one right here on the ignition point of the fire. And if I go down here into my mesh, I'm gonna turn these keyframes off, and I'm gonna parent the pin position to the fire null, and I'm gonna parent this pin position to the lighter null. And the reason for doing that is because I want the flame to always be originating from the lighter, but I don't want the whole flame to float around with the lighter like it's some kind of 2D card attached to the lighter. I want the end of the flame to stay in the quote-unquote three-dimensional space of the room. I want it to move with the handheld camera. So this is my workaround for doing that. There's probably an easier way to do this, but that's kind of my brand, is doing it the hard way, because I wasn't ever properly educated. And here I am teaching you. So allow me to teach you the uneducated, weird version. I'm going to start with the ignition. I'm going to actually just use this pick whip here. First, I'm going to make sure that I can see my lighter null position. I'm going to take this pick whip next to my pin 2 position. I'm going to drag it down to the lighter null position. And boom, now it is attached to the lighter null. As you can see, this one, though, needs to go somewhere. So you would think that I should just take this pick whip and drag it to the fire null position, but it's way up here, even though the fire null is down here. And the reason for that is because the fire null is parented to a null of its own, to its spray null. So it throws off the math here, it throws off the numbers here. If I unparent it, you'll see now that's working the way that it should. But I need this null to parent to the scene null. So I'm going to fix this with some expressions. If I go down here and I can see the expression here that's allowing it to be parented to that position, I'm going to replace this transform.position with 2comp in parentheses brackets 0, 0. And now it is parented to wherever that fire null is in relation to the rest of the comp. Within the comp, it will always stay stuck to that visual position. Now, it's doing some weird bending there, and the way that we can get around that is go to our mesh expansion and turn that up. And now it does more stretching and now it does more stretching and squishing. So now I can, you'll see that if I hit play, the ignition is parented to the lighter, but the fire is ultimately staying in that space in the air, parented to the scene null. All right, so for now, we're just going to turn off the fire layer so I can't see it. We're going to move on to making our flame on the end of the lighter. So I'm going to create a new solid. I'm going to call it flame. And I'm going to apply trapcode particular. And you'll see I've got this emitter sitting here in the middle of the comp. I'm going to, first thing I'm going to do is I'm going to parent the position of the emitter. I'm going to actually parent it to the lighter. And I'm going to do that by going down here to the controls, make sure my lighter null position is visible, and I'm going to alt click, and I'm going to drag this pick whip down to the lighter null position. And then because this is a two-dimensional null that we are parenting to, that Z space needs to just stay 0. So I'm going to replace that one right there with 0. That third one is the Z parameter. All right, so now it's parented to the lighter. Now let's turn that into a flame, shall we? I'm going to start by turning the velocity down to 0 in the emitter. I'm going to go to my particle, and I'm going to make sure that it's a sphere. I'm going to change the size to maybe like 20. And then size over life, I'm going to have that be constantly scaling down. And the opacity over life, I'm going to have that start at 0, crank up to 100, and then go back down. Now, this is way too long, so we need to turn our life down. Let's turn our life down to maybe 0.25. Now it's super small, but we're starting to see some more flamey looking flames there. So let's go to set our blend mode to add. We can't see any difference, but we'll see it when we do this color over life. And you drop this down and you see these gradients, these ramps that are provided. I'm going to do this one because it's a simple 2-color gradient. I'm going to start it at black. Then I'm going to have one right after it that goes to like a blue. And then immediately up to like a flame, orange-ish color. That looks pretty terrible, to be quite honest. Maybe it's too saturated. A little too long, actually, too. Let's turn our flame life to maybe 0.15. That's a little more flamey. I'd say the blue is too saturated, too. Too dark. So maybe try that. We've got kind of a flame, but we're seeing the particles kind of break up here when it moves real fast. So we can go to motion blur, turn that on, but it's still, I feel like we're still getting some of that particle breakdown there. So that can be fixed by changing our particles per second. Let's just double it to 200. Now that's a solidish looking flame. But the thing is, it's not when it's not moving, it's just a little dot. So let's go into our physics. Let's turn gravity. Let's literally crank it back. Like negative 2,000, let's go negative 5,000. Look, now we're seeing flames. Maybe a little too strong. Turn it down a notch. And that's feeling like a flame now, right? Feeling like a flame. That's a real song, and I just sang it for you. Cinema4D live. So, now we've got our flame. Let's move on to our spray, shall we? I'm going to create a new solid. I'm going to call it spray. And I'm going to apply tropical particular. Now, just like before, first thing I'm going to do, I'm going to parent the position to the spray null's position. Alt-click. Drag that pick whip down here to spray null position. Fix that Z to be 0. Fix that Z. And now it is parented to the spray. We're going to crank up velocity to something like, let's go like 7,000 or something. Now that looks pretty absurd. Let's change the direction to directional. And the Y rotation, let's crank it around to where it's facing toward camera and toward that light, that lighter actually. No, we need some more particles per second. Let's do like 2,000. Now it's going pretty far. Let's turn our particle life down to maybe like, let's do the 0.15. Maybe even 0.1. Now you see our spray is getting as far as it needs to. It's getting to the lighter. Might have cranked it around too far. There we go. Now I've got some spray happening. I think our direction spread is a little too much. Let's put it maybe 13%. Let's X rotation up a bit. Down. Right about there. Now what do you say we go to rendering, motion blur, turn that on. That looks like a pretty decent spray from aerosol spray. So Now we need to combine all of them. Well, but first, notice our flame kind of comes on a little too early. Our fire comes on a little too early. As our flame, two things that I see that need to be fixed. One, our flame stays lit even while the fire is spewing out of it. That flame needs to pretty much disappear once the fire hits. So the other part is that the fire hits before the flame hits the spray. That's easy. We'll just drag this fire comp to where we feel like the fire is starting at a reasonable time. Now let's turn that fire off when we want it to, turn the flame off when we want it to turn off. I'm going to go to particles per second. I'm going to keyframe that to go down to 0 by that point. Maybe a little sooner, huh? That feels good. So now we're going to composite this stuff. And we're going to do that using Red Giant SuperComp. SuperComp is part of VFX Suite. It's amazing. It's a dockable compositing user interface that works seamlessly within After Effects. Why would you need that? Well, let me show you. I could composite it here in my comp, but the thing is, the fire, I want the fire to have heat blur behind it. I want it to blur the background behind it. I want it to also have a glow. And that would require creating some additional adjustment layers that are track matted to the fire. It would require a lot of creating new layers. Rather than doing that, I'm just going to use SuperComp. I'm going to select my plate, my fire, my flame, and my spray. Go to Effect, RGVFX, SuperComp, and it immediately creates a new solid with all of these layers in SuperComp, and it allows me to work. Now, why would I work in SuperComp? Well, first off, it's great. That's really all you need to know, is that it's great. But additionally, the SuperComp communicates upward with layers. So if I apply a glow to this bottom layer, that glow will wrap around and influence the light of the layers above it. If I apply a light wrap to a layer up here on the top, that light wrap will be influenced by all the light on all the layers underneath it, which is not something that is not the way that the After Effects comp naturally works. So let me show you why this thing is SuperComp is so great for compositing a shot like this. I'm going to start with my fire. I'm going to turn my flame and my spray assets off. I've got my fire. I'm going to change the layer type to additive, and now it's been properly blended into the scene, but I want to add some heat blur. I want to add some optical glow. I can do this manually on my own. I can go here and add a heat blur. I can turn blur up pretty big. Let's zoom in and see kind of what all this is doing. So the layer behind it is being blurred. Turn that off, turn it back on. You can see there's some blur going on behind it. If I wanted to, I could add some displacement too. I'm cranking that up real high so you can see kind of what it's doing and what it looks like. I also want to add some glow. Optical glow is pretty great. That's pretty strong. So if I put it down to 5, turn the size up to maybe 100 or 500 even. Now I've got this really nice glow happening. If I put it to 4, let's turn vibrance up to 100. That's looking pretty sweet. Now, one thing you might notice, and that's looking pretty sweet. However, check this out. I could do that if I wanted the control and I wanted to do it manually on my own, or I could just use these presets. These presets were created by the team at Red Giant, including Stu Maschwitz, who worked on Twister. So basically, if you can composite this thing yourself, or you can have a guy who worked on Twister composite it. Pretty confident what the right answer is there. Twister, always. So I'm going to go with this Explosion Core preset. That gives me this color corrected, a slightly lowered exposure. color correction. That gives me the heat blur. It gives me a core matte, which is essentially darkens the alpha behind the flame, so that brighter layers that you're compositing as an additive mode onto brighter backgrounds will pop better. You'll be able to see them better even with brighter backgrounds. And then it has an optical glow on it. So we'll just kind of go with that right out of the box. Now, one thing you might notice, the plate you'll notice is in a slightly flatter color space. It's in log color space. We shot on Arri Alexa. All the footage from the film is in log. And our colorist, Ryan McNeil at RKM Studios, obviously would prefer to work within one color space. So it'd be great if I could render these shots out in log to match the rest of the footage in my timeline. And that can be tricky when you're compositing elements that are not in log, like this flame. So SuperComp makes it super easy with this gamma setting. You can go here and specify that this footage is in Alexa log C. And you see what happened there. It changed how it is rendered. It converted it to a video color space. So if I have each of these assets specified for what color space they're in, it helps create this cohesive color space across all of the elements in the plate. But this is the coolest part. I can output it to any one of these color spaces as well. So I set my overall output gamma to Alexa log C, and it is now converting all the elements in it to one singular color space. That's pretty awesome. Now I'm going to keep working with this in the video color space because it looks better while I'm working. But I can always turn it back to the log C when I'm ready to render out my final render. So, got our fire. Let's go in here and comp our flame in. Let's go to a frame where we can see it. I'm gonna, because I'm lazy, I'm gonna use a preset. Well, first I'm going to make sure it's an additive layer. And then I could go with this big fire preset. It's a very small little element, so it's not a huge deal. But I'm gonna go with explosion core because it matches the fire that I did. Then in my spray, I'm actually gonna use this blended mist preset, which gives it a blur behind, which blurs the layer behind it. It applies a light wrap to help integrate it better, a haze to help it sink into the image a little more and not be so bold, and some diffusion. And now it's looking pretty good. I'm actually going to go ahead and put this fire on top of everything. So now if I play this back, this looks pretty great. Now, a couple things I'm going to fix. The spray, I think, could be a little more directional. I'm going to lower the direction spread even more. And then the fire, I feel like, could be going a little further and upward a little more. So I'm going to go to my fire null. I'm going to bring it up and out a little more, so it's going farther. So that looks pretty awesome right there. I actually think our spray is a little too high. Gonna bring that down a bit. Now we're looking good. So I'm gonna apply, and I'm gonna add a look to this just because I can. I often did this while I was working. I did the temporary color grade on the film. I did not do the final color grade. The final color grade was done by Ryan McNeil using looks in DaVinci Resolve. My process for this, I would go through and apply one of these LUTs that I have in here that are from, let's actually go to a more exciting frame. It's a preview. I've used looks to actually host a whole bunch of LUTs that I have from Ryan Connolly and various other places. These are Triune cinematic LUTs that Ryan Connolly sells. I like this one from Drive. I'm going to put that in there. So that looks pretty rad. So you can see SuperComp is amazing for getting amazing results super fast and super easy. Let me show you how I used it to integrate some monsters into a shot. This is a shot featuring one of our monsters called eiders. They are these eyeballs with spider legs made from chalk. Features a bunch of eiders coming down the tree. I can actually show you a final render of what it looked like. So here's kind of what I did to achieve this, how this worked. So I'm going to turn my looks, my super comp, and a bunch of my layers off. Started with this plate. Pretty simple, trees. Then I have element layer, which if I put this in draft mode, you can see what else is going on here. I've got all of my groups in element working toward this look. So Daniel Hashimoto, yeah, you've probably seen his talk already. He had this brilliant idea to hire our friend Matt Walker to create a bunch of animation cycles of these eiders of dangling, basically loopable animations. You had dangling versions of the eiders. You had slow crawls, fast crawls, some jumps, and he went and animated all of those for us. And I could bring them all in here with Element 3D so that I could actually build the scenes in After Effects, which is it's just the user interface that I personally know because I'm so dumb. You can see here we've got this slow creep animation cycle. I've got that assigned to Group 1 and Group 2, and I'll explain why in a second. Group 3, I've got the cylinder, which you can't see now. Because it is rendering out as a matte shadow. It's a cylinder. When I click matte shadow, it collects. It will basically be serving as a shadow catcher to catch shadows and ambient occlusion and contact shadows and make it look like the shadow is on the tree surface. Then I've got these dangling eiders that are. I've got ones where their hands are going downward. I've got ones where they are dangling upward, their feet are going upwards. So with all that stuff in here, I have groups 1 and 2. So I'm going to turn off groups 3 and 4 just to show you how this is all working. I've got groups 1 and 2 are both the same things. They're these slow creep eiders. And I'm using the animation engine in here. So if I go in here and I turn the animation engine off, you'll see there's more eiders. There's ones in the background and ones in the foreground. And that's because my group 1 are all back there. And then group 2 is essentially the same group, but I've moved them all forward and scattered them a little bit, going back and forward. So by turning the animation engine on, and saying the start group is group 1, the finish group is group 2, I can slide this animation knob here and it will move the eiders back and forth, back and forth. And what that's doing is basically interpolating animation between the placements of the eiders in group 1 and in group 2. And I can use that to have these working with our animation cycles of the slow creep. I now can create the illusion that these eiders are slowly walking down the tree without having to do very much animation at all. Turn group 3 on. That turns my shadow catcher back on, my Turns my shadow matte back on. And I'll show you kind of what that's doing by turning the full render on. You can see it's creating that shadow on there, and it's also occluding all of the eiders on the other side of the cylinder. So going back to the draft, I'll turn group 4 on. Group 4 is this one lone eider that is moving faster than the others that I have hand animated to kind of be our little hero eider, just scurry in foreground. And then group 5 are all of our dangling eiders. I have depth of field on in here that you can see when I turn back to full render. All right, so I want to composite these guys here into the scene. And I'll go ahead and turn off Super Comp so I can kind of start this from scratch. Additionally, with these, the background, the plate and element layer, I also have this dust layer that I have that Action VFX makes. Those guys have some amazing, awesome stock elements like dust, explosions, all kinds of stuff. So I have that in there, colorized to be red to kind of put some dust in the air. With my plate and element and my dust selected, I'll go to RGVFX, Super Comp. So that's what it looks like right off the bat. My plate, I shot Alexa log C, so I'm going to boost that there. Now that is kind of Uggs because those highlights are pretty blown out. So I'm going to go back. I'm going to keep working in Alexa log C space so that I can retain this information when I do the color grade. Now, element, I'm going to turn off the dust here. I can do a couple things. I can use some presets, etc. But actually, I'm going to go in and I'm going to start with this color correction. I'm going to show you this cool new thing that we have in VFX Suite 1.5, which allows you to push this button and it will automatically match. It will do a color matching based on the plate, based on any of the visual information behind it. And it's going to base that on the visual information behind only contained within the alpha of the layer you're applying this to. So it's looking at the information, at the visual information at the black points and white points. It's determining the average black point and white point from the information behind the eiders. And it uses that to determine how dark the darkest points in the eider should be and how bright the brightest points should be. And that looks pretty dang great. I'm going to also go in and add a reverse light wrap, which is something that you really won't see the difference there. You'll feel it more than you'll see it. Reverse light wrap is, the opposite of light wrap. If you were to erase this tree somehow from this shot, you would still get a weird rim of of tree ghost around the edges because these images are not pixel perfect. There is spillage of color and light around these individual elements, and so we want to create that illusion. I can turn that up a whole lot on these eiders. Turn the size up really big, and you start to see kind of like the reverse light wrap around it that it's creating. Turn that off and back on. It's almost like a drop shadow kind of a thing. It's just this, gross bleed. I'm going to keep it at, edit settings. And then the last thing, I'll go in here and I'll probably, that's good. Now here's a fun trick that I like to do. I'm going to go to my plate and I'm actually going to add optical glow there. Because if I add a glow, like I told you before, if you add, and that looks gross, I'm going to fix this, but if you, like I said before, if I add a glow to this layer below, that glow will wrap around any of these layers above it. So this is a nice, really quick way to integrate the things, to integrate these elements into the scene is to add an optical, I like adding an optical glow to my plate, and I turn highlights only, up to let's do 75. Let's maybe go higher, maybe 85. So it's only glowing the highlights of the image. I'm going to turn the size to like 500 and turn the amount down to like 3, 2. Let's maybe go highlights only up to 90. Maybe size down to 200. Gosh, maybe 100. And it creates this kind of haze in the air that is wrapping around the eiders. Actually looking pretty cool. Here it is without. Here it is with. I like it. It creates this kind of halation almost. I just used that term wrong, but who cares? It's my tutorial. I'll use whatever words I want. So now these wide dust particles, I'm going to integrate them using one of these presets here. I'm going to go maybe try backlit smoke. Does that make it? Makes it a little too smoky and misty and weird. Let's maybe try hazy integration. It's a little weird. I mean, it's kind of cool, but also kind of not. Like maybe, what if I add color correction and I auto match it? Ooh, that's a lot of red. That's pretty cool. Then maybe I'll add some haze. It's an awful lot of stuff happening, but it's kind of cool. Maybe too much? Could always bump the opacity down to maybe like 50. And then I have this overall look that I apply to it at the end. Yeah, that red, that's too much going on with these wide particles. It's actually, there it is as is. Let's maybe apply some light smoke. Maybe that's the look for it. This is how I use SuperComp to composite all the monsters into darker colors.
Hey, Seth. That's some great stuff.
Hey, man.
That is some really great stuff, man. To actually address some of the comments in the early part of your presentation, people are like, wow, there's a whole bunch of After Effects going on in here, and Red Giant. Well, if you didn't know, Maxon and Red Giant merged, officially closed up in January. So we got to represent all the products that are out there on the good old NAB stream. So a couple of questions is one of the main things I would love to know too is you're a filmmaker, right? How did you start diving into creating post effects for yourself? How did you get into that side of it?
I've always, as a kid, I grew up like breaking my parents' video cameras, trying to do audacious stuff that I would see in movies. And so like visual effects were always a fundamental part of the process for me, of filmmaking itself. You know, like when whenever I talk about VFX from a stage or whenever I've taught a class before, I like to talk about how one of the first, there's a film that was created in Thomas Edison's laboratory called The Execution of Mary, Queen of Scots. It was made for the kinetoscope, and it's simple. It's a bunch of people in costume. There's an executioner with an axe. A woman puts her head down on the stump. The axe raises. You see a blatant jump cut, and the axe comes down, and the dummy's head is cut off. And at the time, you know, this was a very shocking effect. And what's interesting to me is that it's often referred to as the first visual effect ever captured on film. But it was also the first time anyone ever hired professional actors and put them in costume to appear on film. So, which is a pretty fundamental part of cinema. And so I love that because the truth is, like, visual effects are a fundamental part of filmmaking. And if you And if you're not interested in visual effects, if you don't have a respect for them and you don't have at least a basic fundamental understanding of them, I think that it immediately sets you back several paces as a director, as a writer, as a whatever. But to get to the practical parts, I learned, I got individual, like I was into visual effects before I knew how to do it the right way, and I would actually still put myself there. But like anybody else who you'll ask this question, like about 90% of the people who ask this question, I learned from watching Andrew Kramer tutorials. In fact, I watched my first Andrew Kramer tutorial and opened After Effects for the first time. And then 1 year later, was contacted by Arn Rabinowitz at Red Giant about making a tutorial for a video that I put on Vimeo featuring Tropical Particular and After Effects. And I'm saying that not to say that I'm so great. I say that because to talk about how great of a teacher Andrew Kramer is, and that I was able to get a fundamental understanding of After Effects to where I could spend a year breaking it and trying things and getting results enough to be able to get the attention of a company that I now have worked for full time for 8 years.
Nice. But it sounds though that the visual effects was an integral part of your storytelling from the very beginning, though.
I mean, it's an integral part of the movies I grew up watching. Robert Zemeckis is my favorite director. Who Framed Roger Rabbit is one of my favorite movies of all time, and I love that movie because it is much harder than it ever needed to be. It did not need to be that difficult of a movie to make and complex of a movie to make, but they intentionally made it complicated for themselves for the betterment of the final product. And so it's a fascinating movie to watch, not just from a story standpoint, but from a technical standpoint of how are these animated characters carrying live action guns through a scene. The story behind the story is just as fascinating and just as interesting. And so, I grew up watching Robert Zemeckis movies, Steven Spielberg films, well through the 90s where, it's great about working with Stu Maschwitz is now I get to get all the inside baseball of all the ILM movies he worked on in the 90s that I watched and was inspired by.
And some people get a little taste of Stu tomorrow on the stream. Somebody was asking what techniques you use for rotoscoping.
The most effective technique I've found is asking someone else to do it. Rotoscoping. I will start by seeing if I can do it with a mask. And if I can't do it with a mask, I'll try to see if I can do it with a Luma key. And if I can't do it with a Luma key, I'll see if I can do it with a roto brush. And if I can't do it with roto brush, I'll post something on social media asking if someone wants to roto something for me for free software. And when everyone says no, I find a new plate and try something else. That's what I've never learned. I didn't ever get a chance to fully dive into Mocha. If Harry Frank is still in this thread, I'm not looking at the YouTube thread right now, but I'm sure he has a lot to say because he's the one I usually would ask to do it. Any of the most impressive roto shots in any of my shorts were all done by Harry. The best thing I can say is ask Harry Frank. That's the most effective tool for. After that,
we'll pass out Harry's email after the presentation, or what is
yes, he'll really appreciate that.
I'm sure he'll love that. He says he's there and he has rotoed for you. There's a question on the. Is there a limit on the comp size in Super Comp?
I believe that we've tested it up to 8K. I think. I believe. We've tested it up to 8K. It just depends on your driver. It depends on the specs of your machine. I don't think I've tested it larger than 4K personally, but from what I hear, 8K is what we've tested it up to at the company officially.
Someone was asking if you think that you need something as robust as Super Comp when you're doing motion graphic types of animations or pieces, or do you think that default AE tools would suffice? So what can you bring? What brings Super Comp bring to the table for motion graphics types of work?
That's an excellent question, and I think it's all about. My motion graphics approach is normally an exploratory and experimental one. I rarely am coming at it with a plan and a intent. So for me, SuperComp is just one more awesome tool that I can throw into the lab and try stuff with. But I can say it is really, really fantastic for organically blending. It's the subtle, nuanced things like the way edges blend with each other, the way light wraps around objects. And it's creating the look of happy organic accidents. That's what SuperComp is really, really good at getting you those kinds of results. And if you're looking for that kind of a look in whatever motion design piece you're making, I'd say it's excellent. If you're going for a clean approach, nothing I make is generally clean, so I actually personally couldn't tell you what the benefit of it would be. But I know that if you're looking for if you're looking for something to help you find new results through experimentation, SuperComp's great for motion design. And if you're looking to make something that feels organic and a little bit more authentic and real feeling and messy in it, I don't mean that in a negative term, but then I'd say SuperComp's a really cool place to go to.
Awesome. Now that we've merged as two companies, is there anything in particular? Is there anything in particular you'd like to see in terms of integration or the types of tools that could come out from the collaboration of our development teams? What types of tools would you like to see?
That's a tricky question to answer.
Without getting in trouble?
Without getting in trouble, yeah. I would say that the things that I think of first are being talked about already. So that already could probably get me in trouble.
Well, I think that's good news. But just basically tell people the things that you'd really like to see happen are already being discussed. So that's the greatest answer right there.
Yeah, honestly, the best answer I can give is the people that I work with are people like you, exactly like you and me, who want certain things and constantly think, man, it'd be easier or cooler if this did this and this did that. That's what all the people I work with are like. And so the conversations we're having are just like the conversations you have with your friends or yourself, except we have the power to go and try things and make it happen. So yeah, it's definitely exciting times.
Yeah, it is very exciting times. So there was another question about your getting started. We've heard you've been into filmmaking and visual effects from a very young age. When you dove into starting to do some of your own effects, especially within After Effects and the digital tools, people want to know how long it took you to really master them. I probably could answer for you. You never feel like you're a master of any of these tools, but when did you feel comfortable and feel like you could accomplish the types of work that you're doing now?
If I could let's see, I'm thinking maybe a year from now, I will have finally felt that way, but ask me in a year. No, man, you were right. You never feel like a master. I will say I have that feeling about once a year. And it usually happens when I hit some breakthrough. It usually happens when I learn something that makes me think I should have already known this, and because this would have made so many things that I've been doing easier for years. Yeah, I think when you feel like you've mastered everything, you're probably screwed for life, because it means that you actually know very little. I try to constantly be learning new things and getting better. And when you work with people like Daniel Hashimoto, that's not difficult. It's very easy to
absolutely
find out and learn what you don't know. But I would say, interestingly enough, I was talking to Ryan Connolly about this the other day. We both were laughing about how it feels like the year 2009 to 2010 felt longer than all the years since then. Like they felt like they lasted longer. And like that was the year where, like in 2009, I opened up After Effects. I had been using Apple Motion for a year prior to that, and then prior to that, any visual effects I did were all in my Final Cut Pro timeline. So opening After Effects in 2009, I really feel like that year in my memory lasted like 10 years because I learned so much in that introductory time, and I learned what plugins were important, what plugins would help you like get further. I learned what all of Andrew Kramer's go-tos were, and all of his free downloadable scripts and presets were. And so, that around 2010, like that was my first feeling of mastery. And then I had it again in 2011 when I made Plot Device with Arnold Rabinowitz, and I learned a ton about compositing on that. And then I learned it again in 2012 and 2013. I think once every year I have a moment of like, oh, now I know how to use this. So that was a long-winded way of saying I have no idea.
So anything you can tell us about any of the film ideas or possible productions in the future? Any genre directions? Anything, brewing in your head for the next Red Giant film?
I have no idea.
Okay.
What do you think, Paul? What do you want to do next?
I've got tons of ideas. We'll talk after the show.
Thank God, because I have none.
All right, so staying on theme with Matthias and the mograph guys, I have to ask, favorite movie?
Favorite movie is Jurassic Park. I walked into that movie a boy and walked out a man. And I took every family member I had one at a time to go see it so that I could see it as many times as humanly possible. And I realized around the 13th time I was watching it, I was watching the person I brought more than I was watching the movie itself, and kind of taking credit for their entertainment experience. And it's like that feeling that I've been chasing ever since. Wow. So yeah, Jurassic Park.
Excellent. A favorite book or a recent book you've read?
My friend Brad Montague has a new book called Becoming Better Grown-Ups. That's really great. I loved Paul Hirsch's book a long time ago in A Cutting Room Far, Far Away. That's exactly my favorite kind of book, where it's an old Hollywood player telling a whole bunch of anecdotes about all of my heroes. And then Stillness is the Key by Ron Halliday was a really, really great book. Brian Beam recommended that book to me, and I've read it about twice since.
Excellent. Excellent. Well, I can't thank you enough for doing this for us and getting the presentation up here. The comments that I've been watching throughout your presentation have been incredible. Flames, it just was a great presentation. I'm going to actually go back and watch it a couple of times because I didn't catch it all. It moved too fast for me.
Thanks, buddy.
It was really, really, really great. It was so great to have you on here, and we're so thrilled to have you and Hashi and Stu join the crew and bring the kind of content you guys are putting together for all of us. It's incredible. And thanks for incorporating Cinema4D into the latest film. Folks, if you haven't seen Darker Colors, you got to go watch it. It's a great film. It really is a great film.
Thanks,
I know that was a great piece. I know that was a passion piece for you.
Yeah.
Anyway, so that wraps up the rest of the day. Tomorrow we're going to kick off again at 8:30 with Nydia Diaz. We've got a great lineup. Like I mentioned, Stu Maschwitz is going to be on, Joey Camacho, EJ Hassenfratz from iDesign is going to be on, and we close out the entire show with Beeple, who's going to be doing some live every days. That should be always entertaining. We do not have that on delay, so viewer be warned. He's very colorful in his language, but it was always entertaining. But yeah, we'll kick off our last day. Sadly enough, our last day. And I want to thank our sponsors once again. Our big sponsors: Dell, NVIDIA, Unreal, HP. For supporting the stream, supporting the community. We've got some great prizes. Again, get on there and enter the raffle. We will be pulling those names probably Friday and announcing next week. And thank you once again to Dave and Matt over at mograph.com for assisting us in this broadcast. Invaluable. incredibly invaluable. Thank you to Matthias, who has been taking the lead on this, and Rick for popping in, Thanasis for popping in, Chris for popping in occasionally to answer some technical questions, have a little fun. And I think that's all I got for the rest of the day, but we'll definitely see you all tomorrow. Great lineup tomorrow. Great lineup all week, actually. Incredible presenters. But thank you all for watching, and please come back tomorrow. We look forward to seeing you.
waves with amazing deals and fast and knowledgeable customer service.
Swim on in for incredible deals on software and plugins at Toolfarm.
When's the last time something moved you? Was it a flash of beauty? A twist of phrase? A bit of brilliance that blew your mind? What if you could move people like that? And what if you could do it with shapes, sounds, design, and movement? When it comes to motion design, we believe everyone deserves the chance to move from novice to superstar. So we've created an online place for that to happen, so no matter where you are, we're there too. We're opening up worlds of possibilities for our students, and we're kind of obsessed with doing it well. Our teachers aren't just skilled working professionals. They're also the top motion design experts in the industry. Our critiques aren't vague and generic. They're valuable insights about your work. Our classes aren't easy. They are intense and effective. A tidal wave of knowledge. And our students aren't faceless usernames watching talking head instructors. We're a tight-knit community of highly driven learners, filled with global collaboration, inspiration, opportunities, and plenty of fun characters. At School of Motion, we take a full art education, strip it down to the essentials, and supercharge it with real-world grit. And we're equipping our students to do amazing things for some of the best brands and studios out there. In fact, this thing you're watching right now, and even this, was made by School of Motion alumni. Now it's your turn to create something truly moving. And we're ready to help you do it. Because the things that move you forward move us too. School of Motion. We're not just a school. We're a movement.
idea about freelance is that it's not an absolute answer for the entirety of your career. You are an artist. You have a lot of the leverage right now. There aren't enough of us out there for the work to be done. Go to a shop that gets you access to those amazing jobs and those amazing clients and those amazing artists to the left and right that you can build up your reputation with. Going to a shop, 2 years, get everything you can out of it. Be aware of it while you're doing it, right? They're aware that they're taking something from you. You should be aware that there's something for you to take back as well. Freelance for as long as you see fit. Maybe go back to a shop, go to a brand, start your own place. There's more to the continuum other than I work for a shop and I give up my life for a salary and an insurance, or I'm a freelancer and I'm going to be 90% business and 10% art, right? Like, I think that was one great thing about Camp Mograph that exposed us, is being in a room of 70 people trying to hash out a career, figuring out what to do with either no experience or tons of experience. And it's different at every time in your career too.